Data-driven decision-making is at the heart of so much in the world right now. We're making decisions not just for us now, but for future generations as well.
The connection to data science is becoming more and more important to the work. The work has been going on for the last 25 years.
So what really drives us at WiDS is that we want diversity at the decision table here. And women absolutely need to be there.
To me, a healthy data science community is one that embraces diversity.
We started WiDS with a conference at Stanford University in 2015 with three main goals that haven't really changed. First, to inspire women to join or stay in the field of data science. Second, to educate everyone by highlighting fantastic women and their technical work. And third, to support women around the world.
And wow, did we hit a nerve we didn't even know existed. Fast forward to 2022, and we have 200 regional events worldwide in more than 60 countries. And it just keeps growing year after year.
Last year, we were with all of you virtually. We had a 24-hour around-the-world event, which was very exciting. And so despite the pandemic, we got together and we created this global community. We had speakers from over 25 different countries, and it was wonderful.
And one silver lining in an otherwise tough year in 2021 is that attendees to WiDS regional events could be from anywhere in the world. We also saw really interesting collaborations, WiDS ambassadors coming together to host events in Africa, Saudi Arabia, Colombia, and Central and Eastern Europe.
One of the things I really love about WiDS is hosting the WiDS podcast. And we now have listeners from over 160 countries, which is just incredible, and many different guests. And I'm also really excited to announce that we'll soon have a co-host of the WiDS podcast, Cindy Orozco.
We also had amazing participation in the WiDS Datathon this year. Over 4,000 registrants in the Datathon from over 90 countries participating in a challenge related to climate change. And a big shout out to all the WiDS ambassadors who held workshops. We had over 40 workshops across the world.
I hope we also lift our heads above the horizon and think more than just about this moment in time, and think about the goals that we have for our young women and our young girls who'll be leading the next generation.
With the WiDS Education Outreach Program, which is focused on secondary schools, we've delivered materials to collaborators in over 50 countries around the world. We've had a great year despite all the challenges in the schools with COVID. We've had pilots everywhere from Covada, India, to New Haven, Connecticut, to a refugee camp in Jordan and beyond.
New last year were the WiDS workshops, where instructors provided dozens of workshops that were attended by thousands of attendees worldwide, online.
These WiDS initiatives would not be possible without the generous support from our sponsors, the global visionaries, the innovation leaders, and everyone at Stanford.
One thing we've been very excited about this last year is working on what we call the WiDS Academy. We got interested in understanding better what the barriers were for young women and for minorities to enter this exciting field, and how we could possibly remove those barriers, and what sort of programs could we put in place with partners all over the world to help.
Our ultimate aim with WiDS is to increase the percentage of women in data science, to achieve at least 30% women across all domains and at all levels, from students to senior leaders, by the year 2030. And we call this 30 by 30. We believe 30% is a tipping point. That's when women truly believe that they are part of a group and they can contribute and have great impact. And we hope that you join us all in reaching this big goal.
For now, though, whether you're at Stanford or at one of the regional events worldwide or just in your living room, you are a part of the WiDS worldwide movement.
Welcome to WiDS!
And welcome to the 7th WiDS conference, broadcast here from Stanford University. Welcome to all of you here in the audience. Welcome to the people on Hopin online. They've actually been going already for 2 hours. And they've had workshops and they've had interviews with people, and it's been great. There have been many, many people chiming in. And welcome to those of you on the live stream, wherever you are in the world. I'm Margot Garrison. I'm going to be your host today. I'm a professor here at Stanford, and I'm co-founder and co-director of Women in Data Science, and I'm so, so happy to be here. The last time we were together like this was just 2 days before Stanford closed down for COVID. And for many of us in the room, we're the first conference back now that we've opened up again, and I cannot tell you how good that feels. But it's been tumultuous these last 2 years, and it's been tough. And for many of our WiDS participants and ambassadors and our WiDS community, it's been incredibly hard these last 2 years, and still. And we think about Lebanon, we think about Afghanistan, and of course now we think about Ukraine. And you know, in times like that, you often feel there is so much you cannot do. You know, we cannot stop COVID from spreading just by ourselves. We cannot stop conflicts from escalating or wars from starting. But today is about what we can do. And what we can do is build a community. What we can do is build a community across boundaries. What we can do is inspire each other and learn from each other and support each other and connect with each other. And I'm just so happy that we've had WiDS also through these last years and now. And I can't tell you how grateful I've been for this amazing community. So today is about celebrating. It's about celebrating our speakers. It's about celebrating all of you, our participants. And today is about connection. And so let's start with that. So if you are on the live stream, connect by tweeting something. #WiDS2022. If you're on Hopin, now write something in the chat to say, hey, I'm Margot, and I'm calling in from Stanford University. If you're here, look around you now. Find someone you don't know yet, right now. Find someone you don't know yet. Say hi. Right. Give them an elbow bump or a fist bump. Okay? Wonderful. So today we see how well this is going. Right, thank you. So today is about this connection. And today we're strengthening and expanding our community. That's what we're about today. So despite the fact that it is hard, let's celebrate. And let's move forward and build this community that we so need. And I'm very excited about the program for today. I'm also very excited about the diversity in the room today. We have people from over 160 different organizations. This morning I walked around and there were people who've flown in from all over the United States, from Canada, from Europe, from Lima, Peru, from Medellin, Colombia. There's a high school group from San Francisco, which is super exciting. And we have so much in our program. We've got lovely speakers, panelists, interludes, and just a couple of little household items. Get your program, look at the bios of all the speakers. Every time you see a speaker announced, look up some information. We won't have very long introductions. That's what this booklet is for. And I will talk to you in between. But now we're ready for our first speaker. I'm so thankful that today we have Dean Deborah Setz from the School of Humanities and Sciences here on campus, and a dear friend and colleague of mine to give the opening address. So again, welcome to WiDS and welcome Deborah to the stage and opening our conference.
Okay. Well, welcome. It's wonderful to see so many women in the room and some men, and to know this is a global event and is linked to regional events around the world. So I'm welcome to all of you in the room and to all of you joining in other formats. I want to thank Margot, Karen, and Judy for inviting me to speak, and more importantly, for launching in 2015 this series of conferences, networking, datathons, podcasts, and mentoring opportunities. It's really helped to move the needle, and I'm grateful for what you've done and very inspired by it. So data science is transforming every aspect of our lives, but girls and women still remain too much out of the loop. Too few women are involved in the design and creation of new technology. And while there's been progress, and this conference itself has contributed to that progress, we have a lot further to go. I like the 30 by 30. We are less than 20 in 2022. That's in the United States, and around the globe, the numbers are even lower. So data science still is too much of a boys' clubhouse. Now, as a dean and a political philosopher, I care deeply about the ways that women still lag behind men on almost every important social indicator and in every country in the world. Tomorrow is International Women's Day, and it's an occasion to inspire us and to remind us that we still have more work to do, 30 by 30. But why is this work important? I hope you'll indulge me for a few minutes as I step back and ask what might seem like an obvious question, but sometimes the obvious questions are worth asking. Why exactly does the identity of researchers and practitioners matter? Why should we care so much about the number of women in data science? Shouldn't we just care about the substance of the work that data scientists produce? Well, I'm going to give you 4 reasons why this work is so important. So, number 1, it still remains true in 2022 that gender, race, and social class shape the life chances of children. In the home, many parents still think of computer science as a male field, and in high schools across the nation, a repeated pattern plays out. Boys increase their confidence, their status, and their expertise in computing, while in girls, we find a decline in interest and confidence. And I should know, I was one of those girls. I was a first-generation college student, and I loved math and logic. I went to graduate school at MIT to study the philosophy of mathematics, and I took a lot of graduate courses in math. I'm old, and when I was at MIT, there were no women in my cohort and no women on the faculty. In my graduate math classes, there were high school students and junior high school students, boys, who got the answers faster than I did. And I felt really discouraged. And against the advice of my mentors, I decided to opt for ethics and political philosophy, fields I also loved, where I thought, well, maybe I'm more talented. Now, I don't regret my path, but I think back to the lack of confidence I felt, and I wonder how many other women still feel like they don't belong. In a different context, the economist Raj Chetty has talked about the 1 million missing Einsteins, those children born into poverty who never have the chance to explore science and innovation. So I want to call out today the 1 million missing Marie Curies. We need everyone to contribute and flourish. Second reason that women in data science is important, the presence of diverse people changes the kinds of questions that are asked. So here's an example from economics. In development economics, it was assumed that giving aid to male heads of households was the most efficient way, right, to improve the lives of families. But when women entered the field, they questioned that assumption. And because of their research, we now know that giving aid to men, a lot of that aid is spent on alcohol and cigarettes and things outside the family, and that if you want to benefit children, you should give the aid to women. But nobody had asked that question before women entered the field. In this light, I love the topics of this conference. Using data to document human rights abuses, using data to advance equity, using data to empower health. Of course, men can ask these questions too. The capability to ask questions isn't encoded in our genes, but experience matters and it shapes the kinds of questions and the interests and commitments we have. Third, and related, inclusion is needed to expose bias. Everybody has biases. All of us have biases, and in-groups tend to reinforce those biases. Bias was certainly at work in the economics development example, right? The bias that assumed that if you give money to the male head of household, they'll distribute it and everybody will benefit. And there are many other examples of bias. When test dummies were used to determine vehicle safety, the dummies were given the anatomy of a typical man. So it's really important that rather than always focus on the individual researcher, we need to understand knowledge and research as a social product. When there are many perspectives at the table, bias is corrected. Cross-cutting identities are one of the reasons why diverse groups perform better at solving problems than homogeneous groups. And the exposure of bias is critically important because the kind of data that's collected and how it is used is tremendously important and will have differential effects on social groups. From the use of data in elections, in health, in punishment, and with respect to the future of work, we need many voices in the clubhouse. The identity of researchers affects the kind of research they do, the biases they bring, and the questions that they ask. And fourth and finally, although it's true that all of us can learn from everyone, it's also true that social disadvantage shapes women's experience and leads them to wonder, as I did, whether they fit in classrooms and workplaces dominated by men. Having women role models and mentors is important for pressing back on stereotypes and creating an inclusive community. As I said, I was the only woman in my graduate math classes, and I never had a female professor. So, to wrap up this, we should be clear. The extent to which data science remains a boys' clubhouse is bad for all of us. Bad for the missing Madame Curies, bad for the questions we're not asking, but we should, bad for the social consequences of data science research that could be better if biases were caught and corrected, and bad for the persistence of women in data science. Our world is on fire in so many ways with so many urgent problems. Data science has brought many good things to us and created incredible opportunities, but it's also handed us a bunch of problems, from issues of privacy to algorithms that perpetuate bias to the large and powerful monopolies that structure so much of our shopping, but not only our shopping, our health, and our democracy. We can do better, and with you, I believe we can. Thank you, and thank you for everything you do. Stay.
Thank you so much, Deborah. And because we still have a little bit of time, I wanted to ask you something. You've been the dean, and I know you're a very strong supporter of students. And we have a lot of people in the audience today who are studying or just starting their career. What advice do you have for them?
I have lots of advice, but
I know that. That's why I'm asking the question.
People say, and it becomes a kind of a throwaway line, like follow what you love. But actually, there isn't anything more powerful than finding something that speaks to you and finding a place you can make your mark and persisting. And so just don't get discouraged. Don't give up. Find a community. And then for all of us who are here and occupy relatively privileged positions as being here, use what you learn to make the world a better place.
Was there something that, or is there something that now you think about you wish you'd known when you were in your early 20s, which is only 2 years ago?
You're right. So, I remember my story about leaving the philosophy of mathematics. I remember telling this to the social psychologist, Stanford faculty member Claude Steele, who works on stereotypes, and he said, that's such a women's reaction. That's, boys, when they, or men, when they are in that situation, they're like these 10-year-olds. What do they really know? They're like, yeah, they got the problem right this time, but I'm, so much better than they are. And I wish I had known that my doubts were, I could have persisted. And again, I don't regret. I love my life and I love what I do, but I do regret that I didn't have anybody to say to me, that's a lot of, don't be afraid of a 10-year-old boy who,
Write that down. Thank you so much. Thank you so much, Deborah. Deborah Setz, Dean of the School of Humanities and Sciences at Stanford. And what you see right now on screen is a drawing by our in-house cartoonist and illustrator and wonderful friend, Liza Donnelly. Liza, please stand up for a second. You will be seeing her drawings throughout the day. You can also see them in the New Yorker and many other places where she publishes. And you've been with us now for how many conferences? 4? Yeah, so this is your 6th conferences or 5th conference. Anyway, I lost track, but it's wonderful to have her here. And I still have a minute before the next speaker, so I just wanted to take this opportunity also to thank people who made this day possible, because it's not just me, I'm on stage, and that's both a blessing and a curse. I love it though, it's fine. But this conference was put together by so many people, and I wanted to thank my co-directors, Judy and Karen. They're somewhere here in the audience. Are you here, Judy? Of course. They left. And I want to thank the core team of Shelley and Valerie and Marissa and Charlene helping us. And I want to thank Tamara, who's sitting there doing the hop-in, and the wonderful Steph from conferences at Stanford with her team, with Gordon and Dawn and Mike and Mauricio and Damon and Harry and so many other people who are helping us today. Photographer Steve, who's sitting right here. If you want a beautiful picture taken of yourself today, then just ask him. But now it's time for our first keynote, and I'm very excited to announce Cecilia Aragon. She is so much. She's a professor at the University of Washington, a researcher in data science, an author who's just coming out with a new book that she will talk about today, and an aerobatic pilot. And she's here. Cecilia, welcome to stage, and thanks so much for coming.
everyone. Are you as excited to be here as I am? Woo! Thank you so much, Margot, for that lovely introduction, and thank you all for having me here. I have to say, I've been a fan of this conference ever since I heard of it, and I really hope that someday I could come. And thanks to Margot, I'm here. So I think this work, everything that Deborah Zatz said, is so important, and thank you for saying that, because now I don't have to repeat it, because everything you said is, I'm going to tell sort of an emotional and personal story that's based on all the facts that Deborah brought up. So I want to start by asking the question, when you talk about data science, are rigorous and human-centered opposites? If something is focused on the human, does that make it soft, weak, not as technical? I have to admit that I used to believe this, because I had a very traditional computer science and math and statistics education. So I started out working in industry. I used machine learning and statistics to analyze what were considered very large data sets at the time. As a matter of fact, we even had to write our own protocols to transfer large volumes of data efficiently, because TCP packets had too high overhead. I remember crawling through the ceiling helping to pull cables so that we could do our own data transfer, because the existing wiring wasn't fast enough. All right, then around 2000, I moved to government labs in NASA, and I focused on analyzing scientific data, such as airflow across aircraft and spacecraft, computational fluid dynamics, astrophysics, and supernova data. And I admit that perhaps because I didn't like being stereotyped, that I tried to present myself as a hardcore engineer. If the software was hard to write, it should be hard to use. But the more I worked in data science, the more I became convinced that it was the human-centered piece that was the most important, and actually the most difficult. So I transitioned around 2010 into academia to work on human-centered data science, which is a data science that takes into account its societal context. So I'm going to talk about human-centered data science today, but first, I want to take a step back. I'm going to start out by showing you some truly embarrassing pictures of my childhood. All right, notice also how I wasn't smiling in any of these pictures. The reason I show this is because when I was an insecure and nervous graduate student, I used to hear talks by various luminaries in the field, and I always thought, wow, these people are so much smarter than me. I could never do what they do. They must have been born brilliant and successful. Unlike me, total failure, total imposter, never had confidence in myself. And so one of the things that I've asked ever since then is, why did I lack confidence? Why do so many of my students that I talk to today, brilliant young women, people of color, why do they lack confidence after growing up here in the US? And I think about my own childhood. So I was a first-generation Latina. I grew up in a small town in the Midwest, and both my parents spoke with thick accents. As a result, I was bullied by my classmates and dismissed by many of my teachers. I remember once writing an essay that I was particularly proud of, and my teacher accused me of plagiarism. She said, "Someone like you couldn't possibly know all this advanced vocabulary." Now, this teacher didn't intend to be cruel. I'm sure she thought she was helping me, you know? But she's part of the system that teaches us that we should follow stereotypes. She was a cog in a wheel, and it's a wheel that's still turning today unless we stop it. And it's conferences like this that are doing their bit to change the system and to stop this wheel from turning. So it's because of those childhood experiences that I grew up fearful and terrified and timid, and I doubted my own abilities. That's what imposter syndrome is. If you have it, it's not that you are not good enough or that you're not interested in science. It's that your society, the stereotypes have shaped you, perhaps unconsciously, into believing something about yourself that is not true. So one of the things that I love about math is that for me as a child, it was my solace. If I got it right, none of those teachers could mark me down. I got 100% in math. Hey, I couldn't have copied because it was the best score. And I want to tell you, there is nothing like standing in front of a room of people who think little of you, and you silence them with your love of math. It's kind of like a magic trick that way. So, all right, here's the 30-second view of my career. So I worked hard, I earned scholarships, but I didn't believe in myself. So that was the problem. I dropped out of my PhD program at Berkeley. But I do want you to notice that I have this little gap in my data science career in the 80s and 90s where I became a pilot. And not an airline pilot, but someone who flew airplanes upside down. So why was this important? Well, it turned out that the effects of my upbringing were so devastating that succeeding in school and a career was scarier than facing death in an airplane. That's the impact these systemic biases have on children growing up, have on girls growing up. So I want you to think about that effect for a moment. If any of you have ever felt an emotional block against your career or data science or have wondered, is this really the right place for me? It's not your lack of ability. It's not your lack of interest. It's the combined weight of these societal expectations and stereotypes. I had to face my deepest fears in order to finish my PhD in computer science. And I show this slide because I want you all to see that it wasn't a smooth road to where I am today. I wasn't born successful or brilliant or whatever. Maybe I'm not even now. But I almost, as Deborah was saying, I almost changed my career. I almost thought, you know, this isn't right for me. There's so many other things I love. I could do something more traditionally female, and I would be more accepted. I would be more at home. I wouldn't have to risk, you know, death or humiliation. So, and I certainly had professors who thought that was true. I had one professor in my PhD program who said, women don't have the intellectual capacity for computer science. Yeah, imagine how that makes a young, insecure grad student feel. So I don't want anybody else to ever think you might not be good enough to do this important work. So I'm speaking to everybody here who has ever doubted themselves. It's not you, all right? The field needs you. Data science needs diverse viewpoints, as Deborah brought up, as many brilliant researchers have brought up, and I wish I had time to share some of the marvelous work that's been done by so many people in this field. But for now, I just want to let you know, I want you to think to yourself, it is possible to succeed in your career and raise a family and have hobbies you love. Don't let anyone tell you you can't. Because I gave birth to 2 wonderful children who are now in their 20s, and they're amazing. They're really amazing human beings. I'm still married to my husband of 37 years, and I've had a great career. So it is all possible. And I'm also the only, my husband got sick, and I am the primary breadwinner in the family. So it's not like anybody gave me money to do this. I earned it all, and you can do it all too. All right, but now let's get to the important piece, human-centered data science. So I hope to convince you of 3 points. That thinking about human issues in data science is necessary, and then that's, I think, more obvious. But then number 2 is that human-centered approaches to data science make the technical work stronger. This is something that I have lots of great examples of. I'm going to show you one from my own work. And finally, number 3, data science is human-centered, whether we believe it or not. So first of all, I think it's well known because of various ethical concerns that we really need to think about the human issues. But I think there's also anyone who has dealt with something on a mundane level, anybody who's dealt with voicemail jail or any automated systems has this intuitive grasp that machine learning and AI have significant flaws. You know, we studied this in a paper we wrote on folk labeling. We noted how many times automated systems didn't work the way their designers intended them to work, and humans had to fill in the gaps. This happens in every automated system. Now, sometimes these negative consequences of these gaps are far greater. In her book, Automating Inequality, Virginia Eubanks described an attempt to privatize and automate Indiana's welfare eligibility program in 2006. It was a disaster. Thousands of people lost benefits. They received automated notices. Sick people lost medication. Some even died. A 6-year-old girl with cerebral palsy was denied Medicaid benefits for failure to cooperate because she didn't respond to a notice. And there was no way for her parents to contact a human to rectify the automated system. So this was billed as an attempt to save taxpayer dollars and prevent fraud. But not only did it cause a huge amount of human suffering, it ended up costing the state far more than it saved. There were so many lawsuits. Justice sometimes requires an ability to bend the rules. By removing human discretion from frontline social servants and moving it instead to private contractors, the Indiana experiment supercharged discrimination. All right. In my 30 years of experience, I've found human-centeredness in data science makes the technical work a lot stronger. So here is one of many examples from my own work. So a really fun part about being a data scientist is you get to work on so many cool projects. I could talk for an hour or 2 about this really cool project. I was hired to solve a big data problem in this astrophysics project in 2005. Now, this project was working on studying the largest supernova, the largest thermonuclear explosions in the universe, supernova, exploding stars, to measure the expansion rate of the universe. I mean, how cool is this? And when they brought me in, 2 other software groups had tried and failed to solve their problem. And then they brought me in, no pressure. So, all right. I ended up making 4 major contributions to the software, and the first 2 are purely technical, and they involve statistical machine learning, support vector machines, and boosted decision trees, and Fourier contour analysis. And the second 2 are more social, having to do with successful collaboration building and solving issues using cross-cultural scientific building cross-cultural scientific teams. But all 4 of these were discovered through a human-centered ethnographic approach. And all 4 contributed to the ultimate success of the science. So due to time constraints, I'm just going to talk about example 2, a novel image processing technique that led to substantial improvements in supernova image classification. So we had to process over 600,000 images per night. And in 2005, that was considered a lot. And we had to see which of these blobs of white pixels were potential supernova. So I'm not going to explain the details here because of time constraints. But suffice it to say, the top row is there's a galaxy, and then you subtract the middle image, and then you get this nice round star, which is a supernova. And that's how you find it. But on the bottom, you have a star that was close to the edge of the image. And as a result, it was misregistered. There was a registration error. And so you get this, what's called a bad subtraction, which is this funny C-shaped thing, not a star. And it turned out that a vast majority of these were bad subtractions. But the scientists didn't know enough about image processing or data science at the time to know how to deal with the problem. And so the other 2 software groups were not told what to do. But by sitting with the scientists and observing them in their daily work, while they were saying, Cecilia, why don't you write scripts? You know, why are you just sitting here learning about the project? Well, it turns out that human-centered approach is very powerful. So I said, well, there's an existing image processing technique known as Fourier contour descriptor analysis, and I could modify it so it would work here, and it could automatically detect the shape of the supernova candidate. So I implemented, but I should first say, well, I implemented 2 new features, all right, that you could use the object contour eccentricity and the object contour irregularity. But I want to say, why was this a human-centered approach? Well, it's because as soon as I mentioned the word Fourier, the scientists I was in this room with a bunch of physicists, about 6 or 7 men, and then there was me, and not only was I female, I was a computer scientist. 2 black marks. And they said, we are already taking up the full amount of time on for our computation. We cannot add Fourier analysis to our pipeline. You are wrong. And I said, well, first of all, I think this will help you. And secondly, I think I can come up with a constant time algorithm because I have analyzed the problem based on studying what you're doing. And I did it. And in the end, this particular feature produced a 41% reduction in false positives with no measurable increase in running time. I mean, I still remember that feeling I had when I wrote the algorithm, I implemented it into the pipeline, I checked it back in, and there was no change in the running time. Yes! So this was a technical improvement that was arrived at via a human-centered approach. So human-centeredness made my technical work stronger and more effective. So, and this is something that I have found happens over and over again. So in short, and there were many other improvements that we made in this algorithm. It ended up with significant reductions in false positives that led to a 90% labor savings. When I joined the project, there were approximately 6 to 8 postdocs doing 4 hours of grunt work every day. They were not happy. And then after I made my changes, it took 1 person 1 hour a day. You could not completely automate the system. This was the error the other computer scientists made. They thought, we will automate the entire system, we'll take the humans out of the loop. But that didn't work. But 1 person 1 hour a day, that's not so bad. And then once I gave this talk and somebody asked me, but aren't you just putting scientists out of a job? And I said, no, the postdocs didn't want to do grunt work. They wanted to write papers. They wanted to do science. And so the number of papers they wrote scaled up dramatically. And They spent all their time writing papers, doing science, and going off into their careers. So yes, this is the kind of automation you want to do. And all of this was from having a data scientist that has a background both in math and computer science, and in social science and ethnography and human-centered design. So this is one of my favorite slides. Our principal investigator, Saul Perlmutter, shared in the 2011 Nobel Prize for Physics for this work. Now, I'm certainly not going to say it was anything that I did. It was all his idea. But he did say in his acceptance speech that this was the work of a team of people, and he named me as one of the key members. And that's the closest I'll ever get to a Nobel Prize, so I will take it. So I want to close with the third important reason, why data science is human-centered, whether we believe it or not. So it's often presented as this clean and impersonal sequence of computational operations. We assume the human element has been scrubbed from the database. Data are unbiased. They exist on their own. But actually, people touch the data in nearly every step. And I'm going to highlight 5 particular places. And I'll go through this quickly. So there's discovery. When someone encounters a data set and decides to use it, that is a human decision. Then there's capture, the act of acquiring it. A human writes code and brings that in. And they need to understand the data and its origins. And surprisingly, biases, maybe not so surprisingly, biases creep in. Curation is the process by which data is altered to make it to have it make more sense to someone, or maybe it's brought together from different sources. Then there's design. And people say, design data. Well, yeah, it turns out we categorize data through sets of choices. And finally, creation. People are always adding values to records in a data set through labeling. This happened even with the astronomers I was working with. There was one astronomer who they insisted, when I was creating the database for this group, they said you must put the name of the astronomer who categorizes these galaxies, because there was one senior level astronomer who always categorized the galaxies in a different way from everyone else. So I do want to emphasize, though, that these interventions are necessary for high-quality data science work. So I'm not saying that we need to get rid of them. And I hope that when you are working as a data scientist, that you make your own interventions in a responsible, accountable, and transparent manner. This is a human activity. And so I'm just going to very briefly say that it happens in geology. You use established color charts to describe the appearance of Earth samples. You use an existing taxonomy, so you classify species. There's so many examples of this, but I will move on. OK, so hopefully having convinced you that all data is human and is touched by humans, why did we ever believe that it should be separated? And more importantly, what can we do about it? So it's partly due to flawed mental models, outdated benchmarks and data sets, and our traditional methods of teaching students of engineering. And I hope all of you can take steps to change this. So yeah, the mental models, there's this benevolent AI trope. I know I grew up reading a lot of science fiction. And oh yeah, the robots will save us. Artificial intelligence is going to be better than us. It'll get rid of human error. We still see that, all right? But as a great deal of very good work has shown, machines do reflect the bias in human society. And even more than reflect, they amplify the bias, as Virginia Eubanks talked about with the welfare eligibility program. So, OK, quick story. I was sitting on a dissertation committee for natural language processing PhD. And they claimed, oh, my algorithm can detect binary gender in human-generated text with high accuracy. Now, I was kind of suspicious of this. So I delved a little deeper into it. And finally, it turned out the algorithm was based on this data set that was from the 70s, from a particular geographic area in the south of the United States, where all the males were engineers and all the females were housewives. So I said, do you think maybe there might be confounding variables in the data? And they said, oh, this is the best data set available. I said, well, why don't we collect a new one? They said, oh, all the experts rolled their eyes and said, that's a huge amount of work, a lot of money. And what was unsaid, there's no funding, there's no career benefits from doing this work. So we need to change that, all right? So how do we build ethical, human-centered data science going forward? I want to leave you in my last few minutes here with 5 key points of change. First, just like what this conference is doing, we need to recruit data scientists that are interested in ethical design. And it's been shown over and over again that a more diverse group will be more ethical and will produce better results. We need to go beyond technical solutions and develop policy at the highest levels in government. The CEOs need to change. They need to devise and disseminate new mental models and fund and incentivize creation of these data sets and benchmarks that are more equitable. We need to study how data science impacts people and design algorithms that they take that into account from the very beginning. We need to develop best practices for work in data science. This is why we wrote our book. I'm sorry, I don't want to be an advertisement for the book, but we spent a lot of time on this because we feel that we lay out the best practices, and this is really important going forward. And this is for data science in general, not just human-centered data science is technical. I have to say that. It is technical, and it is human-centered. And then finally, we need to teach the next generation of engineers. This is why I went into academia, even though my kids keep telling me, oh, you should work in industry, you'll make 3 times as much money. But this is so important. All right. So what is the most important way to change data science going forward? Well, it's you. I challenge each of you to enter this field, to stay in this field, to encourage others to move into this field. You can have a successful data science career. You can do it. Your unique viewpoints and ideas matter, and you will change it. It's not going to be easy, but don't ever give up. Don't ever think that you are not qualified, that you are not smart, or even worse, that you're not interested in data science. It is an incredibly exciting field, and it's worth the work. It's worth all the effort. Please, please stay in here and keep going. I want to say it's not going to be easy, but it is necessary. And thank you so much for being here. Thank you so much for coming.
Thank you. Thank you so much, Cecilia, for a wonderful keynote. Yeah. And we're going to have a little interlude now for 5 minutes, and then we'll be back with our first tech speaker. Thanks again, Cecilia.
Thank you.
Excuse me. We have a 5-minute video that will show this is not the break yet. Okay?
So please stay in the room. We'll break a little bit later.
So I am Sulakshana Sriram and I am from Hyderabad, Telangana state of India. And I'm associated with Sri Vishnu Educational Society, which is a group of institutions in the higher education space. I'm the associate director here for industry relations and all the initiatives. I really take the pride to say that I'm the WiDS ambassador for the Hyderabad chapter. The moment we opened up registrations, we got so many responses. 200 to 300 was the maximum number I expected, but the registrations were beyond 1,000. All the 12 to 15 speakers from the first conference. The moment I introduced this conference to them and I told them that we want to project their work on this platform, we want to show them as role models to inspire more women to take up this field. Nobody said a no. Associated with Sri Vishnu Education Society, where we have institutions in the higher education space, because our group is popularly known as one of the largest women-only campuses in the entire country of India. So in every institution, let it be a K-12 school or engineering school, we have more number of girls. When we've done the conference, when we've done the datathon, we really wanted to do something for the K-12 schools also. Pilot batch in Vishnu School in Bhimavaram, which is a rural area in Andhra Pradesh, it clicked so well. The reception was so good. All the 60 girls in the batch, they received it so well. When the reception was good, when everything went well, that's when, as an individual, I can't run it on a larger scale. That's when I approached this government organization called WeHub, and it all started there. Now they've designed their own program where they would be training the students of 6 to 7 international schools from across 3 states of India. My idea, my thought, and my dream came true to really take the program to the government schools. I would like to collaborate and talk to other organizations also, because it has to run on a larger scale, and I would like to open the dialogue with other state governments also, and I would really like to see how it goes. Anything about WiDS is so inspiring and so encouraging. I'm always in to do anything for WiDS as long as I can. So women in data science is all about showcasing women as a role model in the field of data science and inspiring more women to take up. So on the same lines, the dance form can talk about women empowerment. In Indian classical dance, every posture and step has a meaning. That is because it represents the Indian culture, and it also talks about the mythology of our religion.
Thanks so much to Sulekshana for that wonderful performance and her words. We're starting our Tech Vision talks now, and the first one will be by Maria Gargiulo from the Human Rights Data Analysis Group. Now, for those of you who are studying, you will empathize with this. She is at Oxford as a graduate student, and she has exams to take this week, so she couldn't be here in person. But we have her on video for the next 15 minutes with a wonderful talk, so please welcome Maria.
Hi everyone, I hope that you're enjoying WiDS so far. My name is Maria Gargiulo, and I'm very excited to be speaking at WiDS again this year, but sad I couldn't make it in person. I'm calling from Oxford in the United Kingdom, where I'm a graduate student in demography. My research here focuses on feminicide in Mexico and how missing data distorts our understanding of the problem, particularly its impacts on population health. Today, I'll be presenting some work I've been doing in my capacity as a statistician at the Human Rights Data Analysis Group, also known as HRDAG. The focus of my talk today will be largely methodological, but I wanted to take a moment to mention my favorite part of the work I do with HRDAG, collaborating directly with partner organizations to help define and answer pressing questions that help support their work on the ground, advocating for accountability and justice. I hope you enjoy the talk, and I hope you enjoy the rest of WiDS. Today, I want to share a bit about the statistical methods I use in my work studying undocumented human rights violations. I'd like to begin by discussing the challenges inherent in working with data documenting human rights violations. Collecting data in conflict is difficult and dangerous, and the data that results are often incomplete. Some victims' stories are never recorded, and those whose stories are documented may still be missing information about the victim, the perpetrator, or the violent event. These missing data are generally not missing at random. There are a number of different statistical biases that affect which victims are recorded, and perhaps more importantly, which victims are not. Some examples include event size bias, where larger violent events are more likely to be reported than smaller events. So events with many victims are more likely to be documented than events with one or two victims. There are also urban biases, where violence in urban areas is better documented than violence in rural communities. This could be due to physical barriers to rural areas, so this is physical access, or disruptions to internet connectivity, among other factors which prevent people from reporting violence when it occurs. A final example relates to social visibility. Prominent activists, lawyers, or public officials, especially those who are known to the international community, are more likely to be reported when they are victimized than an ordinary citizen would be, particularly if that ordinary citizen lives in a rural area or an area that's less connected to documentation efforts. As a result, the documented data may not be statistically representative of the victim population as a whole. Using the documented data to generate population inferences has the potential to mislead us about both the magnitude and patterns of violence. Our goal as statisticians is to estimate the total size of the victim population, including those victims who were never documented, and then use those estimates as the basis for our study of patterns of violence. I'd like to now zoom in a little bit more on the missing data problem I just talked about. The data you're seeing on the screen is a stylized example of the data I use in this work. Every row corresponds to a named victim. We'll have some information about the victim, the perpetrator, and the violent event, as well as a record of which sources the victim appeared on. These could be lists of victims from government institutions, nonprofits, media sources, or activists. These data sets don't generally come with crosswalks, binding the different data sets together. So we identify the lists that an individual appears on through a process called record linkage or data deduplication. I unfortunately won't have time to cover this step today, but it is a critical component of these analyses. Returning to the data, you'll see question marks in a number of places. These are meant to represent missing information. For example, we've documented person 1 as a victim, but we don't know the date of the violation. Another example, person 4 is missing both the date of the violation and the perpetrator of the violation. In contrast, person number 3 has complete information. But this is just one type of missingness. These are missing fields in records of documented victims. But we also have some undocumented victims, which are represented by the gray rows at the bottom. So again, these are the victims whose stories were not documented by any of the available data sources. We know nothing about these victims. We do not know when they were victimized, who the perpetrator was, or how many victims there were. This is the same stylized data, but now I've color-coded the missingness because we're going to use 2 different statistical methods to address the 2 different levels of missingness. For the green cells, these are again the missing fields within documented records. We are going to use a process called imputation. And for the yellow rows, which are the victims who were never documented by any of the data sources, we're going to use a method called multiple systems estimation. So I'm going to start by discussing imputation. Now we can think of imputation as a process of filling in missing fields with information based on the non-missing information available in other records. This is a particularly important step if we want to calculate estimates stratified by any field that contains missing data. And the example from before, this would be necessary if we wanted to examine patterns in time or by perpetrator. The alternative to imputation in this sense is either not doing the stratified analyses, which might be necessary for what we're trying to show, or to do a complete case analysis, where we drop records that are missing information in the field or fields of interest. We really don't want to drop records. This will only serve to statistically bias our results. So instead, we are going to impute this missing data. There are many different methods for imputation, and the most appropriate method will generally depend on the specifics of any particular analysis. Some examples include mean or mode imputation. In this case, you'd fill in the missing columns using the mean of the non-missing values for continuous variables or the mode for categorical variables. There are also regression or tree-based methods where you fit a regression or tree-based model on the observed data and then predict the values to fill in the missing fields. What I've just described are 3 different single imputation approaches. That is, we fit some model, which can be as simple as the column mean or more complex like a random forest, and fill in the missing values one time. However, we'd prefer to have a way to represent the uncertainty inherent in this imputation process. No matter how good our model is, we don't know what the right answer should be by virtue of the data being missing. Rather than hiding this uncertainty, we would prefer to propagate it into our final estimates of the total victim population. We do this using multiple imputation, which is a family of methods in which the imputation process is repeated a number of times. And this results in a number of distinct versions of the imputed data set. So we'll have one version of the data set where the missing values are filled in one way, and another version of the data set where they are filled in a slightly different way. Some missing values may be the same across both imputed data sets, but in other cases, they may be different. This allows us to propagate the uncertainty from the imputation step into the final estimates. Just like there are a number of different methods for doing single imputation, there are many ways to do multiple imputation. 2 methods that I commonly use are predictive mean matching, which in a certain sense resembles k-nearest neighbors, and again, tree-based models can be used in the multiple imputation framework as well. And now that we have a kind of basic understanding of the process of imputation, so filling in the missing data in the observed records, I'd like to turn our attention to the victims who are never documented. To do this, we'll use a different statistical method called multiple systems estimation, which is also known as capture-recapture or capture-mark-recapture in some other fields. The basic idea behind this method is that we would like to use information about the documentation patterns of the observed victims to estimate the total population size. And again, this includes victims that were never documented. We saw this earlier in the stylized data. The sources column represents which victims were documented in which list. Some victims appeared in only one list, while others were documented by 2 or more lists. These patterns, so the way in which these victims are documented, serves as the input to the multiple systems estimation model. Multiple systems estimation is technically possible, but you have to be willing to make very strong assumptions about the lists. These often don't seem plausible when working with human rights violation data. So when I apply these methods in my work, I only do so when I have 3 or more distinct lists available. As with imputation, many different multiple systems estimation models exist. They're both Bayesian and frequentist. Some examples include log linear models, decomposable graphical models, and latent class multiple capture recapture, which is the model I often use in my work. To make what I've just explained a little more concrete, let's imagine we have 2 lists A and B and a population of unknown size n. This example differs from the way that I construct my estimates in practice, but it's helpful to understand the intuition behind what multiple systems estimation is doing. Let's imagine that lists A and B are independent, and now I'd like to define some quantities. So the first quantity I would like to define is the probability of being on list A. So I'm going to call this P of A, and this is equal to A, so these are the number of people within the dark green circle, divided by n, the total size of the population. Similarly, the probability of being on list B is P of B, and that is B divided by n. Now I'd like to ask, what about the intersection between lists A and B? In the diagram, that's labeled as n, and that is sort of the dark gray people in the middle of A and B. The probability of being an M is therefore M divided by n. But because the lists are independent, so lists A and B are independent, we can rewrite this expression as the probability of being on list A times the probability of being on list B. That is, we can do A divided by n times B divided by n, which is just A times B over n squared. Rearranging the terms in this equation, we can say that our estimate of n is then equal to A times B divided by n. I think that this is really cool because using only the data we've observed, we now have this estimate of the entire population of victims, including the victims whose stories were never documented. To wrap things up, I just want to talk a little bit about how we use multiple imputation and multiple systems estimation together to get estimates that include both uncertainty from imputation and from the multiple systems estimation model. This process has 3 general steps. The first step is creating the multiply imputed data sets. So I will create, let's say, 10 multiply imputed data sets using an R package called MICE, and this stands for multivariate imputation through change equation. Again, as I explained earlier, these 10 imputed data sets will all be slightly different because the imputation process is probabilistic and allows for variation, which is exactly what we want to see because we don't know what the correct answers are. Next, so after we have the 10 replicates of the multiple imputation, so the 10 versions of the imputed data sets, we're going to calculate multiple systems estimation estimates for the population of interest on each of these imputed data sets. So at the end of this process, I will have 10 sets of results, 1 for each of the imputed data sets. I do the multiple systems estimation estimates using the R package LCMCR, which refers to, again, latent class multiple capture recapture. This is a Bayesian framework, so my 10 sets of results are 10 vectors of draws from the posterior distribution of the probable number of victims. Finally, we're going to take these 10 sets of results and combine them to get a point estimate of the most likely number of victims and a measure of our uncertainty. And what's most important about this measure of uncertainty is that this uncertainty is going to account for both uncertainty in the imputation and the uncertainty in the multiple systems estimation model. And that's very important to us. So we're propagating the error from the imputation into the final results. There are a number of different rules for combining the results from multiple imputation. In our case, we are generally able to say that the results resemble a normal distribution after we apply a log transformation. So we can use combination rules that make normality assumptions without too much issue. And finally, just to close, these are the references I referenced throughout the talk today, if you're interested in learning a little bit more. And thank you so much for joining my talk today. If you'd like to discuss anything I mentioned here in greater detail, you can reach me at mariag@hrdag.org. And happy International Women's Day and enjoy the rest of WiDS.
Thank you so much, Maria. I'm a big fan of the Human Rights Data Analysis Group, and I really recommend that you check out the incredible work that they do all around the world for human rights. We're going on to our next Tech Vision talk, and this is a talk by Tanvir Shada Mahmood. And what I like so much about her, she's going to do double duty today. She's giving a talk, and then after our break, she will reappear in our panel, which is really quite incredible. So thank you so much for coming and joining us today. Tanvir.
Good morning, everyone. How is the day today? It's a brilliant day, not so cold. And for those who are coming from the East Coast, so today I'm going to talk about a fun topic, for me at least, and I hope it is fun for you. It's something that we took on during running our Medical Civ Radiology Grand Challenge, but I thought this was an appropriate forum to discuss it so you could see what does it take to build a data science application from end to end. I just want to acknowledge my team, and you can see that there are clinicians, machine learning researchers, data scientists, medical imaging researchers, you name it, you need all of them to pull off something like this. So you might say, where is the field of radiology today? Right from the time when we did our Eyes of Watson exhibit at RSNA, that just stirred up the field of radiology, saying, oh my, AI is coming to replace us. And then both radiologists and AI companies got into the fray, and you can see a lot of them still maybe around and trying to make money. And a lot of FDA-cleared products also out there. But adoption in radiology workflows is still slow. And if you see why is that the case, it's because it doesn't help them if you just do a few of these findings. You want to be able to cover at least one modality in its entirety to get somewhere. And the kind of reports you may generate from there, just saying what the labels are, is not good enough for replacing in their clinical workflows. So in the Medical Civ Radiology Grand Challenge, which was targeted towards building AI assistants that are provably good enough, this problem was posed to us. Can you pick one modality, such as a chest X-ray, and do a full preliminary read, and to be done at the level that I couldn't distinguish between a human read and a machine read? So if you've got a chest X-ray, you need to get to the right, and you can see over there that there is very fine-grained descriptions of findings with laterality, location, and so on. So this was a task. Now you may say, why chest X-rays? So these are, obviously, they are the most common imaging exam, so obviously maybe there is a business case for it. But you'll see that we took it for a different reason. But then the more important thing was, in a data science problem, labels are somehow known or given. But in this particular case, we had no idea how many findings are there if we have to claim coverage of all. And then we had to say, if we had to be better than the radiologists, we needed to know how good are the radiologists themselves. And then the third thing is, if you make all of those, can you now describe the findings in a way that is natural looking, that you couldn't really tell who did it? So here you can see the reason we took on with these are, even though they're the most common, they're some of the hardest to interpret. They could have technical assessment issues. This is what a radiologist has to look through as they go through their workflow. These are not technically ready to interpret. Then there are things that are opacities, which are all essentially what they try to interpret, and know whether the opacities are due to consolidation or atelectasis. Then you go over and look at tubes and lines that may be present, particularly if you're in an AP at an in-hospital environment, whether the lines and tubes are placed, and you want to know what type of line and tube is it. Is it a nasogastric tube, or is it an IJ line, or a Swan-Ganz catheter? Then you need to know whether there are any implants and things that you may want to interpret from opacities to distinguish between whether there's a nodule or it's just an opacity of some other kind. So you can see that this is a very hard problem. And in order to build something that have an AI scale, you want to address many different problems, not just for AI, which we know we have to do, but also on the radiologist side, setting up the benchmarks and establishing ways of defining ground truth and to measure their performance and then measure machines' performance as well. So let me show how we actually do this right now. So if I can run, here's an image that comes in. The system can actually interpret, extract the anatomical regions, and as it starts assessing, it can spit out a report that looks like that. And you can just pick up any image and try to send it as a service. It interprets and gives a result like this. And the images could be pretty bad, as you can see from here. These are web images, and then there are findings discussed in there. Okay, so let's go to the first question. We have to know what are the findings and how many findings are there. This was a cataloging exercise that required extensive clinician work time and bringing data from both textbooks as well as from data driven from reports, looking at reports. And we did an extensive cataloging of findings, over 2,000 findings when you look at it at a very fine-grained level. But even if you roll up, there is considerable number of findings, much larger than what typically people use with the 14 labels that you see for NIH data set that is out there, and all the derivatives. The second thing was to be able to acquire multi-institutional data sets. And these are data sets that come from a variety of hospitals, both national and international. So you could have distributions, different incidence distributions. And as you can see from the incidence distributions, not all findings are occurring as commonly. So you need to build machines that can tolerate such imbalance in data as well. Then the next thing is to be able to label. Much of this data that's available is unlabeled. And even if it is labeled, it's only for 14 findings. When you're talking about 2,000 findings, how are you going to label such data sets? Manual labeling was nearly impossible. So we needed to develop very good methods for using the companion radiology reports to be able to interpret. And here's where the chest X-ray lexicon that we developed came in handy. This, together with natural language parsing and looking at the structure of sentences, we were able to do phrasal grouping. This is a work that won the Best Paper Award in EMEA a couple of years ago. And basically build this structure to form something called fine-grained finding patterns. Once you have those patterns, it's relatively easy to spit out an English language sentence, such as something over here. You can say, for the anatomical finding, left basal atelectasis is something that you can spit out. Still, it turns out that even this method would have some issues with negations, which tend to be still a bottleneck for many of these. But we have gotten it down to fairly good accuracy enough that the error that you get from such labeling is tolerable in the building of models. Okay, so now it's time to build models. You've got data, you've got labels, it's time to build models. So the first approach we took was that we are going to label it individually by taking classes of findings, like tubes and lines or technical assessments. And we got pretty good ROC curves with the data sets and the models that we used. But our experiment revealed that actually it is possible to build one single model that covers all the findings. Because of the incidence distribution rates, there is something you can do to tune the model towards these findings to adapt for sensitivities and specificities based on the likelihood of occurrence. And as a result, we ended up with building this model which exploited the latest in computer vision, feature pyramids, dilated blocks, global score quilling. For all those who use computer vision models know these are popular techniques, but put them in unique combinations to do this. Based on that, you can now see the kind of findings we can detect would say something like moderate pleural effusion in the right lower lobe. That's actually a label. So it should be relatively easy now to put forward a sentence that describes it pretty close to that. The system is also able to detect them fairly accurately where these volumes were. So you can see low lung volumes, hyperaerations. Many of them are located correctly as well. So now the question is, how do I generate a report out of this? So obviously, there is labels that are already, the findings, distributions that are given. But in order to make sure that the sentence is as natural as possible, we actually exploited prior radiology reports and combined machine learning with document retrieval and a variety of techniques to actually construct sentences out of those. So these would then have the problem that they would be actually natural language like, but also describe the findings as correctly as possible. We did these evaluations and we have published papers, so you can see some of the sentences that are being generated by such a report generation method. Okay, so in the last section, I will talk about how we said we were going to build a machine that was comparable, and how do we prove that? So we had to now conduct studies on the radiologist side to actually build benchmark data sets. So we used a ground truth labeling process called triple consensus with adjudication as a validation, and then brought them and actually recorded nearly 2,000 chest x-rays with ground truth labels across 60 plus findings. And then we looked at the performance of entry-level radiologists on detecting these, and then compared them with machines in an objective way as we could, and this is the paper in JAMA. And you can see from this ROC curves that for some findings, radiologists are better than machines, and for others, machines are better than radiologists, and for some of these, like normal-abnormal discrimination, they're right on the curve as such. So in fact, the overall conclusion from that was that there isn't much statistically significant difference between sensitivities of AI and radiologists, but specificities, you can actually tune them to be much higher for machines based on the performance considerations that you choose and the prevalence distributions of these labels as such. So this was actually encouraging that we can actually find machines that are capable of achieving this performance. So this, you can see some of the performances of which ones radiologists are good at and which ones machines are good at. Okay, so now come to the last part of it, which is building a Turing test for radiology AI. How do we do that? So one of the methodology, this is something we did with partnership with universities as well, and we rolled out initial versions at RSNA, and then later on at a final demonstration at a symposium, where we had these interfaces actually given to attendings to go and look at chest x-rays and their reports already generated with an unknown process and have them rate this. So this is the final result that came from here, and I want to focus a little bit of time on this and describe to you the event and the excitement that it generated when we were in this symposium. We had actually set aside 3 dark rooms for attendings to go and evaluate, and the reports that were randomly collected were actually distributed among these 3 radiologists. One of them just got machine reports, one of them got radiologist reports, one of them got a mixture, but none of them were told who got what. So that's what they did. They went and evaluated them, and the kind of results that they were looking for is to see if they are quality from a diagnostic purposes, whether it's an excellent quality report. So these are criteria that American College of Radiology also uses. And then a perception score in some sense of the satisfaction for how well are you satisfied with the report that you have. And then we were watching the distributions as the numbers were coming in. And we hoped and prayed that our numbers would look better. So you can see from here, across the 4 categories that we looked, when we overlay the 2, you can see that the reads, for at least for this batch of things that we used, it seemed to have come out better on the more excellent quality reports than for the radiologists in this particular case. And then the impression scores also went along these lines. Okay, to summarize, what we did was something that was attempting a grand challenge going from end to end, because we started at a place where we said we'll take on a goal saying, how can we show how good are machines? But we actually, talking about human-centered AI, the previous speaker, we had to actually go back and see how good are the humans. And most of the studies and quotations, about 26% error rate in radiologists, is anecdotal or for specific findings. But if you now have this many class of findings, how good are they? You had to actually do those studies as well. It would be nice if someone else did those studies, but given a team and where we were going with this and the duration, we had to recruit different institutions and come work with them collectively to go through this process as such. So this is a lesson learned in data science, is that the next wave of things that you will see in AI models come after is go after fine-grained findings. I think the coarse grains have already been addressed now, and in future you will see machines going after things that are much more finer level of detail when it comes to perceiving things. Thank you.
And we're going to see her back again after the break in our health panel. So that's what's coming up. Now, I know you're incredibly eager to have this break and to connect with people, because as soon as you thought we had a break just a little bit ago, you're off. But before we go, just a few announcements about this. First of all, I want to say to our online audience at Hop-In that you're going to be enjoying interviews during this break created by our media collaborator, theCUBE. For those of you here, you will see them outside in the studio. It's really fun to, to witness them do that. You may wonder, with as many women as we have, will we have enough bathrooms? But we do. All of the bathrooms close by are converted to female or women only. Gender-neutral bathrooms are at the end of the hallway. So just keep that in mind. We have coffee outside. We have a job board outside. If you're looking for people to work with, if you have openings or you're looking for a job, check out the job board. We're going to be back here at 9:50 exactly Pacific time, right? About 20 minutes. And you have homework for this break. And the homework is meet as many new people as you can. See you in 20 minutes.
From Stanford University, it's theCUBE, covering Stanford Women in Data Science 2020. Brought to you by SiliconANGLE Media.
Hi, and welcome to theCUBE. I'm your host, Sonia Tagare, and we're live at Stanford University covering the 5th annual WiDS Women in Data Science Conference. Joining us today is Emily Glassberg-Sands, the head of data science at Coursera. Emily, welcome to theCUBE.
Thanks, so great to be on.
So tell us a little bit more about what you do at Coursera.
Yeah, absolutely. So Coursera is the world's largest platform for higher education. We partner with about 160 universities and 20 industry partners, and we provide top learning content from data science to child nutrition to about 50 million learners around the world. I lead the end-to-end data team, so spanning data engineering, data science, and machine learning.
Wow. And we just had Daphne Kohler on earlier this morning, who's the co-founder of Coursera, Absolutely. And she's also the one who hired you.
Yeah.
So tell us more about that relationship.
Well, I love Daphne. I think the world of her. As I will talk about shortly, she actually didn't hire me from the start. The first answer I got from Coursera was a no, that the company wasn't quite ready for someone who wasn't a full-blown coder, but I eventually talked her into bringing me on board, and she's been an inspiration ever since. I think one of my first memories of Daphne was when she was painting the vision of what's possible with online education, and she said, think about the first movie. The first movie was literally just filming a play on stage. You'll appreciate this, given your background in film. And then fast forward to today and think about what's possible in movies that could never be possible on the brick and mortar stage. And the analog she was creating was that the first MOOC, the first massive open online course, was very simply filming a professor in a classroom. But she was thinking forward to today and tomorrow and 5 years from now, and what's possible in terms of how data and technology can transform how educators teach and how learners learn.
That's very cool. So how has Coursera changed from when she started it to now?
So it's evolved a lot. So I've been at Coursera about 6 years. When I joined, the company had less than 50 people. Today, we're 10 times that size. We have 500. I think there have been obviously dramatic growth in the platform overall, but 3 main changes to our business model. The first is we've moved from partnering exclusively with universities to recognizing that actually a lot of the most important education for folks in the labor market is being taught within companies. So Google is super incentivized to train people in Google Cloud, Amazon in AWS. Folks need to learn Tableau and a whole host of other softwares. So we've expanded to including education that's provided not just by top institutions like Stanford, but also by top institutions that are companies like Amazon and Google. The second big change is we've recognized that while for many learners an individual course or a MOOC is sufficient, some learners need access to full degree, diploma-bearing credentials. So we've moved to the degree space. We now have 14 degrees live on the platform, masters in computer science and data science, but also in business, accounting, and so on. And And the third major change is, I think, just sort of as the world has evolved to recognize that folks need to be learning throughout their lives, there's also general consensus that it's not just on the individuals to learn, but also on their companies to train them and governments as well. And so we launched Coursera for Enterprise, which is about providing learning content through employers and through governments so we can reach a wider swath of individuals who might not be able to afford it themselves.
And how are you able to use data science to track individual user preferences and user behavior?
Yeah, that's a great question. So you can imagine, right, 50 million learners. They're from almost every country in the world. They're from a range of different backgrounds, have a bunch of different goals. And so I think what you're getting at is that so much of creating the right learning experience for each person is about personalizing that experience. And we personalize throughout the learner journey. So in discovery, up front, when you first join the platform, we ask you, what's your career goal? What role are you in today? And then we help you find the right content to close the gap. As you're moving through courses, we predict whether or not you need some additional support, whether it's a fully automated intervention like a behavioral nudge emphasizing growth mindset, or a pedagogical nudge like recommending the right review material, and provide it to you. And then we also do the same to accelerate support staff on campus. So we identify for each individual what type of human touch might they need, and we serve up to support staff recommendations for who they should reach out to, whether it's a counselor reaching out to a degree student who hasn't logged in for a while, or a TA reaching out to a degree student who's struggling with an assignment. So data really powers all of that, understanding someone's goals, their backgrounds, the content that's going to close the gap, as well as understanding where they need additional support and what type of help we can provide.
And how are you able to track this data? Are you using A/B testing?
Yeah, great question. So we call it eventing level data, which basically tracks what every learner is doing as they're moving through the platform. And then we use A/B testing to understand the influence of kind of our big features. So say we roll out a new search ranking algorithm or a new learning experience. We would A/B test that, yes, to understand how learners in the new variant compare to learners in the old variant. But for many of our machine learned systems, we're actually doing more of a multi-arm banded approach, where on the margin, we're changing a little bit the experience people have to understand what effect that has on their downstream behavior, separate from this mass hold in or hold out A/B test.
And so today you're giving a talk about Coursera's latest data products. Give us a little insight about that.
So I'm covering 3 data products that we've launched over the last couple of years. The first 2 are oriented around really helping learners be successful in the learning experience. So the first is predicting when learners are going to need additional nudges and intervening in fully automated ways to get them back on track. The second is about identifying learners who need human support and serving up really easily interpretable insights to support staff so they can reach out to the right learner with the right help. And then the third is a little bit different. It's about once learners are out in the labor market, how can they credibly signal what they know so that they can be rewarded for that learning on the job. And this is a product called skill scoring, where we're actually measuring what skills each learner has up to what level, so I can, for example, compare that to the skills required in my target career or show it to my employer so I can be rewarded for what I know.
And that can be really helpful when people are creating resumes by ranking how much of a skill that they have.
Absolutely. So it's really interesting when you talk about resumes. So much of what's shown on resumes are traditional credentials. Things like what school did you go to, what did you major in, what jobs have you had, and as you and I both know, there's unequal access to the school you go to or the early jobs you get. And so part of the motivation behind skill scoring is to create more equitable or fair or accessible signals for the labor market. So we're really excited about that direction.
And do you think companies are taking that into consideration when they're hiring people who, say, have like a 5 out of 5 skill in computer science, but they didn't go to Stanford? Do you think they're taking that?
Absolutely. I think companies are hungry to find more diverse talent. And the biggest challenge is when you look at people from diverse backgrounds, it's hard to know who has what skills. And so skill scoring provides a really valuable input. We're actually seeing it in use already by many of our enterprise customers who are using it to identify who of their internal employees is well positioned for new opportunities or new roles. For example, I may have a bunch of back-end engineers. If I know who's good in math and machine learning and statistics, I can actually tap those folks to transition over to machine learning roles. And so it's used both as an external signal in the external labor market as well as an internal signal within companies.
And just our last question here, what advice would you give to young women who are either out of college or just starting college who are interested in data science, who maybe haven't majored in a typical data science major? What advice would you give to them?
So I love that you asked who haven't majored in a typical data science major. I'm actually an economist by training, and I think that's probably the reason why I was at first rejected from Coursera, because an economist is a very strange background to go into data science. I think my primary advice to those young women would be to really not get too lost in the data science, in the math, in the algorithms, and instead to remember that those are a means to an end, and the end is impact. So think about the problems in the world that you care about. For me, it's education. For others, it's healthcare or personal finance or a range of other issues. And remember that data science provides this vast set of tools that you can use to solve the problems you care about most.
That's great. Thank you so much for being on theCUBE.
Thank you.
I'm Sonia Tagare. Thank you so much for watching theCUBE, and stay tuned for more.
Live from Stanford University, it's theCUBE, covering Stanford Women in Data Science 2020. Brought to you by SiliconANGLE Media.
Hi, and welcome to theCUBE. I'm your host, Sonia Tagare, and we're live at Stanford University covering the 5th annual WiDS, Women in Data Science Conference. Joining us today is Nusha Ajami, who's the Director of Urban Water Policy for Stanford. Nusha, welcome to theCUBE.
Thank you for having me.
Absolutely. So tell us a little bit about your role.
So I direct this urban water policy program at Stanford. We focus on building solutions for resilient cities. We try to use data science and also the mathematical models to better understand how water use is changing and how we can build future cities and infrastructure to address the needs of the people in the US, in California, and across the world.
That's great. And you're going to give a talk today about how to build water security using big data.
Sure.
So give us a preview of your talk.
Sure. So the 20th century water infrastructure model was very much of a top-down model. So we built solutions or infrastructure to bring water to people, but people were not part of the loop. They were not, the way that they behaved, their decision-making process, what they use, how they use it, wasn't necessarily part of the process. And we assume there's enough water out there to bring water to people and they can do whatever they want with it. So what we are trying to do is we want to change this paradigm and try to make it more bottom up, to engage people's decision-making process and the uncertainty associated with that as part of the infrastructure planning process. So I'll talk a little bit about that today.
And where is the most water usage coming from?
So interestingly enough, in the developed world, especially in the Western United States, 50% of our water is used outdoors for grass and outdoor spacing, which we don't necessarily are dependent on. Our lives don't depend on it. I'll talk about the statistics in my talk, but grass is the biggest crop we are growing in the US, while we are not really needing it for food consumption, and also uses 4 times more water than corn, which is a lot of water. And in California alone, if you just think about some of the spaces that we have, the grass or green spaces we have outdoors in these malls or institutional buildings or different outdoor spaces we have, some of that water, if we can save it, they can provide water for about 1 million or 2 million people a year. So that's a lot of water that we can be able to, we can save and use or actually repurpose for needs that we really have.
So does that also boil down to people watering their own lawns, or is it the problem for much bigger grass usage?
Actually, interestingly enough, that's only 10% of our outdoor water use. The rest of it is actually the residential water use, which is what you and I, the grass you and I have in our backyard, and we're watering it. So that water is even more than that amount that I mentioned. Wow. So we use a lot of water outdoors, and again, some of these green spaces are important for community building, for making sure everybody has access to green spaces, and kids can play soccer or play outdoors, but really our individual lawns and outdoor spaces, if there are not really native landscaping, it's not something that we use enough to justify the amount of water you use for that purpose.
So taking longer showers and all this stuff is very minimal compared to...
No, not at all. Actually, those are also very, very important. That's another 50% of our water that we use in our urban areas. It is important to be mindful the way we wash dishes, the way we take shower, the way we brush our teeth and not wasting water while we're doing that, and a lot of other individual decisions that we make that can impact our water use on a daily basis.
Right. So tell us a little bit more about, right now in California, we just had a dry February,
Sure.
which is the first in 150 years. And, this is a huge issue for cities, agriculture, and for potential wildfires.
Sure.
So tell us about your opinion about that.
So the 20th century infrastructure model I mentioned at the beginning, one of the flaws in that system is that it assumes that we will have enough snow in the mountains that would melt during the spring and summertime and would provide us water. The problem is climate change has really, really impacted that assumption, and now we're not getting as much snow, which comes back to the fact that this February, we have not received any snow. We are still in the winter and we have spring weather and we don't really have much snow on the mountain, which means that's going to impact the amount of water we have for summer and springtime. This year, we had a great last year. We got enough water in our reservoirs, which means that we can potentially make it through. But when you have consecutive years that are dry and we don't receive a lot of water precipitation in the form of snow or rain, that will become a very problematic issue to meet future water demand in California.
And do you think this issue is along with not having enough rainfall, but also about how we store water, or do you think there should be a change in that policy?
Sure, I think that definitely has something also in the way we store water. We are in the 21st century. We have different problems and challenges. It's good to think about alternative ways of storing water, including using groundwater sources, groundwater as a way of storing excess water or moving water around faster and making sure we use every drop of water that falls on the ground, and also protecting our water supplies from contamination or pollution.
And do you see us ever going to desalination or to get clean water?
So interestingly enough, I think desalination definitely has worked in other parts of the world when you have smaller population or you have already tapped out of all the other options that are available to you. Desalination is an expensive solution. Costs a lot of money to build this infrastructure, and also again depends on this centralized approach that we will build something and provide resources to people from that location. So it's very costly to build this kind of solutions. I think for California, we still have plenty of water that we can save and repurpose, I would say, and also we still can do recycling and reuse. We can capture our stormwater and reuse it. So there's so many other cheaper, more accessible options available before we go ahead and build a desalination plant.
And you're going to be talking about sustainable water resource management. So
Sure.
Tell us a little bit more about that too.
So sustainable water resource management, and occasionally I use also the word like building resilient water future, is all about diversifying our water supply and being mindful of how we use our water. Every drop of water that we use is degraded and needs to be cleaned up and put back in the environment. So it always starts from the bottom. The more you save, the less impact you have on the environment. The second thing is you want to make sure every drop of water that we can use it as many times possible and not make it, not take it, use it, lose it right away, but actually be able to use it multiple times for different purposes. Another point that's very important is actually majority of the water that we use on a daily basis doesn't need to be extremely clean drinking water quality. For example, if you tell someone that we are flushing down our toilets drinkable water, it would surprise you that we would spend this much time and resources and money and energy.
Welcome back from break. Please find your seats, and I know it's hard, but I'm going to ask you to stop talking. It's impossible. We are very excited to start this morning session with a panel on health issues. Tanvir has already warmed us up, talking about her work in radiology, and we'll be addressing so much more in this panel that is going to be moderated by my wonderful colleague, Tina Hernandez-Buzar. You can see all the panelists in the list, and they're also going to be introduced to you by Tina. So welcome, Tina, and the panel.
We have Tanvir here. She's coming after that lovely talk she gave. She had to get some coffee, and she is on her way to stage right now. So thank you so much for having this opportunity to speak with you this morning. We have an absolutely wonderful panel here today, and I'm really excited to have with us these exciting professionals in data science and healthcare. Here comes Tanvir, who's going to join us. My name is Tina Hernandez-Buzard. I'm an associate professor in medicine in the Department of Data Science at Stanford University. And I'm here with three outstanding leaders in healthcare. First, we have Sylvia Providis, the chair of the Department of Biomedical Data Science at Stanford. We have Janus Yazani, chief of the Division of Rheumatology at University of San Francisco, Zuckerberg General Hospital. And we have Tanvir, who you met earlier, who is IBM Fellow and Chief Scientist at IBM Research. So to start this morning, we're each going to give you a brief overview of the work we're doing in data science and healthcare. And then we're going to discuss some of the opportunities and challenges we see in the field moving forward. So let me start with sharing with you some of the work we do in my lab, and I'm going to get us going, and then I'm going to pass it down the row here. So I'm going to get started, as we've heard today, just the opportunities we've had for mentorship and getting started in the field. So I'm from a very small town. My father is Mexican. He was a farm worker. And so education wasn't something very typical in my family. And I went into my undergraduate school, and I was paired with a mentor who just changed everything in my life. He really believed in me and opened opportunities for me that I didn't even think were possible. And so my career has been, like others we heard this morning, not straightforward, but I've done different paths into healthcare and data science. Data has always been my strong point, and so merging data science and healthcare has just been a great opportunity for me. And it was through my mentorship at undergraduate that he opened opportunities, so I went and pursued a master's degree in public health, and then I just kept on learning a PhD in computer science, and then another master's degree in health services research. So I really have been able to combine these two fields to develop a unique niche where we're combining data science and healthcare. I think one perspective I bring to my work is I really have a diverse knowledge of different cultures, different societies, different social economic classes, and I understand how important it is to incorporate that when we look into healthcare and healthcare fields. And so as data scientists, I think there's many opportunities to advance the field. Specifically in my lab, we work on developing different AI technologies. In fact, I'm doing some work with Tanvir down here, developing a cancer patient digital twin, and that concept of what it is to have a virtual twin when you're undergoing cancer therapy to really understand optimal treatment pathways, identify potential outcomes, and identifying information that you can present to the caregiver to have these shared decision conversations. We develop these models, and we include things, all different types of models, deep learning, machine learning. We do a lot of natural language processing to mine medical records to really see if we can better capture the patient voice. I'm a very strong advocate of we need better technologies and tools to capture the patient voice and integrate that into routine care so we know patient values and goals. And we do that using different NLP technologies, transfer learning, et cetera. So You see, I think it's a very exciting time to be in the healthcare field. There's so many challenges and so many opportunities, and technology and data are really a path forward where we can better incorporate and really get to the next step of precision medicine, where the treatments and the technologies we develop are personalized. They take into account different patient perspectives, patient goals, patient values, and move us closer to an optimal treatment pathway. And so with that, I'm going to turn it over to my colleague, Sylvia, and she's going to give her perspective on the work she's doing and her experience in the data science field. Sylvia.
Thank you. Thank you so much, Tina. That was really interesting. So it's really wonderful to be with you today. My research is focused on data-driven computational models of cancer biology and cancer outcomes. And I thought what I would do is just tell you a little bit how I got into this field. I finished my PhD in electrical engineering here at Stanford in Information Sciences Lab. And I worked with Al Makovsky in MR spectroscopic imaging, where we were trying to apply statistical image analysis methods to spatially resolve a specific metabolite called lactate as an early indicator for brain tumors. And when I finished my PhD, I loved what I had done, but I got very interested in a very different question. And that question was, can we use MRI to screen for cancer? MRI is very expensive technology, and at the time it was kind of a crazy idea. And I told my advisor I didn't want to pursue image analysis. I wanted to pursue this really different path. And he hooked me up with a healthcare economist, Alan Garber, and I also ended up with a master's in health services research. I ended up doing a postdoctoral fellowship after my PhD, and I used my engineering background, leveraging data on screening in breast cancer mammography, asking the question, could we leverage this data and transfer the knowledge from screening trials mammography into a setting where we were screening for breast cancer with MRI, specifically in women who had high risk for breast cancer because they carried a mutation BRCA1 or BRCA2. So we developed a simulation model, not unlike this digital twin concept, of a randomized controlled trial that had never been done and has never been done to date, of women randomized into standard of care, which is mammography, versus MRI plus mammography. And we ended up getting it published in JAMA and showed that it was effective to add MRI screening to women who carried a BRCA mutation. And then the next year, the American Cancer Society used that publication together with other evidence to develop a clinical guideline for women undergoing MRI screening if they carried a BRCA mutation. So I was really excited about that. By this time, I was now a faculty member in the radiology department, and I was thinking about this problem and had gotten interested in underlying these models were clinical models of disease progression. And we had folks at Stanford, in particular, Pat Brown, had developed the DNA microarray. And at the time, folks at Stanford were generating the global transcriptome of tumors across thousands and thousands of patients. So it was a lot of data. And I thought, wouldn't it be interesting to take this data and sort of redo that underlying natural history model, but make it more molecularly specific? And so I've kind of pivoted again, but when you have skills in data science, you can actually apply them in many different ways. And so I ended up developing models of disease progression, of molecular disease progression of cancer by integrating many multi-omic data sets. And I was able to pivot because the NCI actually had an RFA asking folks like me to come into the space of cancer biology. They pretty much said in the RFA, you don't need to have a cancer biology background. We need people who think like you. And so I was able to put a team together at Stanford, and we got funded, and we've been funded for over 15 years now. So it's been a very exciting journey for me, and the upshot for me is what you heard earlier today, pursue your passion, because that's what's going to take you through your career. You're always going to have new challenges, but if you're really interested in the problem you're trying to solve, you're going to rise up to that challenge.
Thank you, Sylvia. And I think it's really important just to highlight what you said is if you have the data science skills, it's really easy to pivot across domains and across important topics and take advantage of those. Because people are always looking for somebody with really strong data science skills to come and address a different challenge, right? So thank you. All right. Jinus, do you want to go ahead and take the floor?
Sure. So really a privilege to be here today, and we're the opposite of a manel, which I'm very excited about. A lot of the themes in my career have actually been very similar to the previous two speakers. My journey on my current path actually started during my medical training. I was a rheumatology fellow at UCSF. I was working in public hospitals and in more private settings, and I just noticed that the care that patients got was uneven. There were disparities like right in front of us, and I think all of us who actually have gotten healthcare or taken a loved one to get healthcare realize that that's true. You can get one advice when you go to one place and different advice when you go to a different place. And so this was sort of the thing that I wanted to work on and solve. And my career has really been about putting together the pieces in my field to try to make care more equitable and more standardized. And so, one of the first problems that I worked on was actually just trying to get people to put patient-reported outcomes into the electronic health record in a standardized way. Electronic health records right now are primarily used for billing, and they don't actually include some of the things that really matter to patients. And so that was the first thing that we tried to do. We tried to actually agree on what outcomes should be measured, and I had to learn a lot about measurement and about electronic health record design and about how to actually get clinicians to do things like put these outcomes into the electronic health record. Next, we wanted to aggregate this data. And so that entailed building a registry, and we wanted to do this on a national level. We wanted to connect the electronic health records of clinicians across the country so that we could actually study the quality of care, find out where the gaps were, and then go back and try to make a difference. And so this entailed, using clinical informatics and learning about registry infrastructure. I know a lot about privacy and security because we were asking people to share, protected health information on a scale that hadn't been done before. And this was very successful. We were able to build a national registry with the American College of Rheumatology. It has 2.5 million patients in it. About a third of all US rheumatologists participate now. Once we had the data, then the next task was really to use data science and my background in epidemiology and biostatistics to try to understand health disparities, to try to understand where there were gaps in care. And so this entailed, developing quality measures, applying them, and a whole lot of data cleaning, which isn't always glamorous, but it's so important. And then now, I'm focused a lot on human-centered design and implementation science. I'm interested in taking all the things that we've learned from data back to the bedside. We're building things like dashboards and quality improvement toolkits so that we can actually, clinician by clinician, try to provide feedback that's meaningful and get people to change practice, reduce health disparities. And I think, I have dabbled in many different things, and I haven't had a narrow area of focus. But I think, like the previous two speakers, I feel really passionate about health equity. I feel passionate about quality of care. And so everything that I've done has sort of, circled around trying to solve this important problem.
Great, thank you. And there's a lot of commonality in all of our work, as you can tell. And so Tanvir has already given a wonderful talk this morning, but she has more to tell us. So Tanvir, we're looking forward to the additional things you can share with your work and what you have, your insights that you've driven.
Okay, maybe I can give a little bit of historical perspective because I've been in this field for a while. So as you may know, I'm one of the underrepresented minorities, I would say, come from a very conservative Muslim family. And it was a big deal in those days to send a girl unmarried alone to go get a PhD in another country. So we made those because education to us was like a pilgrimage. And so when I was in India, I used to teach courses in artificial intelligence, the Feigenbaum kind. I used to follow the Feigenbaum's Handbook of AI. And my first forays were in speech signal processing, and behind the Harpy speech understanding system, my advisor was working on that at CMU. So anyway, I came to MIT, and the day I landed, I was so excited to be in the AI lab because this is the place for doing artificial intelligence work. And then the professor, Jerry Sussman, who used to be there, I think he's still around, he would say, "Oh, you came too late, AI is over." And here I was like, what do? I came here to do PhD. So I got involved in a few interesting projects in the first year. So that helped me look at the field from a broad perspective. My first year was in building vacuum cleaner robots, some of which you now see in the market, the Roombas, early prototypes of those, to knowledge representation and reasoning, to landed in computer vision. At that time, vision was a thriving field, but not very commercially thriving. And the question that was posed to me was, well, we've solved the recognition problem. So the two other problems that are left to be solved are correspondence and selection. And the selection problem was the attentional selection problem that I took on. And now I know attention is a big word in these societies, but attention in those days was also something that we took on in computer vision. And from there, we moved to looking at searching for images over from a content-based retrieval field. And then when it came to the time, so computer vision wasn't very hot in those days. Now I see that it has changed completely. But when the time came to see what can we apply, and I've been fortunate to be part of exploratory projects throughout my career. So there was an idea, like think of it as you are pretending to a bunch of startups, a bunch of venture capitalists, and then have an idea that you get some funding to explore some area. So I rounded up a bunch of usual suspects who were working in computer vision and said, let's go address a problem. And the problem happens to correspond to a personal story of mine where my father was misdiagnosed during an emergency for an ischemic stroke when he actually had a hemorrhagic stroke. And the resident that was in the ICU did the misdiagnosis, and then that led to some consequences. Now, fortunately, he recovered, but that gave me, is there some way in which we can get AI to help in such decision-making, provide alternative hypotheses, or at least present the evidence so that there is some sort of caution, particularly to those who are not trained and are still serving, because they are the only ones out there on the field at that point in time. So that led to the work in healthcare, and as we went through, you can see the progression of that in the work I described today. So that's my field, motivated by real-world problems and across many different fields. And I think AI is not over. In fact, it's still starting. And if I look at the capabilities of systems today, I feel like there is a lot in human capability that we haven't yet reached, that there's more to go.
Great, thank you. And so you can see we all have very different areas of interest we're working on. And one thing, so as moderator, I'm going to take the prerogative to kind of change the questions that I thought we might ask. But one thing I think is really important that we've heard a lot in the literature is sort of the bias and the fairness of the algorithms we develop. And certainly in healthcare, this is really important because some of the biases that come up in the healthcare issues, they are, we get allocation bias, so certain patients might be less, identified as needing particular resources, things like that. And so it's something that is really, really important in the healthcare field, as with many other fields. And a lot of the bias that we develop when we're developing our algorithms can come from data representativeness. And so it's something that we think about a lot in our field. And particularly in my lab, how are we capturing data from diverse populations? How do we ensure the data we have is really representative of the population for whom we're going to apply these algorithms to? And certainly when we think about, like the work in my lab is incorporating the patient's voice, which patients' voices do we have? It's people who come to the healthcare system when we use our electronic medical records. It's patients who are engaged. It's patients who are reaching out. But there's a whole nother population who might just need, who need just as much resources, if not more resources, that often aren't represented in our data. And so I think there's a lot of challenges to think about, how do we capture data across these more diverse populations? And what we're thinking about in our lab is, it can't be the same technologies that we apply just unanimously across the field. Different populations are going to need to, we're going to need to capture these data using different types of technologies. And really understanding these different technologies and how they play a role is going to be really important. And this is true not only for patient-reported outcomes, but also when we think about diversity in imaging and things like that. We were recently looking at images for lung cancer, and we noticed that over 80% of the lung cancer images we had were from smokers, which is not the representation of the people who have lung cancer. So thinking about diversity across all aspects of diversity, I think, is really important. And so I'd like to ask the panelists, how do you think about diversity when you're developing your models, and how do you ensure that you have representativeness of the population? And if not, how do you transparently disclose that information, or what are your thoughts on that? And so I'll start with you, Sylvia. And if you, because imaging, often we don't think about representativeness, but it really is a problem also, right?
It is really important. So I mentioned that I work in population outcomes analysis of cancer, and we want to understand the value of a screening test, for example, in reducing cancer mortality rates. And most of the data that we have to inform those models comes from Caucasian community. And we know that it's not representative of other ethnicities and other races, and we have been challenged to explain cancer trends in other communities, and it's really a paucity of data. So it's beholden on us, all of us, to make sure that we collect those data. I don't think there's any other way around it. And so we have tried to infer, some of the ideas that we heard before, transfer some concepts from kind of the majority population community to minorities, but it hasn't actually worked, and we can't explain the trends yet. And so until we have the data, I think we're going to be stuck, quite honestly.
Absolutely. Tina, I mean, certainly with patient-reported outcomes, I think that's something we're really interested in. What are your thoughts on that?
Yeah, I think an example that I worked on with a graduate student a few years ago is helpful in thinking about this issue. So we were trying to develop a deep learning model that would actually predict the outcomes of patients who had rheumatoid arthritis over time. And we used data from the UCSF health system to build this model. It actually performed pretty well, but then we realized that we wanted to actually understand whether this model performed well in a more diverse population. And so we then tested the model at San Francisco General Hospital, which serves the poor and underinsured individuals in San Francisco, and something very interesting happened. So the model didn't perform as well. That wasn't surprising. But when we actually took the model from San Francisco General Hospital and sort of added what it had learned to the data at UCSF, the model at UCSF performed better. And so I think that there are multiple reasons, right, to include diverse populations. I think it'll actually improve healthcare for everybody, but it'll also, help us actually understand outcomes and trajectories in populations that may not be represented if we, just use the data that's easier to access. And there are, greater barriers to access. It was harder to actually use the data at San Francisco General Hospital. Imagine collecting outcomes in a population where 70% of people don't speak English. I mean, that provider team has to be really committed, and you have to work with them, right, to make them understand the importance. They need resources to be able to do that, to get that information into the electronic health record so that we can do this kind of research. And so I think it actually requires a multimodal approach that involves patients, that involves clinicians, that involves resources, so that we can do this type of analysis.
I'll take a little bit, maybe a different take on this, because I've been thinking about, how can one avoid bias in the data? And at least there are two ways I can think, in addition to the things that we will talk about. One of them is governmental initiatives or large-scale initiatives about collecting the data across, like the Bridge to AI is an effort that NIH has put forward to address some of these issues. So somebody steps in and say, I'll be the sort of the keeper of the data, and you guys all contribute. So that's way we can get a representative population. The other may be to substitute some of the, not everything has to be derived from the data. Maybe there is something about the knowledge that is present in those communities that can be incorporated through things that have been probably collected from other mechanisms, through modeling and so on. So I won't discount the role of other types of modeling mechanisms that people used to do before everything became machine learning driven or deep learning driven, to see if there is something one can bring those back. So some of the latest thinking in design of deep learning models is going to look at incorporating knowledge into the design of these and domain specificity as well. So when you start doing that kind of modeling, some element of the bias could also be addressed, I would think.
Yeah, so it is a grand challenge in healthcare, and we all have been thinking about this for some time. And so I think that's one of the opportunities where we can bring data and technology together to try and address and move some of these challenges forward. Now, throughout the morning, we've heard about mentorship and how important mentorship is in our career pathways, and really finding a mentor who is supportive, has similar values or interests, et cetera, is extremely important. So I was going to ask the panelists if they can talk a little bit about their mentorship and how and diversity on their team and how that has shaped your career. So Sylvia, I think mentorship is so important. You've already mentioned a little bit of your mentors. So any thoughts there?
Yeah, I really appreciate this topic. So I think that in terms of mentorship, what I'd like to advise is just give mentorship. And I put it in this way in contrast to some advice given by Steve Jobs many years ago, who said, just ask, and meaning just ask for mentorship. And while that advice is really good, and it really works because I do ask for mentorship all the time, and it has made a huge difference for me, there was a time when I was really nervous about asking for mentorship, and I felt too intimidated to ask for mentorship. And so what helped me in the early times of my career was just receiving mentorship from people who would just give it to me unsolicited. And so I want to give you one example of how this played out for me. I was a sophomore in electrical engineering, and I walked into the IEEE student chapter meeting, and they were looking for a new president of the student chapter. And I walked into a room of men. Many of them were sitting on the tables. Others were just pacing around, throwing things at each other. So there was all this physical energy in the room. And I just snuck in and walked into the back and was really trying to be invisible, and just was observing everything. And the student chapter president, the faculty director of the student chapter chair of the electrical engineering department, Professor Yusuf Efe, walks in, and he said, okay, so who wants to run for president? Come up front. And so two guys pop up, and they're in the front of the room. And then Professor Efe looks around the room, and he says, he points his finger, he says, you back there, come up here. So I kind of came up to the front of the room. He says, why aren't you running for president? And I said, I don't know anything about being the president of the student chapter. He said, these guys know nothing either. And so he said, you should run. So I ran, and I ended up being elected, and it was fantastic. I was no longer invisible to my classmates anymore. And so that happened because he gave me advice, completely unsolicited. So it makes a difference to give advice. I can assure you that all of you in here have advice to give somebody, especially somebody in an underrepresented community. So go up to them and just offer your advice. I can guarantee you it's going to make a big difference.
That's a great example. And can you just, I'm going to take prerogative because she is the chair of the Department of Data Science here at Stanford. So how do you ensure that, you know, in your department, there's mentorship and support for all the new students coming on? You have a great bunch of students. Can you talk a little bit about that?
Yeah, mentorship is really important, and it's become kind of a cornerstone of Stanford University. This is something we talk about at every level, not only from the students, but also for our faculty at every stage of their career as well. So all students, new students, are identified an academic mentor, and before they pick their faculty advisor, who becomes really their mentor for their research career. And all faculty are given a faculty mentor. But I also reach out to the students. If I can tell that there's a student that may need some additional input, you know, I'll say, hey, come and talk to me. I want to hear how your rotations are going. What are you thinking? I want to share with you my view of the program. So I do reach out to students, and I, you know, encourage our faculty to reach out to the students. And it is something that I feel like we can do better and that we want to improve. And we're actively talking about it. So it has become a very active part of our program.
Thank you. Eunice, do you want to talk a little bit about the mentorship you've had in your career and any differences in what Sylvia's shared or similarities would be really interesting?
Yeah, lots of similarities, but you know, one thing that I've recently been thinking about is just the types of mentorship that I've received and sort of reflecting on the different roles that people have played. You may have heard that you need a team of mentors, and that has certainly been true in my career. I think we focus a lot on having technical mentors, right? So these are the principal investigators, the people sort of that help us with, learning a new skill or, working on a paper or things like that. And those types of mentors have certainly been very important. But there are actually 3 other types of mentors that I've relied on over the last couple decades. So one type has been a career mentor, who actually was very different than the technical mentor. And this is somebody who could really look holistically at my progress, talk to me about where there were gaps, and try to really fill in some advice about the things I needed to do to get promoted in academic medicine. Another type of mentor, which has been really important, is a life mentor. And different people have taken this role at different parts of my career, but I remember a particularly vulnerable period. I had just had my first child, and I was a late fellow, early faculty member, and I just felt like there were so many things I needed advice on. And it was actually, the women who were just a few years ahead of me that served as life mentors. And, to Sylvia's point about giving advice, they gave me advice about how long my maternity leave should be, about childcare issues, about where to pump breast milk when I came back to work. And actually, that was incredibly valuable. I needed that support in order to make it through those really hard years. And then the last type of mentor have been people that are often referred to as sponsors. And these are people who really don't necessarily have anything to gain by helping you, but they just do. And I think actually the example of somebody asking you to run for president is that's a wonderful example of somebody acting as a sponsor. And in my career, very early on, I was a young faculty member, I had no experience, but there was somebody at another institution who knew I was interested in this issue of quality and data, and so he nominated me to serve on this committee at the American College of Rheumatology. And that nomination really changed the trajectory of my career. I was able to work hard on that committee, multiple leadership opportunities came up, and then I had access to this network that allowed me to build all of these things that I talked about before. So I guess to all of the women in this room, I think we have opportunities to sponsor each other and to ask for sponsorship. And so I really encourage you to, whenever there is an opportunity, like you said, give mentorship, nominate people, put people's name on the radar, because it really makes a difference.
It does, and I want to just kind of follow on that, a point you just said. So I mentor a lot of people, and a lot of people come to me with, starting a family or, a diversity mentor. And one of the things we're seeing more and more is sort of this diversity tax. So because you're a woman, because you're an underrepresented minority, you often get put on committees or nominated for things because they need diversity on the committees, because they need diversity in whatever it is they're doing. And I always tell the people that make sure it's a benefit for you too, right? Don't just sit on the committee because you're filling a spot in their diversity panel, but just make sure it's meaningful to you. And you have to be, I think sponsorship is so important, and that's having somebody put your name in the hat or calling you up to run for something. But you have to make sure that the goals are aligned. And I think that diversity tax is something we're seeing more and more. And I always tell my mentees, just make sure there's value in this committee or value in this position for you also. And so I think that's really important. And I'm not sure if you guys feel that also. I'm sure you felt that in your career when you walk in a room and there's a panel of 8 men and come join the panel. And you're like, I'm really not an expert in that. So it's important to think about. Tanvir, anything to add on mentorship?
I think all these points are very good, and I don't have too much more to add other than the fact that you are your best advocate. In many of these situations, you have to make a case. So many times we've all had experiences where people tell us it can't be done, or you're too late, as they said to AI. So you just have to learn to ignore and go with your gut feeling and be willing to fight your case. So I think people will help you, but there's something that you have to give as well to make it work as such. So I think that would be important aspect of maintaining and confidence, as you said in your case. Also, you had that. So that's one thing about mentorship. The other thing I would say is that also in academics in particular, one way of mentoring is that the faculty has a much greater opportunity to mentor so much. In industry also we see those things, but the dominance of men is a lot, and particularly in our field. And so we are trying to change that by hiring more women, but there continues to be a challenge. And so there's a lot of encouragement from a technical standpoint, but I think still getting more women into industry would be good in this sense.
Yeah, great, thank you. And so we've covered a lot of topics, and one of the things that I think is really important that we can, give some information on is really what are the main challenges we face today, and what are some mitigation strategies. And so in the data science and healthcare field. And so I'm going to start the other way. So Tanvir, I'm going to start with you. And what do you see as the biggest challenge in the healthcare field related to data science, and what are some thoughts on how we can think about tackling that?
Well, certainly the availability of data is a big challenge, and when we talk about in computer vision, millions and billions of images, here we're talking about hundreds of thousands still. So the scale at which we can do medical imaging and or even multimodal as such is still very limited. So the availability of data sets, the diversity in there continues to be a problem. However, there is also another side of the equation in terms of putting these things in clinical workflows. There is still so many barriers, and some of the barriers come from the regulatory aspects itself. Right now, there is no good way to easily approve systems that can cover very large number of findings. It's still one finding at a time. And at that pace, when will we get to a stage where we can actually, accomplish a chunk of the functionality in clinical workflows? So I think something has to change over there as well. And so both of these are two of the examples we face. And then, of course, labeled data sets, and working with labeled or unlabeled data, combinations of those continues to be a challenge. And active research is underway in any of these areas. So so there is enough number of challenges for healthcare data, and some of this that come from the nuance that how much domain knowledge do you need? And there are opinions of people who think that you can just work with, you've got a labeled data set, just put a machine learning model to work. And then it doesn't do the right thing for you, and then you are back to seeking help with clinicians. So if you incorporated that help to begin with, there might have been much better models to go on. So it's that tug of war between, when to seek help and when not to, that also becomes a challenge. And of course, the cost of doing it all is a big barrier as well. So these are some of the things that are currently not getting the field to that level. So in AI, we have seen the hype, and we are seeing a valley come down again now in adoption. And I just hope that, since I've seen so many of these waves in AI, particularly in healthcare, I hope that it goes back up again with some strong successes in this space.
Yeah. Chinus, quick thoughts on challenges and in the field?
Yeah. Just to follow up on what was just said, I think that I spend more time, trying to get people to basically focus on understanding context when they're using healthcare data. This is like the missing ingredient in a lot of work. People really want to just get their hands on the data, and they want to start building models, but then they make mistakes or come up with findings that are not relevant because they don't understand context. There's a famous example of building a model to predict death in the ICU, and finding that a family meeting is one of the variables that predicts death. But if that person had actually just spent some time in an ICU, read some notes, talked to some staff, they would have realized that by the time a family meeting happens, that team already knows that the patient has a poor prognosis, and so it's sort of a circular thing, and I think it could have avoided a lot of time and energy if they'd understood context. And so my advice is that when working with healthcare data in particular, you have to spend time talking to people, interdisciplinary team, reviewing charts, some of the things that have nothing to do actually with sort of the data and the models. That will actually get you to the right answer more quickly.
That's true. I always tell my team we probably spend 80% of our time understanding the data and maybe 10 or 20% doing the fun machine learning models, et cetera. Sylvia, any quick thoughts on challenges and opportunities?
Yeah, I just want to follow this theme. I couldn't agree with it more. When you work in biomedicine, you really need to understand the domain if you're going to make a difference. Developing the methods is exciting when you have a novel method and watching, sort of monitoring predictive accuracy. But at the end of the day, you want to answer a biomedical question, or you want to solve a biomedical problem. And the answer is just as important as the method. And I feel that, especially my work in cancer biology, I spent so much of the last 15 years of my career really learning basics of molecular biology, so much so that I set up a wet lab, and now half of my lab are cancer biologists, and in fact, one of them's in this room, at least one. And so we work together. It's totally interdisciplinary. The cancer biologists come into my lab because they want to understand computational methods. The computational scientists come into my lab because they want to work with the cancer biologists and make sure whatever they're working on makes a lot of sense. And another part of this for the data scientists or the biomedical data scientists that I feel is really important for our future is that we have to empower the data scientists to ask the question, to define the question. There's so much data available right now. We shouldn't wait for somebody else to come and tell us, can you solve this question for us with this data? We understand the data. If we understand the context, we can ask and answer a really unique question that people who don't have our background would never even conceptualize. So I just encourage you to think in that way.
Yeah, thank you. And I agree with all of these challenges. I'm going to leave you with one additional challenge that we face in our lab, and that is really getting a gold standard. So knowing exactly what it is we're trying to predict, be it depressive symptoms, be it a specific disease. And with healthcare data, it's hard because we can't share data with the community. So labeling data, gold standards, really has to be somebody within our team. And often getting a clinician, they will say, to label, 500 records is a challenge. So I think there's a lot of opportunities to think about how we can do more data sharing. etc. So please, everyone, join me in thanking our wonderful panel. I hope you enjoyed the session. A lot of interesting talks.
Thank you. Thank you so much, Tina, for moderating in a powerful way, and thank all of you for being here. While we're transitioning to the next talk, I want to do something that I always try to do. You know, how many of you have been in a room where you were one of the very few women? That can feel pretty awkward. So I want you to appreciate the people in this room today who do not identify as women. So all of you, stand up and be applauded. Come on, stand up, all of you. Okay. Time to switch over now to a Tech Vision talk, and I'm very excited to introduce Alex Hanna to you, who's going to talk about Beyond Bias. Thank you, Alex.
Hi, WiDS. How are you doing? I'm glad you're excited because I'm going to kind of be a downer. My name is Alex Hanna. I'm the Director of Research at the Distributed AI Research Institute. DARE is a nonprofit independent research institute that focuses on community-based AI research free from the pervasive influence of big tech. And I forgot to bring the clicker. So, when she was finishing her PhD, now Dr. Joy Buolamwini started researching commercial facial analysis algorithms from computer vision. And she was using these facial analysis algorithms, and she found that it wasn't detecting her face. As you can see, Dr. Buolamwini is a dark-skinned black woman, and it wasn't until she put this white mask on her face that found out it was actually recognizing that white mask on a face. So as she said, in my case, a white mask was a closer fit to what the system has learned was a face than my actual human face. So she constructed a study with the founder of DARE, Dr. Timnit Gebru, that was creating a data set called the Pilot Parliaments Benchmark data set, analyzing how well it was actually performing on a gender classification task, in binary gender classification. And what you've probably seen, how many of you have heard this story before? Raise your hands up high. About half of you, actually most of you, that's awesome. And what you could expect is that it performed really poorly on darker skinned women and really well on lighter skinned men. And he found this disparity. So there's been a lot of interventions in this space around bias. We've heard a lot about bias from many of the speakers. One of the interventions was this intervention by IBM to create what they called a diversity in faces benchmark. And they wanted to use this to analyze how well these systems would perform for people from all around the world. Okay, it sounds good, right? But it turns out that much of the data was actually collected from Flickr without data subject consent. So this kind of striving for this unbiased type of data set that is more ethical, that is more good, it's often done in this way that is called by Louis Seamstra as predatory inclusion, or Keeanga Yahama Taylor has also called it predatory inclusion in the spaces of mortgage lending. The discourses of inclusion can actually obscure or hinder progress to more ethical data production and data use. As Anna Lauren Hoffman has said, inclusion operationalizes the language of remorse in doing better to obscure its commitment to a substantive techno-rationalist conception of the future. So what I want to really look into is actually to understand where we're going with data, we need to understand where we've been. And so what I do and what I've done in this project and what I'm focusing and talking about today is what I've been calling thinking about data as infrastructure and what we've been calling the genealogies of data project. We follow a historian of science in machine learning, Aaron Plasek, who says to begin to see how biases are propagated and reinforced via machine learning system training, we need histories of data sets themselves. So I move on to a paradigmatic example in ImageNet. Who here has heard of ImageNet? It's already been said at least once today. If you haven't, here's a short introduction, maybe not what you get in your typical computer vision textbook. So ImageNet was a data set that was developed at Princeton and here at Stanford by a few researchers. And what it was oriented was to really advance the cutting edge of computer vision research. It had 20 million images in it, 14 million images in it with 20,000 categories. The prior data set to that, this is in the 2010s, so there's many larger data sets now, but the prior larger data set only had 20,000 images in 20 categories in it. And so ImageNets are often credited with leading to what's been known as the deep learning revolution, this idea that we have these huge neural network models that have billions and billions of parameters, and that has led to the cutting edge of computer vision algorithms. You can see this inflection point in which a particular algorithm, AlexNet, no relation, was developed by researchers Alex Travinsky, Ilya Sutskever, and Jeff Hinton at University of Toronto. And it was reviving this older version, this older type of work on neural networks. This paper is hugely influential. It's had 80,000 sites the last time I developed this talk. And they ran it as a competition that ran from 2010 to 2017, how well people could do on the ImageNet, a subset of the ImageNet data for object classification and image localization. When we start digging into ImageNet, it reveals some really weird things though, even though it's regarded as an influential benchmark. Researchers Kate Crawford and artist Trevor Paglen looked into the person subclass of ImageNet. And we have this GIF on the right of these arcane, racist, sexist, homophobic, transphobic, and frankly bizarre image classifications from real images scraped from the web. In a deep archaeology, they found these categories like Ballbuster, which features images of women with no unifying theme, bondswoman or bondsmaid, closet queen, drug addict or junkie, failure, loser, non-starter, Jezebel, mistress or kept woman, second-rater, wimp chicken or crybaby. There's this really bizarre relationship from words to images in ImageNet, namely the assumption that all words have this kind of imageable relationship in the world. There's no reason to believe that. The relationship between images and their meanings is complicated, mediated, and complex. As Crawford and Paglen state in the weird metaphysics of ImageNet, there are separate image categories for assistant professor and associate professor, as though if someone were to get a promotion, their biometric signature will reflect the change in rank. So Crawford and Paglen didn't stop there. They trained this thing called ImageNet Roulette. Who's seen an ImageNet Roulette? It was very popular, okay, some of you. It was very popular on Twitter and Facebook. It was written about in the tech press and beyond. On the left, tech journalist Julia Carey Wong ran her image to it, called her a racist slur, which I won't print here. And a video editor from the New York Times, Jamal Jordan, put multiple pictures in, always returned something related to his race. So what are the implications when the cutting edge methods of AI are trained, tested, and validated on data sets such as these? It's not even a requirement that a vision model be trained on ImageNet to have deleterious downstream effects. As we saw in the example of AlexNet, methods which are based on these methods have rhetorical institutional weight, constructing more and more accepted black boxes in a Latourian sense upon which modern AI infrastructure are being built. And so in this, we argue that data sets can be thought of as a type of infrastructure. And we mean that in a kind of, we borrow this concept from science and technology studies, thinking about the ways in which infrastructures enable other things to be done and how we need to interrogate that. First, data sets operate as infrastructures at the most obvious kind of level. Training data sets are what the model learns, right? So it frames how problems are framed, what solutions are prioritized. Statistical properties of a data set determine category boundaries and what is rendered legible by a downstream model. So in the case of ImageNet, because the social specific practices of photography or sharing images on the web, it gives this weird rise to things like seeing hammerhead sharks as objects of scientific inquiry, trout as dead fishing trophies, and lobsters as food. Secondly, we can think about data sets as a way of benchmarking algorithms. The better you do on a particular benchmark equals how well you do in a field. But we know that's not necessarily true, especially we heard this prior panel thinking about context, thinking about what it actually means to do well here. But that's sort of what we've seen, especially within computer vision. The neural network result in 2012 in AlexNet set the tone in which neural networks then took over most of image classification, but it might not work that well for other types of classes of problems. Third, data sets work as model organisms. Because data sets and their associated benchmarks take on this authoritative nature, they can take on this status. And the characteristics of model organisms are pragmatic. Prior studies of model organisms have shown that they're readily available, they're easy to manipulate, and somewhat uncomplicated in form. However, the cheapness and availability of the model organism itself opened them up to a set of conceptual empirical gaps. You think about the ways in which fruit flies are used in genetics and et cetera. Data sets and authoritative benchmarks then, with their contingent collection processes, annotation, and archival practices, become a stand-in for more complicated data traces and machine learning tasks. And then lastly, data sets provide the methodological grounds and model developments in industry contexts. You might say ImageNet, oh, this is a thing that's mostly used in academic contexts. But that's not necessarily so. A lot of these practices do transfer on to this. Even though the constraints in data may come, a lot of the practices that come from collecting data can transfer. And so we've kind of seen this in the way that data has been compared and this development of this one data set called JFT300 that was published, the details of which were partially published by Google in 2012 or 2017. Okay, so lots of problems here. So what I've been focusing on with my colleagues is thinking about a research agenda for thinking about the genealogy of data. This is important because we can think about interrogating different practices about how data has been collected and used, and thinking about how we can do this better as data scientists, AI, and machine learning researchers. We ask first, how do data set developers describe and motivate the decisions that go into the creation of those data sets? And that work, I've done some work with Emily Denton, Morgan Klaus-Schauerman, and myself in an award-winning CSCW paper where we do a sample of computer vision benchmark data sets and look at what's valued. And we find primarily 4 results: that there's much more focus on universality at the expense of specificity. There's much more of a concentration on efficiency at the expense of care. There's much more of a focus on non-contextuality with, as compared to positionality, understanding where one's identity is, and then thinking about that kind of slowness of doing research. Second, we ask, what are the histories and contingent conditions of the creation of benchmark data sets? And we've done some work on focusing more on ImageNet that you can check out from my webpage. Third, how have benchmark data sets become hegemonic or paradigmatic? In a recent paper published with sociologists of science, Bernie Hogan and Jacob Foster, as well as Emily Denton, we found that only 12 benchmark data sets, 12, constitute 50% of the benchmark data usages in all of machine learning research. So that should signal a problem, especially when we know that, that data sets like ImageNet, MS-COCO, and many of the data sets known as benchmarks are rife with the kinds of problems that are endemic to that. And then lastly, what are the current work practices, norms, and routines that structure data collection, curation, and annotation? And I want to give a call back to our keynote this morning by Cecilia, talking about the importance of ethnographic methods, qualitative methods, and interrogating our work practices, because we know in the data science workplace, in classroom, much of the time it's how we communicate with each other and how we communicate with different types of people rather than the technical aspects of these things. So the implications of this study are mostly that we're thinking about, when we talk about bias, we often only think about addressing certain kinds of challenges to algorithmic fairness. We need to collect more data, or we need to de-bias the data. Fairness too often means not having enough representative data, and we can only contest it based on the distribution of those categories. Now, I want to give a shout out to the ImageNet team, because after the publication of Crawford and Paglin's study, they actually took out many of the offensive categories. They balanced it against skin tone, perceived age, and perceived gender. But I actually want to push it further and say one of the challenges to transparency more broadly is understanding why certain classifications exist, who they serve, and who holds the power to classify. Who is this AI thing? What is this data set actually serving? I'm actually trained as a sociologist. I think a lot more about inequality, thinking about how things can serve society rather than rushing to the technical solution. So designers, engineers, and policymakers need methods to show their work and bring to light motivations, routines, and norms of creating classifications and annotations. With that, I want to say thank you, and I want to give thanks to my collaborators, Emily Denton, Morgan Klaus-Schauerman, Rosvin Amaronesi, Andy Smart, Hillary Nicole, Bernie Koch, Jacob Foster, Jamil Smith-Lau, Tony Giroux, Andrew Zaldavart, and Meg Mitchell. Thank you.
Wonderful, wonderful, and such an important talk. Thank you. Hey, I just wanted to ask, are you warming up? It was a little bit cold this morning, but now we're good. I think we have a lot of energy. I also hope that on Hopin you're all enjoying yourself, and I wanted to share with all of us that we have people on Hopin from 99 different countries. So that's amazing. Right, so we're going to move on to our next Tech Vision talk by Chiara Bills. And Chiara, welcome to the stage.
Thank you, Margot, for that introduction, and thank you all for having me. So I'm going to speak to you all today on the topic of confronting inequities and data biases in travel demand analysis. So to start with some motivation, I want to share with you a few notes on the state of income inequality in the United States and inequity in the United States. I think many of us are aware of the current extreme case of income inequality as represented by the amount of economic growth that has accrued to the top 1%, or the top 0.1%, excuse me. As of 2020, we know that this is to the tune of 196 times that of the bottom 90% of earners in the United States. And to add some context, this is because over the past 4 decades, the majority of economic growth, estimated at $50 trillion, went to the top 1% rather than going to the bottom 90%. So this is equivalent to about $42,000 on average for the median full-time worker in the United States. So when we talk about equity, it's about many of the things that we are familiar with. It's about the fair distribution of opportunity, fair distribution of power, fair distribution of outcomes. It's also about fairness in data. It's about fairness in the algorithmic outcomes. It's about fairness in the decision-making process. But I also submit to you that it's about fairness, it's about the health and stability of our economy. Inequity jeopardizes our national economy by making society weaker and poorly equipped to respond in times of emergency. So I think in the United States, our initial poor response to COVID-19 and our slow relative recovery relative to other countries can serve as evidence. Inequality constrains economic growth in the literature. And all of these things together signify the urgency and the critical nature of addressing equity in many domains that we work in. So I'm a transportation engineer, and in transportation engineering and planning, we have a long history of investigating equity in decision-making for large transportation infrastructure that dates back to the 1950s and 60s. And so pictured here, you see images reflecting the aftermath of the construction of the interstate highway system, I-75 in Detroit. And this is just one case of many across the United States. So I think many of us are aware that this same case occurred over and over throughout the United States. And there were some 1 million Black and minoritized residents who were made to be displaced in order to make way for the Eisenhower interstate system. So this is evidence of how decisions that we make, if done without investigating impacts to vulnerable communities, can result in devastating consequences. So we understand that there are inequities from a historical context, but I want to also present that these inequities persist today. So one of the advocates of big data, we have data available from transportation network companies like Uber and Lyft that can be combined in experiments and experimental design to shed light on disparities when it comes to the quality of service across racial groups. So for example, There was a study that found that nearly 50% or nearly a 50% higher occurrence in terms of cancellations in Uber and Lyft trips, and much longer, significantly longer waiting times when it comes to Black travelers in comparison to the counterparts. We also know that federal funding for transportation tends to prioritize heavy rail, even though we know vulnerable communities tend to benefit more so from local bus services. And we're also aware that vulnerable communities tend to experience a significantly greater exposure to various types of transportation pollution, even though they're less likely to contribute to emissions in terms of VMT and so on. So with that as motivation, I study how to confront equity in travel demand analysis. And for those who are unaware, travel demand models are computational tools that are often used in mid to long range forecasting of transportation plans and decisions. They can be used to decide for or against large transportation infrastructure, like expanding certain types of transit or highway expansion, or even mitigating traffic congestion using traffic control mechanisms. And these models are widely used for transportation decision making, and they can drive up to 200 billion in annual transportation spending at the federal and state levels. So in order for us to confront bias, representativeness, equity in transportation decision-making, it includes the following. It includes our data collection process. It includes how we expand the data. It includes our modeling and estimation phases, as well as our calculation of performance metrics using these models. Why are all of these phases so important? Because these are probabilistic models that are empirically estimated. So in my work, I've spent the last few years studying the data collection phase, and in particular, focusing on biases associated with the survey data collection. Now, although we have access to vast amounts of big data in transportation, produced from smartphone utilization, app utilization, and so forth, with regard to travel demand models, these models are still primarily estimated using classical household travel survey data. So let's talk about how these data can become biased. So we are aware that there may be non-coverage bias that occurs, and this is when certain participants are simply missing from the sampling frame. We know that there might be non-response biases for those who are included in the sampling frame, namely unit and mainly unit and item non-response. And in terms of unit non-response, this is when participants are simply opting not to participate in the data set. And item non-response refers to those who are participating but deciding which questions they want to respond to. There's also significant evidence that sometimes the survey modes, so whether it's paper or online or mobile, sometimes the survey modes don't necessarily align with the needs of the target group. So I'm speaking to issues connected to the digital divide, issues connected to literacy that might overall serve as barriers for target communities to participate in surveys. And a couple of notes from the literature. So we know that these types of non-response biases are more prevalent for disadvantaged communities, so low income, elderly, underemployed, transit-dependent, and so on. We also know that there are a range of solutions that are offered in the literature and that many of us here study, things like the benefits of increasing the sampling size. And so this is one of the reasons why big data is so attractive, because it improves our capacity to collect data, but also other solutions like sophisticated data stratification techniques, data imputation, sample weighting, and so on. But the primary challenge for data science and estimating of these travel demand models is that we tend to assume that the data that we have available actually gives us the complete picture. In other words, we assume that any errors that might exist in the data are ignorable errors. And this presents significant issues. Further, there's a big question around the policy implications. So if we have severe issues where certain groups may be poorly represented in the data, what are the policy implications? What does this mean for decision making? And so this is a big unknown. So now what I want to do is to contextualize these policy questions. We know that there's a historical context for inequity in transportation decision making. We know that these transportation inequities persist today, and this is observable in the data, but let's talk about what the decision making implications are. So say that we have Vanessa and Susan, and we're using Vanessa and Susan to represent two demographics for which we want to estimate job accessibility. This is a common objective in transportation planning. We're using the above simple utility function to represent our model as a means of calculating accessibility to a downtown location where there are 100 jobs available. Now, if Vanessa and Susan have the same conditions, they live equidistant from downtown, they have the same access to modes and so forth, then our model would predict that they have the same level of attractiveness to traveling downtown. However, what if there are biases unknown to the analyst and not reflected in the data, like discrimination with regard to the labor market? So in this case, what if there are 25 companies that are less likely to hire Vanessa? What this would mean, or this would result in reality, a reduction in her accessibility to being employed downtown. However, our model would predict that Vanessa and Susan have the same level of accessibility because this is an unknown that is not reflected in our data. Now, what if we, for whatever reason, we didn't have access to data from Pam or Lydia, we didn't have access to data from Vanessa or Susan, and we used Pam and Lydia's responses to reflect their demographic. However, while Lydia lives in a similar neighborhood as Susan, Pam lives on average, or her demographic on average lives closer to downtown. This would result in an increase in our estimate or our calculation of accessibility for Pam and Vanessa's demographic group, which would be an incorrect prediction from our model. So these two simple cases are reflections of what the ramifications are if we, for example, have prevalent social issues like racial discrimination in various domains, if we have non-response that is systematically more prevalent for certain groups, and in this case, they are on average living closer to downtown than they do in reality. This is how our travel models might lead us to assume that working downtown is more attractive than it actually is for various demographics. So with that, I'll summarize. So equity is, among many things, tied to the economic strength and resilience of an economy, and this makes addressing equity even more urgent and critical. We are aware that vulnerable communities suffer from inequitable decisions of the past, as well as impacts of new transportation services today. And then responding to the question of how we can advance equity in travel demand models, there are a number of solutions that my team is working on, but I think primarily we need to denormalize the use of data as if it gives us the complete picture and work towards advancing incorporation of the likelihood of the data or probability of responses from various groups in transportation data analysis. And that's it. Thank you so much.
Thanks so much, Tiara. And the wonderful thing is that we will continue discussing this very important topic in a panel that comes right after the next 5 minutes that a lot of people in the world are waiting for, because this is the announcement of the winners of our global datathon.
We're thrilled to be hosting the WiDS Datathon for the 5th year in a row, encouraging women to hone their skills in predictive analytics. We're thrilled to be hosting the WiDS Datathon for the 5th year in a row, encouraging women to hone their skills in predictive analytics through a social good type of challenge.
This year's challenge is related to climate change, which is a global, urgent, and extremely complex issue that affects literally everyone, regardless of their geography or life situation.
We worked with Climate Change Bar AI and Berkeley Labs to create the dataset, allowing participants to build models to predict building energy consumption.
We see building retrofitting as the low-hanging fruit to reduce greenhouse gas emissions. Predicting energy consumption of building helps to identify retrofitting approaches that can ultimately reduce emissions.
At Berkeley Lab, we've got scientists who are researching and analyzing ways to mitigate the effects of climate change. With the WiDS Datathon, we're effectively expanding our reach, allowing data scientists all around the world to come up with their own unique ways of predicting energy consumption.
Participants enter our competition and submit their models on Kaggle. In order to encourage women to participate in particular, we require that women comprise at least half of each team.
At Kaggle, we're always looking for ways to encourage a more diverse group of people to participate in data challenges. And that's why we've continued to collaborate with the WiDS Datathon year after year.
We've worked with several collaborators to provide resources and tutorials to help participants throughout the competition. Participants get guidance on everything from getting started with Kaggle to building regression models and load forecasting. We realize that participating in a datathon involves a learning curve, particularly for first-timers, and we designed these resources so that participants come out of the datathon with more knowledge and confidence.
Dozens of WiDS ambassadors hosted Datathon workshops where they helped their communities get started on Kaggle, form teams, get mentorship, and even submit their first models. Around 40 workshops have been hosted worldwide in over 22 countries, including Kenya, Nepal, the UK, and Peru.
Excitingly, next up is phase 2 of our WiDS Datathon, the Excellence in Research Award, where WiDS Datathon participants have an opportunity to engage in open-ended and deep explorations of one of 3 research tracks, covering a range of domains including healthcare, environmental protection, and energy efficiency.
Over the course of 3 months, participants can have a hands-on data science problem-solving experience that simulates academic or industry research. Registration for phase 2 opens on March 8th, and submissions can be made through June 30th.
Hosting the WiDS Datathon and the Excellence in Research Award always involves many people from a number of collaborator organizations. We could not do it without all of your contributions and the support of our global visionary sponsors.
With such an incredible group of people to work with on the Datathon, and here's a special shout out to our Datathon committee, we really can't wait to see what we're gonna do next. In fact, the WiDS Datathon have always historically focused on a social impact issue. In the last 5 years, we selected topics such as financial inclusion for lower income families, environmental impact of palm oil plantations, health care outcomes in hospital intensive care units, and this year, building energy efficiency and climate change. So if you have a great idea about a data set or socially impactful Datathon challenge for next year, please reach out and let us know.
Hi, everyone. It is my great pleasure to announce the winners of this year's WiDS Datathon. They come from 3 countries, and they span 3 continents. So let's start with 3rd place. Congratulations go to the Gradient Boosted Math Ladies. And this is their first time competing in a WiDS Datathon. Okay, 2nd place goes to Kim Montgomery and the dihydrogen oxide team. And Kim was actually 1st place winner last year, so it's great to have her back on the podium. And then, they stole my thunder, but 1st place goes to the ZUJM or ZUJM team from India and France. And congratulations to all the winners. Stay tuned, we'll share their models and their stories with everyone in the WiDS community in the coming months. Thank you.
Thank you.
you, Karen. The excitement with the Global WiDS Datathon this year has been enormously large, and it's so exciting to see this come to fruition now. So I am very, very happy that we can continue that wonderful topic and very important topic of equity in transportation, sustainability and energy now with a panel led, moderated by my colleague Jenny Sakali here from Stanford University. And she will introduce everyone on the panel. Welcome, Jenny, and the panel.
Yeah, I'll sit here. All right, let's take a seat. Thanks for introducing us, Margot. I'm very excited to be here, and I'm particularly excited to host this particular panel. It's very close to my heart. We're thinking about equity, and we're thinking about what is the role of algorithms, of models, of data to help us move forward. I should say that we intentionally decided to call this an equity panel rather than an inequity panel, because we really want to think about how do we move forward. We heard a lot about bias and the importance to contextualize this morning, and I think that was such a wonderful way of framing the conversation we want to have today here. So I have three wonderful speakers. Their bios are already in the leaflet, but I want to start with letting everyone just kind of briefly introduce themselves, what they do. They all work on equity with algorithms, with data, but from different angles. So why don't we start with you, Ling, and then we'll go through our wonderful speakers here. And why don't you tell us a little bit about what you're doing right now, and what does equity mean to you?
Hello, everyone. It's such an honor to be here. I learned a lot from the inspirational talks this morning, and I'm looking forward to learn more from this panel discussion. So as a research scientist in the Lawrence Berkeley lab, I actually wear multiple hats there. So the first hat I wear is as an atmospheric scientist, focusing on air pollution controls. So it's so important that having clean air to breathe. It has intimate relationship with the equity issues. To give you some numbers globally, we have just the particulate matter pollution alone accounts for more than 4 million deaths per year. And also in the United States, the deaths caused by particulate matter pollution is twice as many as that are caused by car accidents. It's been well established in the literature that such a huge health risk factor is disproportionately burdened by the lower income and the racial minority groups. So moving forward, how can we minimize and avoid such environmental justice disparity? One of my recent work is to use air quality modeling tools and atmospheric sensitivity analysis to come up with pollution control strategies that can help benefit the disadvantaged communities in Central California. And this region is actually account for close to 70% of the most disadvantaged communities in the whole California region. What I'm very excited about is two of my upcoming projects, which continue this legacy, basically looking at the distributional effects in air quality and health burdens arise from the different deployment strategies of EV charging infrastructure, as well as decarbonization pathways in the transportation sector. The other hat I wear, I don't know if I'm running too long, but is as a data scientist and also domain scientist. which I tries to bring data science method into the building energy as well as the transportation research. Here, Jessica and Tiara probably will be like more into these fields. The focus here, what I try to focus is mainly in the leveraging data and algorithms to bring the behavioral insights and build behavioral-based models. To me, this is related to equity because understanding the opportunities as well as the constraints that ultimately shape the decision context is the first step to a equitable distribution of resources based on individualized needs. And they also help us to design policy levers that really address the barriers faced by individuals and help them to better achieve clean energy goals.
Thank you, Ling. That was great. And I think also already a lot of topics come popping up that will build on transportation, climate change, pollution, energy. Jessica, do you want to tell us a little bit about your work?
Yes, thank you. Thank you for having me here today. It's a real pleasure. I'm a mechanical engineer by training, and I've always been really interested in the human dimensions of the technologies and the processes that we're developing. I've spent my career working in buildings, building science and building technology, and I think that's in no small part because of the core role that buildings play for us. They're where we create our homes, where we work, where we educate our children and gather in community. And with a third of greenhouse gas emissions, the energy-related portion coming from our facilities, there's also the opportunity to do very societally relevant applied problem solving. So what we're finding right now is that we're in the midst of a really exciting energy transition. We're using data to curate nearly every aspect of our lives. And we're seeing this proliferation of data-driven technologies and services. For buildings, what that means is that we're increasingly able to use our facilities as the hub for the exchange of clean electrons in this clean energy economy. So we're integrating with renewable resources to power our buildings. We're able to modulate the consumption and loads in our facilities to better coordinate with those renewables, and even sometimes contribute that clean energy back into the grid. And more, we're also passing through those clean electrons into our vehicles, into our electric vehicles that are integrated through the buildings with our charging infrastructure. We're doing all of this today with a real newfound focus on equity and justice. And how that's manifesting is in real considerations to things like health and air quality. What are the implications of burning fossil fuels in our power plants, in our homes, in our appliances, or things like poor condition facilities that may expose us to things like mold? We're aware of the problems of extreme heat and the urban heat island effect that's so acutely experienced in our Black and brown communities in each and every city across the country. And I would say finally, we're thinking a lot about who is it that gets to participate in this new clean energy economy. There's aspects here of workforce, and also I would say most critically, access to and ownership of our clean energy assets. Who is it that is able to reap the benefits of the rooftop solar, of the behind-the-meter battery storage, of the smart and connected equipment and appliances that are out there? Thank you.
That sounds exciting. Tiara, do you want? We already heard a little bit from your work.
Yeah,
do you want to build on that?
So I'll just add that I've been interested in transportation equity and how to advance equity in transportation since I started grad school. And I think that it's motivated really from growing up and seeing examples. I'm originally from Detroit, Michigan, and growing up and seeing examples of how place matters and how where you live, the modes that you have access to, they all dictate outcomes related to opportunity. So that was very real to me growing up. Once I got to grad school, I started thinking about all of these different cases. In Detroit also, there is a community known as Mexican Village. It's a high concentration of Hispanic residents. And it's right near the on-ramps for the Ambassador Bridge, which is connecting to Windsor, Canada, and is responsible for, I think, about 25% of all trade from North America to Canada. So you have this community that's located in this area that is known to have a high concentration of vehicle-based air pollution, but they are not necessarily benefiting overall in terms of economic, prosperity from their position. So these are all very clear examples to me, and they drive the work that I do. As I was able to mention earlier, I study these travel demand models and really the whole landscape. So how we collect the data, the relationship between the quality of the data and modeling outcomes, prediction accuracies, how well these models reflect conditions for vulnerable communities. And also, once we have improved data and improved models, using them to calculate measures that can inform decision-making in a meaningful way. And so I study all of these areas. And one of my interests, again, relating to the discussion earlier, is that there are a lot of social issues that drive the models that we end up with in decision-making. Those social issues don't always make their way into the data. And so I think it's really important that we start being more aware of this and trying to come up with ways to better reflect some of these broader, seemingly exogenous factors in our data and in our modeling.
And I think that's such a great point. I would love to build that out maybe a little bit more, because it's also something that we work in my group. We mostly do model development, and it is challenging, right? When you think about equity, that there is the quantitative side, there's the algorithm, the model that you're using, but there's so much context that is so essential. There's so many implicit assumptions that go in. That it depends both on that govern how you set up the model, but also how you apply the model. Mm-hmm. So maybe let's do another round, and I would love to hear from each of you about what is the role that algorithms play and models play, and how can they help us move towards greater equity? So do you maybe want to build that point out a little bit more? Like, how can we move to a place where models are where the models are moving us towards greater equity rather than sort of repeating mistakes of the past or sort of enforcing our blind spots?
Yeah, absolutely. I think one of the really exciting things about emerging data sets that we have coming online is that we can explore things that we would not be able to explore without them. So I gave the example of leveraging TNC data to understand disparities in the quality of service. I think that these are things that we couldn't necessarily put clear numbers behind before. And so it highlights, a significant issue, and it also highlights, something about how this can happen. From a modeling perspective, so I think, I kind of glossed over this, but under the hood of travel demand models are essentially discrete choice or econometric models, right? These are models that are intended to preserve the causal effects, the behaviors, the why, the preferences of travelers, why they're making certain choices when it comes to their transportation. However, one of the and I'm going back to challenges, but trying to make my way to the opportunities. One of the challenges is that we don't pay enough attention to the constraints, right? So this is tying back to the underlying conditions. For example, if I'm choosing to take transit today, to get to work, I'm making that choice under some constraints, right? There's some market conditions that sort of led me to that. It has to do with my access to travel modes. It has to do with predispositions towards a mode, perhaps. It has to do with my pocketbook. It has to do with some things that we can observe and some things that we cannot. And so I think that we spend a lot of time focusing on the choice process, not enough on the constraints. And with the advent of big data, we're starting to have an opportunity to understand more of those constraints in new and interesting ways. And so I think that's where the opportunity is. I think that we need to leverage the vast amounts of data that we do have about all parts of life and all types of activity to understand constraints that are not presented in traditional data sets.
Yeah, that's such an interesting point. Certainly, I think something we see in our research as well is that some communities have a lot more choice than others.
Absolutely.
And we tend to take that for granted, but then, of course, that has the risk of just like perpetuating existing inequities, right?
Exactly, and assuming that everyone has the same level of choice.
Exactly, just assuming that everyone had that. Jessica, do you want to share from your experiences? I'm sure that kind of theme has come up when it comes to energy transitions and building design, like some tend to profit more than others or tend to be more active in the choice and the design than others, or what is the experience?
I think in one respect, one aspect of that I've been considering in my work is the extent to which the tools or the techniques that we are interested in drive us down certain paths. So there's a lot of activity in the building sector now in the R&D side around control. And so it turns out up to a third of the energy or emissions in our buildings is wasted just through how we operate them. So much attention on control and advanced control, particularly learning-based methods. As it turns out, those are most powerful for very complex systems. When we have rooftop solar and behind-the-meter storage, and we have many, many knobs to turn. And so we start asking, is that leading us down a path where we're only designing solutions for the Class A high-end real estate or homes that feature these assets that we can then exercise our incredibly powerful models over? So it's, a lot of times the problem drives the tool, but sometimes the tool can drive what problems of focus you end up spending your attention on. I think similarly, as we develop more and more complex solutions that can handle diversity, are we able to maintain them and deliver them at different points across the digital divide, which we know is still prevalent and something we have to think about and grapple with if we're talking about economy-wide solutions.
An excellent point, yeah. Ling, you mentioned earlier that you're working on behavioral models. So behavioral models obviously try to bring in some of that human choice element or some of that social element. Can you tell us a little bit more about your experiences with those types of models?
Yeah, sure. Just in an example of travel behavior research, like modeling the choice of like transportation mode that you choose, or what type of vehicle you own in your household. The traditional so-called, we call that gold standard methods are like discrete choice models, which are based on the random utility maximization theory. So it's borrowed from econometric. What I want to say is that it has been only like scratched the surface that machine learning methods have been applied, because to me, machine learning methods, the uniqueness about it is that there's no predefined form that you need to fit, right? So you don't have to come up with a hypothesis and then test it. You just let the model learn from the data. And the traditional limitation of machine learning methods is that it has maybe superior performance at cases in prediction. However, the interpretation side, the people treat it as a black box. But in the recent advances in explainable AI, for example, the so-called explainable tree, which applies to all these tree-based methods, like the first Datathon winner, like boosting method is a tree-based classification method. So these methods can be interpreted using so-called Shapley value, which again is borrowed from game theory, to understand both the local importance of a certain variable and its global importance in predicting a certain outcome. I see that as an opportunity to marry the gold standard with machine learning methods, so that you no longer have to constrain yourself with like a fixed model structure. And what's more unique about this is that you can even borrow some behavioral insights from the machine learning models to help improve the specification of a gold standard model and improve its performance. So I see that as an opportunity, and that hasn't been exploited to the full extent yet.
That's an interesting idea, I think, particularly sort of this marrying of data and modeling, so that you don't pre-impose your view of the world necessarily on the problem, but you kind of take some clues. But then again, of course, it's the degree to which that makes our decisions and policies more equitable then depends on what kind of data do you have, and do you have the data, and how do you look at the data? So one of the things we often see in some of our projects where we really look at sort of the extreme impacts of climate hazards on communities is what happens in the majority of the population can be quite different to what happens in very specific communities. So to which degree do you feel like the data holds you back, or maybe what is the big challenge when it comes to data? Is it scarcity? Is it lack of representativeness? Where do you see sort of the data, both from an opportunity and from a challenge point of view? Do you want to?
Yeah, sure. Yeah, I have, since I work with data on a daily basis, I just have, I have to say, as a data scientist, 80% of your time is spent on cleaning your data. And that's probably true for every data scientist, I believe. So really, I agree with the previous talk that understanding the context is very important. And as a statistician, I want to quote George Box saying that all the models are wrong, but some are useful, right? So don't lose hope. Like even the data can be biased, and if you are aware of the potential biases, you may have like ways to correct it. For example, we once used the social sequence clustering method, trying to contextualize the decision context for various families that making choice decisions. And we quickly realized that there is a hyperparameter that you need to tune in for the missing values. Because if you compare like two trajectories of life courses, there are always some pattern missing, and we quickly realized that that's gonna really begin to create this artificial cluster where people seemingly to be similar, but in fact is due to they have similar missing patterns. So we came up with methods to tune that hyperparameter so that with T-SNE visualization, basically it's in a high dimensional space, to make sure that bias goes away once we tune the parameter to some extent. And that will give us confidence that what left behind is something at least not biased by the structural missing. So I think most of these methods are case-by-case basis. It's really hard to tell you one-size-fits-all solutions.
I think that's a great point to generally, I think for work or research or applied work in equity, like one size rarely fits all. I'm sure that's an experience you might have had as well, Jessica.
Oh, absolutely. One of the huge challenges we're grappling with across the building sector and applications that will move us forward in that part of the economy is really generalizability and scalability. People will say, if you've seen one building, you've seen one building. We're confronted with extreme heterogeneity. And it turns out that once you have taken the published model form from the literature, tuned all of your hyperparameters with the data you may be fortunate enough to have, and then instantiated that for actual control in a physical environment, it doesn't transfer well to the next building typology or the next system configuration. Right. And so how to move forward with that is just really something that we're kind of butting our heads up against currently.
Yeah, I know that feeling.
Yeah, I think I'll just try and rephrase the comment that I made before about assuming that the data gives us a complete picture. We're in the age of big data where, someone else has better numbers than me, but, as we're speaking, we're collecting data, right? We're collecting lots of data. I think, a little hormone is released in our minds when we see we have more data. We now, more reflective of, X. And I just want to encourage us to resist the urge to assume that it's giving us the complete picture, because we know so much about how it does not. We know that, like as you mentioned, conditions for the most vulnerable are going to vary substantially from the mean, right? From the central tendency. And I think as we continue to have this discussion, it'll slowly make its way into our practice. We have all these amazing brains in here that are going to go back to their fields and, with new light and new information and, new practices. And so I'm hopeful that we'll overcome that. But I think that many of our issues, they do stem from assuming that whatever errors exist, they're ignorable because we have more data now.
Absolutely, I totally agree with that. And that's also something that we always try to embrace is just accept the fact that things are biased, data will be biased, models will be biased. Just try to accept that and then constantly push back, right? Like constantly think about how could we do a little better? Like how can we fit this gap? How can we sort of move around this area? I think that's such a powerful idea.
So just to add a bit of optimism, we can get there. I think that it's about trying to work towards understanding the nuance and understanding how to apply data sets in different contexts. So it's not just about one size fits all, obviously. It's about making sure that we have clear guidance on how to apply different tools and different data sets appropriately.
Right. And I think one of the opportunities that data really does provide is also to make sure that the model doesn't get stuck in the past. So for example, we have done some work with our county during COVID, and one thing that was striking to me is the behavioral data early COVID was very, very different than a year later, right? Like so it's just the behavior changed completely, and I think that was very powerful to have that reflected in the data, and then have a model that adjusts to that new world of things are moving forward, things are changing, and then maybe try to find a model that links the data and tries to stay in touch with people. I would love to hear from you, each one of you, and maybe we'll start with you, Ling, again, about one of the things that you tried and you thought it was a great idea, and then it just didn't work at all. So just kind of like one of those moments, I feel like I have a lot of those moments sometimes where I feel like this model would be great at this, this, and this, and then I try it, and it's just not not so suitable. So any like sort of learnings that you can offer where you thought something would really help you move towards greater equity and then it didn't quite?
Yeah, so like I have two examples. So like the first one is in the air quality modeling field. So we often think like if you look around the research papers you found or where equity issues or like regarding either exposure or health burdens were often evaluated as an afterthought, like after you already come up with the energy or technology scenario, and then you evaluate multiple scenarios and compare their trade-offs, right? So I had an idea like, how about apply the model, like how about co-optimizing, like treating the each molecule of emissions differently, like judging its importance or damages based on where and when it's emitted. And however, then I did a back of the envelope calculation. So once you have that, right, that would be great. You essentially have a geospatial and temporal data set that can be dumped into this optimization problem to do multi-objective optimization. However, then I calculated even on a supercomputer that would take about 50 years to run, right? Because all these sophisticated chemical transport models, and they are like incorporated state-of-art photochemistry and physics, and it's really cumbersome to run. So in my recent project, what I did was apply a different way to look at this, the problem. Like if you have a targeted community to protect, how about doing a reverse perturbation, like perturb the impacts on the community and see how it propagates back to all these input parameters, which is called the adjoint method. So by doing that, you only need to run the model once. You got all the parameters you need. So we've been generating that geospatial and temporal data sets, and we're looking forward to application of it. Like my dream is to having the justice, environmental justice, being evaluated as like a co-optimized together with the economic factors or greenhouse gas emission goals. And this data set will really help us to get there.
That sounds exciting. Jessica, do you have any things that you've tried and you're excited about it and then it didn't quite work out?
More than I would care to admit. One place I've definitely hit the wall was in the use of synthetic data sets. We have, so what do you turn to when you don't have sufficient measured data? You can turn to models, and particularly physics-based models. So we have really powerful models that have been built up over just decades of building science work. They're terrific. They can be exercised to represent all kinds of different typologies. You can get energy consumption profiles and equipment loads and indoor environmental conditions across many types. You can run these models at to understand different spatial and temporal resolutions, and then have a playground of data from the outputs. But what we very quickly will find is that those outputs are not reflective of the kind of stochastic variability that we observe in the field. And as it turns out, it's actually really difficult to mess up or noise up the data in a way that is realistically reflective of all the funky behaviors that we encounter. So the, occupants opening windows and doors in winter while the heating system is on. It happens all the time. It's not reflected in the way that the models are running, or silent faults or problems that are lurking across all the equipment that you otherwise would never know are there, but are not represented in the idealized instantiation in the model that you're trying to use. Operator overrides, like on and on. And so we find that we're not able to then challenge enough our solutions in a way to get a solid understanding of how they're going to behave in the field. And I would offer a call for collaboration to anyone or everyone here to be able to develop the techniques to generate enough synthetic data that will have the typological variability, as well as the different operational modes that we need to see in order for our solutions to be robust.
And to briefly follow up on that, what is the role of these personal sensors, or like, for example, purple air, or like indoor air quality sensors that are becoming more abundant? Do you feel like that helps you get a better grasp on, you know, people just forgetting to close the window? I have to admit, I'm one of those. I have to just forget. So what is the role of this sort of more personalized data?
That's a dream. More highly granular and resolved, measured data from our environments and facilities would be fabulous. The challenge being, do we have our environments instrumented well enough over, you know, we don't often have, we have data sets of convenience as opposed to data sets by design. So I think that those are just the sort of solutions that we need more and more and more of. And you know, the day of ubiquitous sensing will come, and we'll have more to feed our models.
Yeah, and I think we actually have data sets of convenience. We also have models of convenience. I think those two make a lot of convenience, but not always a lot of practicability. Tiara, do you want to share some experience from your end?
I'll, you know, at the risk of someone pointing out obvious. So when I was doing my dissertation work, I was looking at regional travel demand models and trying to understand how to perform transportation equity analysis. And so this is given a model, let's apply the model to some set of transportation scenarios. And let's look at the outcomes and look at how those outcomes are distributed across various classes. So income classes, auto ownership classes, and so on. And the problem or the challenge with that is that at the regional scale, everything is, you know, there's a need to aggregate. Sometimes in ways that are not so intuitive. And so there's an aggregation of projects. You might have one scenario that's comprised of hundreds of different types of transportation investments. And then there's also an aggregation of certain transportation dimensions. So, you know, within the region of San Francisco, there are, you know, dozens of transportation alternatives when you break down all the forms of transit, all the different levels of vehicle occupancy, all the different types of vehicles, and so forth. So there are dozens of alternatives that have to be aggregated. So you end up with aggregate transit alternatives and aggregate vehicle classes. And it turns out that when you're trying to perform equity analysis and understand, you know, how does accessibility by transit vary across the population, you end up with some results that are not so intuitive. And so, but that's the nature of how we apply these travel demand models in regions. And so in subsequent studies, what I've learned from that experience of, you know, doing this, you know, performing this analysis and arriving at my final results, which is this distributional measure, and it's like, okay, now how do I explain this? And it's based on how we aggregate alternatives. It's based on the classes of projects that we have that make up each scenario. And so, you know, there's a need to understand how to right-size these tools. Another thing that I've learned subsequently is that, you know, because of residential patterns, you know, we still live in a very segregated society. We still cluster together, whether it's based on choice or circumstance. And the implication is that you can have whole communities that are sort of swallowed in these measures, and we don't actually understand whether this regional plan is going to benefit these communities. We just don't have a clear view of it. And so that points me back again to the need for us to have better guidance on how to right-size these tools if we're going to be serious about evaluating equity outcomes.
Yeah, and maybe tools on different scales that are interconnected. I could chat with you guys forever, and I greatly appreciate the privilege of being here and being able to ask so many questions. But I also want to give one of you a chance to ask a question. If there's a burning question on your mind and you didn't get it, that you would like to weigh in on, please raise your hand if there's something. I think there's a question by the door over there. Okay, sorry. There.
Hi, I'm Katrina, one of Jenny's grad students. I'm my first year of my PhD. So thanks so much for coming to speak to us today, all the panelists. It was so interesting. So I guess I'm quite interested in augmenting sparse data. So I think it's kind of related to the synthetic data question that Jessica brought up, where I guess the call to collaborate to come up with a solution to the fact there are so many variables in constructing realistic synthetic data. And I guess in my case, I'm interested in augmenting sparse precipitation data in the Arctic. But the problem there is that I think the problem is pretty much the same in that there's just a lack of data, or like spatially and temporally, and I think that also goes to what Ling and Tiara was talking about. So I think there are obviously a lot of issues that go, or factors that go into solving this kind of problem. And I think I'd love to learn more about specific solutions to, or what you think specific solutions would be to generating the synthetic data. Like, is it that maybe we have clusters or sets of data that specifically answer a very specific question with regards to the equalities or inequalities that we're trying to better understand. Yeah.
Thank you. Great question. We only have a few minutes left, so maybe a lightning quick response. Who would like to?
I would love to talk more off the podium with you. The short answer is, I don't know. We have some high confidence in limited data sets reflective of actual conditions. We have very good physics-driven models. We have extremely powerful statistical methods to understand and begin to characterize the stochastic variability that exists in the measured data. And how to combine those three things is it's an incredibly non-trivial problem, and that's why I say let's collaborate, because I do not know how to solve it.
That sounds great. I think there was one more question. If you can make it super quick, that'd be great.
Hi, my name is Hana Atik. I have actually a pretty basic question. One of the things that I feel I'm trying to explore is understanding what field to specifically choose within data science. I do understand that the skill set can be transferred, but how are you guys able to find your journey on what fields you want to focus on within the data science world?
Ling, what was your story?
That was a great question. Actually, I started as a master's student in energy resources at UC Berkeley. And one of the classes that the faculty members offer was climate uncertainty, and it's a major topic in one of the class. And I felt like, how can I quantify the uncertainties? And then I thought about the statistics. So I went to basically the stat department and got a second master's degree in it. And then it turned out I was not that, I was too naive. Like, the uncertainties came from I think a majority from the like in economic sense or policy sense, rather than the data sense. So it's so uncertain that you can't predict human in an accurate way. But I ended up acquiring the skills, and that helped me like down the stream to like since I got training in environmental engineering as well as resource economics. So combining the domain knowledge with the statistical skills I acquired made me a pretty good data scientist.
And I think this is a question we can all ask each other over lunch. How did you end up where you are? But I wanted to just take this opportunity to thank all of you for a fantastic panel. Thank you, Jenny, for moderating. Yeah. Thank you, Chera, Jessica, Jinling. And I welcome you to come off the stage. You can leave your chair now. I know it's very comfortable. Now, before we close for lunch, I just wanted to comment on, we started really cold. Then we got very hot, and I'm thinking I'm just having hot flashes. But no, what we were actually doing is collecting data for Jessica. Right? Anyway, we have reached the end of this morning, and I've really thoroughly enjoyed the diversity of speakers, the diversity of topics. I hope it inspired you. I just wanted to thank all the speakers from this morning and ask you to just join me in a big round of applause and thank them. It's just been fantastic. And we have lots and lots to chat about during lunch. For those of you on the live stream, you're going to now be seeing interviews and meet the speakers from our media collaborators, theCUBE, which is going to be very nice. For those of you on Hopin, you can join the Career Expo and meet a lot of our sponsors, or you can do networking, so I hope you really enjoy that. And for all of you here, it's time to connect with more people, to have some lunch, and to have some more coffee and caffeine so we can come back strong at 1 o'clock. I look forward to walking around and meeting many of you. We have the run of the place today, so you can find any place outside, in the back, hallway, anywhere, and spread out and enjoy. And we'll be back here at 1 p.m. exactly, Pacific time, for a keynote with Vidya Sedler. See you then.
Live from Stanford University, it's theCUBE, covering Stanford Women in Data Science 2020. Brought to you by SiliconANGLE Media.
And welcome to theCUBE. I'm your host, Sonia Tagare, and we're live at Stanford University covering the 5th annual WiDS Women in Data Science Conference. Joining us today is Talithia Williams, who's the Associate Professor of Mathematics at Harvey-Mudd College and host of Nova Wonders at PBS. Talithia, welcome to theCUBE.
Happy to be here. Thanks for having me.
So you have a lot of roles, so let's first tell us about being an Associate Professor at Harvey-Mudd.
Yeah, I've been at Harvey-Mudd now for 11 years, so it's been really a lot of fun. I'm in the math department, but I'm a statistician by training. So I teach a lot of courses in statistics and data science and things like that.
Very cool.
Yeah.
And you're also a host of a PBS show called Nova Wonders. Tell us more about that.
Yeah, that came about a couple years ago. Folks at PBS reached out. They'd seen my TED Talk and they said, hey, it looks like you could be a fun host of this science documentary show. So Nova Wonders is a 6-episode series that kind of takes viewers on a journey of what the cutting edge questions in science are. So I got to host the show with a couple other co-hosts and really think about what are animals saying, and so we got some really fun episodes to do. What's the universe made of was one of them. What's living inside of us. that was definitely a gross one to do, but yeah, fun to figure out all the different microorganisms that live inside our body. So
That's so
it's
cool.
been fun to host that show as well.
And do you talk about data science and AI and all that stuff on?
Yeah, one of the episodes, Can We Build a Brain, was dealt with a lot of data, big data, and artificial intelligence, and how good can we get, how good can computers get, and really sort of compared it to what we see in the movies. We're a long way away from that, but it seems like we're getting better every year at building technology that is truly intelligent. Yeah.
And you gave a talk today about mining for your own personal data. So give us some highlights from your talk.
Yeah, so that talk sort of stemmed out of the TED Talk that I gave on owning your body's data. And it's really challenging people to think about how they can use data that they collect about their bodies to help make better health decisions. And so ways that you can use like your temperature data or your heart rate data, or what does this data say over time? What does it say about your body's health? And really challenging the audience to get excited about looking at that data. We have so many devices that collect data automatically for us, and often we don't pause long enough to actually look at that historical data. And so that was what the talk was about today. Like, here's what you can find when you actually sit down and look at that data.
Well, what's the most important data you think people should be collecting about themselves?
Well, definitely not your weight, because I don't want to know what that is every day. It depends. I think for women who are in the fertile years of life, taking your daily waking temperature can tell you when your body's fertile, when you're ovulating. It can, so that information could give women during that time period really critical information. But in general, I think it's just a matter of being aware of how your body is changing. So for some people, maybe it's your blood pressure or your blood sugar. If you have high blood pressure or high blood sugar, those things become really critical to keep an eye on. And I really encourage people, whatever data they take, to be active in the understanding of and interpretation of the data. So it's not like if you take this data, you'll be healthy, you'll live till 100. It's really a matter of challenging people to own the data that they have and get excited about understanding the data that they are taking. So
absolutely, putting people in charge of their own bodies.
That's right, yeah.
And actually, speaking about that, in your TED Talk, you mentioned how you were, your doctor told you to have a C-section, and you looked at the data and you said, no, I'm going to have this baby naturally. So tell us more about that.
Yes, you should always listen to your medical professionals. But in this case, I will say that it was definitely more of a dialogue, and so I wasn't just sort of trying to lean on the fact that like I have a PhD in statistics and I know data. It was really kind of objectively with the on-call doctor at the time, looking at the data and talking about it. And this doctor this was his first time seeing me, and so I think it would have been different had my personal midwife or my doctor been telling me that, but this person sort of only looked at this one chart and was making a decision without thinking about my historical data. And so I tried to bring that to the conversation and say, like, let me tell you more about, my body, and this is pregnancy number 3, like, here's how my body works. And I think this person in particular just wasn't really hearing any of that. It was like, here's my advice, we just need to do this. And I'm like, well, And so as gently as possible, I tried to really share that data. And then it got to the point where it was sort of like, either you're gonna do what I say or you're gonna have to sign a waiver. And we were like, I think we'll just sign the waiver.
Right.
And so that caused quite a buzz in the hospital that day, but we came back and had a very successful labor and delivery. And so, yeah, it was a good decision at the time. But, with that caveat that you should listen to what your doctor says. So.
Yeah, I mean, there's really interesting, like, what's the boundary between, like, what the numbers tell you and what a professional tells you?
That's right, because I don't have an MD, right? And so, I'm cautious not to overstep that. But I felt like in that case, the doctor wasn't really even considering the data that I was bringing. We were actually induced with our first son. But again, that was more of a conversation, more of a dialogue. Here's what's happening. Here's what we're concerned about. And the data to really back it up. And so I felt like in that case, like, yeah, I'm happy to go with your suggestion. But by kid number 3, it was just like, no, this isn't really, yeah.
Right. So you also wrote a book called Power in Numbers, The Rebel Women of Mathematics. So what inspired you to write this book, and what do you hope readers take away from it?
Yeah, a couple different things. I remember when I saw the movie Hidden Figures, and I spent 3 summers at NASA working at JPL, the Jet Propulsion Laboratory, And so I had this very fond connection to, having worked at NASA. And when this movie came out and I'm sitting there watching it and I'm like bawling, just crying. And, I'm like, I didn't know that there were Black women who worked at NASA like before me, And so it was just so transformative for me to see these stories just sort of unfold. And I thought, like, well, why didn't I learn about these women growing up? Like, imagine had I known about the Katherine Johnsons of the world, maybe that would have really inspired not just me, but thinking of all the women of color who aren't in mathematics or who don't see themselves working at NASA. And so for me, the book was really a way to leave that legacy to the generation that's coming up and say, like, there have been women who've done mathematics and statistics and data science for years, and there are women who are doing it now. So about a third of the book are women who are still here and like active in the field and doing great things. And so I really wanted to highlight sort of where we've been, but also where we're going and the amazing women that are doing work in it. And it's very visual. So some folks are like, oh my gosh, women in math. And it's really like a very picturesque book of showing these beautiful images of the women and their mathematics and their work. And yeah, so I'm really proud of it.
That's awesome.
Yeah.
And even though there is like greater diversity now in the tech industry, there's still very few African American women, especially, who are part of this industry. So what advice would you give to those women who feel like they don't belong?
Yeah, well, they really do belong. And I think it's also incumbent of people in the industry to sort of recognize ways that they can be advocate for women, and especially for women of color, because often it takes someone who's already at the table to invite other people to the table. Like, I can't just walk up and be like, move over, get out the way, I'm here now. But really being thoughtful about who's not represented and how do we get those voices here. And so I think the onus is often more on people who occupy those spaces already to think about how they can be more intentional in bringing diversity into those spaces.
And going back to your talk a little bit, how should people use their data?
Yeah, so I mean, I think the ways that we've used our data have been to change our lifestyle practices. And so, for example, when I first got a Fitbit, it wasn't really that I was like, oh, I have a goal. It was just like, I want something to keep track of my steps. And then I'd look at them and say like, well, gosh, I didn't even do anything today. And so I think having sort of even that baseline data gave me a place to say, okay, let me see if I can hit 10,000 steps in a day. And so in some ways, having the data allows you to set goals. Some people come in knowing like, I've got this goal, I want to hit it. But for me, it was just sort of like, And so I think that's also how I've started to use additional data. So when I take my heart rate data or my pulse, I'm really trying to see if I can get lower than how it was before. So the push is really like, how is my exercise and my diet changing so that I can bring my resting heart rate down? And so having the data gives me a goal to push toward, and it also gives me that historical information to see like, oh, like this is how far I've come, like I can't stop now,
That's a great social impact.
That's right, yeah, absolutely.
And do you think that, so in terms of a security and privacy point of view, like if you're recording all your personal data on these devices, how do you navigate that?
Yeah, that's a tough one. I mean, because you are giving up that data privacy. I usually make sure that the data that I'm allowing access to is sort of data that I wouldn't care if it got published on the cover of, the New York Times. Maybe I wouldn't want everyone to see what my weight is, but, and so in some ways, while it is my personal data, there's something that's a bit abstract from it. Like it could be anyone's data, as opposed to say my DNA. Like I'm not gonna do a DNA test. I don't want my DNA to be mapped and out there for the world. But I think that's increasingly become a concern because people are giving access of their information to different companies. It's not clear how companies would use that information. So if they're using my data to build a product or make a product better, we don't see any royalties from that. We don't have the benefit of it, but they have access to our data. And so I think in terms of data privacy and data ethics, there's a huge conversation to have around that. And we're only kind of at the beginning of understanding what that is, yeah.
Well, thank you so much for being on theCUBE. Really awesome having you here.
Thank you, thanks for having me, yeah.
I'm Sonia Tagare. Thanks so much for watching theCUBE and stay tuned for more.
Live from Stanford University, it's theCUBE. Covering Stanford Women in Data Science 2020. Brought to you by SiliconANGLE Media.
Hi, and welcome to theCUBE. I'm your host, Sonia Tagare, and we're live at Stanford University covering the 5th annual WiDS Women in Data Science Conference. Joining us today is Ya Xu, the head of data science at LinkedIn. Ya, welcome to theCUBE.
Thank you for having me.
So tell us a little bit about your role and about LinkedIn.
So LinkedIn is, first of all, the biggest professional social network where we have a massive economic graph that we have been creating with millions, actually close to 700 million members, and millions of companies and jobs, and of course, with students of skills and also schools as well as part of it. And I lead the data science team at LinkedIn, and my team really spans across the global presence that LinkedIn's offices have, really working on various different areas that both thinking about how we can iterate and understand and improve our products that we deliver to our members and our customers, and also at the same time thinking about how we can make our infrastructure more efficient, thinking about how we can make our sales and marketing more efficient as well. So really span across.
And how has the use of data science evolved to deliver a better user experience for users of LinkedIn?
Yeah, so first of all, I think LinkedIn is in general, we truly believe that everybody can benefit from better data access in general. So we certainly, with using data to continuously understand better of what our members are looking for. As a simple example is that whenever we launch a new feature, we are not just blindly decide ourselves that this is the better feature for our members, but we actually understand how our users reacting to it, right? So we use data to understand that, and then certainly making decisions and whether we should be eventually launching this feature to all members or not. So that's a very prominent way for us to use data. And obviously we also use data to understand and just even before we're building certain features, is this sort of feature that's right feature to build? We do both survey and understand the survey data, but also at the same time understanding just user behavior data for us to be able to come up with better features for users.
And do you use A/B testing as well?
Oh, absolutely. Yeah. So we do lots of A/B experiments. That's what I was not trying to use that word, but that terminology. But this is what we use to have an understanding of is the features that we are developing that we are putting in front of our users. Is that what they enjoy as much as we think they would enjoy?
Right. So you had a talk today about creating global economic opportunities with responsible data. So give us some highlights from your talk.
So, first of all, at LinkedIn, we truly believe in the vision that we are working towards, which is really creating economic opportunity for every member of the global workforce. And if you're kind of starting from that and thinking about that is our sort of the axiom that we're working towards, and then thinking about how you can do that, and then obviously the sort of the table stake or just the fundamental thing that we have to start with is to be able to preserve the privacy of our members as we are leveraging the data that our members entrust with us, right? So how can we do that? We have some early effort in using and developing differential privacy as a technique for us to do a lot better with regarding preserving that privacy as we're leveraging the data. But also at the same time, it doesn't end there, right? Because you're thinking about creating opportunity. It's not just about let's preserve the privacy, but also when we are leveraging the data, how can we leverage the data in a way that is able to create opportunity in a fair way? So there is also a lot of effort that we're having with regarding how can we do that and what does fairness mean? What are the ways we can actually turn some of the key concepts that we have into action that is really able to drive the way we develop product, the way that we're thinking about responsible design, and the way that we build our algorithms, the way that we measure in every single dimension.
And speaking about that bias, at the opening address, they mentioned that diversity is really great because it provides many perspectives and also helps reduce this bias. So how have you at LinkedIn been able to create a more diverse team?
So first of all, I think it's certainly there is a, we all believe that diversity is certainly better as we're building product. Thinking about if you have a diverse team that is really a representation of the customers and the members that you're serving, then you definitely are better to be able to you are able to come up with better features that is able to serve the needs of the population of our member. But just also at the same time, that's just the right thing to do as well, right? Thinking about we all have had experiences we may not feel as much belong when we walk into a room that we are the only person that we identify with to be in that room. And we certainly wanted to be able to create that environment for all the employees as well. And thinking about, I think there is also studies that has done as what makes a high-performing team. Some of the studies that's done at Google with the psychological safety aspects of it, which is really, there's a lot of brain science that says when you make people feel they belong, that they will actually be so much more creative and innovative and everything, right? So we have that belief. But tactically, there are many things that we're doing from all the DIBS aspect, right? How can you bring diversity, inclusion, and belonging, starting from hiring, right? So we certainly are very much emphasized on how can we increase the diversity of individuals that we're bringing to LinkedIn, and when they are at LinkedIn, can we make them feel more belonged and then feel more included in every aspect? We have different inclusion groups, right? We have, obviously I'm very much involved in Women in Tech at LinkedIn. We have both many efforts that we do to help women at LinkedIn in engineering and in other groups as well to feel they belong to this community. At the same time, there is concrete actions that we're taking too, right? That we are helping women to have a much better understanding and aware of some of the ways that we operate that is slightly different from maybe our male colleagues would operate, right? There are certain things that we're doing to change the current processes, hiring processes, promotion process, that we are able to bring more equal footing to the way that we're thinking about gender gap and gender diversity.
Right, that's great. And what advice would you give to women who are just starting college or who are just out of college, who are interested in going into data science?
So I want to say the biggest learning for me is just have that can-do attitude. The woman biologically and or just like in every way, we're not any less than men, and you certainly have seen many strong and very talented women that we have in the field. So don't let people's perception or biases around you to bring you down, and then thinking about what you wanted, and then just go for it, and then go for the advice that you can get from people. And then there are so many, and you can see in the conference today, so many talented women that you can reach out to who are willing and very willing to help you as well.
And in this age of AI and ML, where do you see data science going in the future?
That's a really interesting question. So in the way that data science, I want to say it's a field that is really broad, right? So if you're thinking about things that I would consider to be part of data science may not necessarily be part of AI, some of the causal inference that is extremely popular and important, and then I think the fields will continue to evolve. There are going to be, and then the fields are continually overlapping with each other as well. You cannot do data science without understanding or have a strong skill in AI and in machine learning. And you also you can't do great machine learning without understanding the data science either, right? So thinking about some of the talk that Daphne Kohler earlier was sharing, as in, you can blindly run your algorithm and without realizing the bias that all the algorithm is really just detecting the machines that's used in the images versus actually detecting the difference between broken bones or not, right? So I think having I do see there is a continuously big overlap, and I think the individuals who are involved in both communities should continue to be very comfortable being in that way too.
Right. Yeah, thank you so much for being on theCUBE, and thank you for your insight.
Of course, thank you for having me.
I'm your host, Sonia Tagare. Thank you for watching theCUBE, and stay tuned for more.
Hey everyone, welcome to theCUBE's coverage of Women in Data Science 2022. I'm Lisa Martin, excited to be coming to you live from Stanford University at the Arriaga Alumni Center. I'm pleased to welcome, fresh from the keynote stage, Alex Hanna, the Director of Research at the DARE Institute. Alex, it's great to have you on the program.
Yeah, lovely to be here.
Talk to me a little bit about yourself. I know your background is in sociology. We were talking before we went live about your hobbies and roller derby, which I love.
Yes.
But talk to me a little bit about your background and what the DARE Institute, this is Distributed AI Research Institute, what it actually is doing.
Sure, absolutely. So happy to be here talking to the women in data science community. So my background is in sociology, but also in computer science and machine learning. So my dissertation work was actually focusing on developing some machine learning and natural language processing tools for analyzing protest event data and generating that, and applying it to pertinent questions within social movement scholarship. After that, I was faculty at University of Toronto and then research scientist at Google on the ethical AI team, where I met Dr. Timnit Jabru, who's the founder of DARE. And so DARE is a nonprofit research institute oriented around independent, community-based AI work, focused really on, the kind of lots of discussions around AI are done by big companies or companies focus on solutions that are very much oriented around collecting as much data as they can, not really knowing if it's going to be for community benefit. At DARE, we want to flip that. We really want to prioritize what that would mean if communities had input into data-driven technologies, what it would mean for those communities, and how we can help there.
Double click into some of your research. Where do your passions lie?
So I'm a sociologist, and a lot of that being, I think one of the big insights of sociology is to really highlight at how society can be more just, how we can interrogate inequality and understanding how to make those distances between people who are underserved and overserved, who already have quite a lot, how we can reduce the disparities. So finding out where that lies, especially in technology, that's really what I'm passionate about. So it's not just technology, which I think can be helpful, but it's really understanding what it means to reduce those gaps and make the world more just.
And that is so important. I mean, as more and more data is generated, exponentially growing, so are some of the biases and the challenges that causes. You just gave your Tech Vision talk, which I had a chance to see most of it, and you were talking about something that's very interesting, that is the biases in facial recognition software.
Yeah.
Tell me a little bit about what you talked about and why that is such a challenge, and also, what are some of the steps being made in the right direction where that's concerned?
Yeah, so there's the work I was talking about in the talk was highlighting, not work I've done, but the work by Drs. Joy Buolamwini and Timnit Jabru, focusing on the distance that exists and the biases that exist in facial recognition as a technical system. The fact remains also that facial recognition is used and is disproportionately deployed on marginalized populations. So in the US, that means Black and brown communities. That's where facial recognition is used disproportionately. And we also see this in refugee contexts where refugees will be leaving country, and those facial recognition software will be used in those contexts and surveilling them. So these are people already in a really precarious place. And so some of the movements there have been to de-bias some of the facial recognition tools. I actually don't think that's far enough. I'm fundamentally against facial recognition. I think that it shouldn't be used as a technology because it is used so pervasively in surveillance and policing. And if we're going to approach that, we really need to rethink our models of security, models of immigration, and whatnot.
Right, it's such an important topic to discuss because I think it needs more awareness about some of the biases, but also to your point about some of those vulnerable communities that are really potentially being harmed by technologies like that. We have to be, there's a fine line, or maybe it's not so fine.
I don't think it's that fine, actually. I think it's used, in an incredibly harsh way. And for instance, there's research that's being done in which, so I'm a transgender woman, and there's research being done by researchers who collected data sets that people had on YouTube documenting their transitions. And already there was a researcher collecting those data and saying, well, we could have terrorists or something take hormones and cross borders. And you talk to any trans person, you're like, well, that's not how it works, first off. Right. Second off, it's already viewing trans people and the trans body as kind of a mode of deception. And so that's, whereas researchers in this space were collecting those data and saying that, well, we should collect these data to help make these facial recognitions more fair, but that's not fair if it's going to be used on a population that's already intensely surveilled and held in suspicion.
Right, the question of fairness is huge. Absolutely. Were you always interested in tech? You talked about your background in sociology. Was it something that were you a STEM kid from the time you were little? Talk to me about your background and how you got to where you are now.
Yeah, I've been using computers since I was 4. I was taking apart, my parents' gateway computer.
Oh, you're one of those kids.
When I was,
love that.
Yeah, when I was 10, going to computer shows, slapping hard drives into things, seeing how much we could upgrade computer on our own, and ruining more than one computer to my parents' chagrin. But I've always been that. I went to undergrad in triple major in computer science, math, and sociology. And originally just in computer science, and then out of the other two, more I got interested in things and understanding that I was really interested in this intersection of tech and society. And I think the more and more I sat within the field and went and did my graduate work in sociology and other social sciences, really found that there was a place to interrogate that intersection of the two.
Exactly. What are some of the things that excite you now about where technology is going? What are some of the positives that you see?
I talk so much about the negatives. It's really hard to. I mean, I think, some of the things that I think that are positive are really the community-driven initiatives that are saying, well, what can we do to remake this in such a way that is going to be more positive for our community? And so seeing projects like that try to do community control over certain kinds of AI models, or really try to tie together different kinds of fields, I mean, that's exciting. And I think right now we're seeing a lot of people that are super politically and justice literate, and they know how to work, and they know what's behind all these data-driven technologies, and they can really try to flip the script and try to understand what would it mean to kind of turn this into something that empowers us instead of being something that is really becoming centralized in a few companies.
Right, we need to be empowered with that for sure. How did you get involved with WiDS?
So Margot, one of the co-directors, we sit on a board together, the Human Rights Data Analysis Group, and I've been a huge fan of HR DAG for a really long time, because HR DAG is probably one of the first projects that I've seen that's really focused on using data for accountability, for justice. Their methodology has been, called on to hold perpetrators of genocide to account, to hold state violence perpetrators to account, and I always thought that was really admirable. And so being on their board is sort of kind of a dream, not that they're actually coming to me for advice. So I met Margot, and she said, come on down and let's, do a thing for WiDS, and I happily obliged.
Is this your first WiDS?
This is my very first WiDS.
Oh, excellent.
Yeah.
What's your interpretation so far?
I'm having a great time. I'm learning a lot, meeting a lot of great people, and I think it's great to, bring folks from all levels here, not only, people who are super senior, which they're not going to get the most out of it. It's going to be the high school students, the undergrads, grad students, folks who, and, you're never told to be mentored, so, finding your own mentors too.
Mm-hmm. It's so great to see the young faces here and the mature faces as well. But one of the things that I caught in the panel this morning was the talk about mentors versus sponsors. And that's actually, I didn't know the difference until a few years ago at another Women in Tech event. And I thought it was such great advice for those panelists to be talking to the audience, talking about the importance of mentors, but also the difference between a mentor and a sponsor. Who are some of your mentors?
Yeah, I mean, great question. It's gonna sound cheesy, but my boss, Janija Brew, I mean, she's been a huge mentor for me, and with her and another mentor, Meg Mitchell, I wouldn't have been a research scientist. I was the first social scientist on the research scientist ladder at Google before I left, and if it wasn't for they did sponsor, but then they also mentored me, greatly. My PhD advisor, Pam Oliver, huge mentor of mine, and I mean lots of primarily, and then peer mentors, people that are kind of at the same stage as me academically, but also. And professionally, but are mentors. So folks like Anna Lauren Hoffman, who's at the UW, she's a great inspiration and collaborator and co-conspirator. So yeah.
Co-conspirator, I like that.
Yeah.
I'm sure you have quite a few mentees as well.
Yeah.
Talk to me a little bit about that and what excites you about being a mentor.
I have a lot of mentees, either informally or formally, and I sought that out purposefully. I think one of the speakers this morning on the panel was saying, if you can mentor, do it, and that's what I did, and sought out that. I mean, it excites me because folks, I don't have all the answers. No one person does. Yeah. You only get to those places if you have a large community, and I think being smart is often something that people think comes like, there's kind of like a smart gene or whatever, but and there probably is. Like, I'm not a biologist or a cognitive anything, but what really takes cultivation is being kind and really advocating for other people and building solidarity. And so that's what mentorship really means to me, is building that solidarity and really trying to lift other people up. I mean, if I'm only here and where I'm at in my career because many, many people were mentors and sponsors to me, and it's only right to pay that forward.
I love that, paying that forward. That's so true. There's nothing like a good community, right?
Yeah.
I mean, there's so much opportunity that groundswell just generates, which is what I love. Tomorrow is International Women's Day.
Yes.
And if we look at the numbers, women are 50% of the workforce, but only less than a quarter in STEM positions. What's your advice and recommendation for those young girls who might be intimidated or might be being told, even to this day, no, you can't do physics, you can't do computer science?
Yeah.
What do you tell them?
Yeah, I mean, so individual solutions to that are putting a Band-Aid on a very big wound. And I mean, I think finding other people and working to change it. I mean, I think building structures of solidarity and care are really the only way we'll get out of that.
I agree. Well, Alex, it's been great to have you on the program. Thank you for coming and sharing what you're doing at DARE, the intersection of sociology and technology. It was fascinating. And your roller derby, we'll have to talk more about
yeah,
that.
For sure.
Excellent.
Yeah.
Thanks for joining me.
Yeah, thank you, Lisa.
For Alex Hanna, I'm Lisa Martin. You're watching theCUBE's coverage live of Women in Data Science Worldwide Conference 2022. Stick around, my next guest is coming right up. Hey everyone, welcome to theCUBE's live coverage of the Women in Data Science Worldwide Conference 2022. I'm your host, Lisa Martin, coming to you live from Stanford University. I'm pleased to welcome fresh from the main stage, Tina Hernandez-Boussard, the Associate Professor of Medicine here at Stanford. Tina, it's great to have you on the program.
Thank you so much for this opportunity. I love being here, and I've been coming to WiDS for many years, so it's exciting to be part of this and participate.
It is exciting. It's one of my favorite events, as I was telling you before we went live. And if you think about, they only started back in 2015.
Yes.
And how it's now, it was a one-day technical conference, and now it's this worldwide
It's amazing
phenomenon in 60 countries, and just 200 different local events.
Exactly.
Talk to me about, I caught part of the panel that you were on this morning,
Yes,
and one of the things that I love that you were talking about was mentors and sponsors. Talk to me about what you guys were talking about on the panel overall, and some of who your mentors were as you came up in your career.
So mentorship is so important, and really it makes a difference in people's careers. So I come from first generation family. No one in my family has had any higher education. So having a mentor, an academic mentor, was just made all the difference in the world for me. So I started undergraduate, and I was immediately paired with somebody, a mentor, because I was first generation. And this person, he's no longer with us today, but he believed in me, and he opened doors for me, and he opened my eyes to all of these different opportunities. And having somebody who believes in you and really can help you pursue these other ideas it's so important. And so we talked about, in the panel, we talked about the importance of, having a mentor, but we also talked about the importance of being a mentor. And helping people and students coming into the field, find their place and develop, the confidence that, this is for everybody. There's something for everybody here, and you've got to try. You've got to put your name out there, and having support is really important.
Oh, it's critical. Even some interviews I was doing last week for International Women's Day, which is tomorrow. I was surprised at the number of women that I talked to who said, well, I was told no. No, you can't study computer science. No, you can't study physics. And talking
this is a really difficult field. Are you sure you want to pursue this? Well, yeah,
Yeah, instead of, so having those mentors and that encouragement to help build that confidence from within is a game changer.
Absolutely.
Tell me a little bit about your research.
Yeah, so we do, we use electronic health data, all types of different health data, to really define and predict, prognose healthcare outcomes. We develop AI algorithms, tools to analyze the data, and we really try and, one, incorporate the patient's voice in the tools we develop, and two, we try and get those back to point of care. So I think a lot of emphasis has been about model development and model performance, and we really focus on, okay, that's great, but it's only useful if we can get it back to the hands of the clinician, back to the patients to really improve health outcomes. And so that's a big piece of what we do, and as part of that, understanding patient values and patient preferences is really a big, important aspect of developing optimal treatment and optimal models.
That's good, involving them in the process. How can data science promote health equity? First of all, what is health equity, and how can data science help drive it?
So health equity is really an important topic, and there's a lot of different definitions about what is health equity. Health equity, what we want is equal outcomes, and that's not equal resources. And so a lot of times there's this contingency behind, are we trying to be, have equal resources for every patient, or is it equal outcomes? And so we really focus on equal outcomes. We want everyone to have the opportunity to have the same outcomes. So health equity requires that we really think about different populations and their different needs, different preferences, et cetera. So that's what we focus on. And so to your question about, how data science can promote health equity, one of the things we've been working on is really thinking about the gold standard of clinical care, which is the clinical trial, right? So a clinical trial is our gold standard for what treatments work, in what situations, and for what populations. However, a lot of the clinical trials are developed in a non-representative population. Right, so we have to have patients who can come into the care setting at multiple times during a period. They can't have particular diseases. They can't, for example, in one particular trial we were looking at, they had to have a specific BMI. They couldn't have diabetes. They couldn't have all of these other healthcare conditions, which at the end of the day, it doesn't really represent the community at risk, right? And so when we develop these models using clinical trial data, a lot of times it's not generalizable to routine care. And so AI can really help that. AI can help us understand, how we can better identify patients to include in trials, what patients are going to be more likely to complete the trials. And so there's a lot of opportunity there to think about how we diversify clinical trials and also how we can start thinking about simulating and doing pragmatic clinical trials if we don't have enough data to represent certain populations.
Right, one of the exciting things about data science is all of the things that it's informing. It's also, it can be, there's pros and cons.
Absolutely.
Right? But when we talk about AI, we always talk about ethics. How is it being used in healthcare? How are you seeing it being used ethically and effectively in healthcare to really turn the table on some of those biases that, to your point, weren't representing some of the most vulnerable parts of the community?
Right. And I think we've been taking this holistic approach of the AI life cycle. So not just focusing on the data we capture, but the whole life cycle. So what does that mean? That means, where's the data coming from? Who's capturing it, and in what setting, right? If we're only looking at the healthcare setting, well, we're missing another large population. If it's only collected via a mobile device, there's another big population we're missing. So thinking about where the data is coming from, and then thinking about who it represents and who's missing from that. The next step is really thinking about the questions we're asking. I'll give you a good example. We can ask, can I use AI to predict a no-show appointment? Or can I use AI to identify barriers for this patient to access care? So really even thinking about how we can flip that question to make it more equitable, make it more diverse is really important. And then there's been a lot of work in model development and algorithmic fairness, and so there's a lot of research on that. But then there's another piece that we don't really see a lot on, and that's model deployment. So what are the biases when you introduce this into the healthcare system? The clinicians, how do they understand the data we're giving them, the tools, how do they use that to make clinical decisions? And then also, what systems can actually deploy these AI algorithms, because they're very resource intensive. So we think about the AI and equity along all of those aspects of the AI lifecycle, and it really helps us get a more holistic view because each of these components intersects.
They do, you're right.
Yeah.
Tell me, I'm curious a little bit about your background. So you are Associate Professor of Medicine here at Stanford, but give the audience an overview of the path that you took to get where you are.
Yeah, and so not a straight path, which is, often typical that we're hearing today. So I started getting a master's in epidemiology and public health. And from there, I was like, I wasn't really sure what I wanted to do. I applied to medical school, but I'm like, I'm not sure that's what I want to do. So I went and got a PhD in computational biology. I'm always data savvy. And so thinking about how I could use data, and then I was interested in healthcare. And so I got my PhD in computational biology. And from there, I was thinking about, I was really interested in the application of data science to the healthcare field. So then I got a master's in health services research. So it's the combination of all these different degrees that make me really have, I think, a diverse view. I really understand the need for multidisciplinary teams and how we need opinions and viewpoints from so many different disciplines to really create something that's equitable and fair and something that is feasible and usable.
Thought diversity is so important
in
every aspect of life, whether we're talking about business life, personal life, and without it, there's bias.
Absolutely, absolutely. And so we see this, we'll have a clinician maybe come to us with a question, and then we'll have, the health economists think about it, we'll have the other people think about it, and we kind of work it, and we massage it to get to something that's meaningful and something we can really use that's going to change care for patients or particular patients. And so it's really important to have that diversity.
Absolutely. Talk to me about your team that's working
Yeah,
with you
so
now.
my team is very diverse, and I'm very proud of that. We have diversity across every aspect. So we have racial ethnic diversity. We're probably about 80% female on my team. And so interestingly, one of my members was like, wow, I didn't realize I'm like such a minority on your team. It was a male. And so I'm like, and I'm very proud of that. But we also have very diverse disciplines. So we have a lot of medical students, medical faculty. We have computer scientists, engineers, epidemiologists, health policy experts. And so it's very, very diverse. And what I like to do is I like to pair people up in teams. So I might put a health economist with a computer scientist and watch them go. And it's just amazing how they can learn from each other and the directions they go in. It's really incredible.
Well, and the opportunities that interdisciplinary relationship builds. I mean,
Right.
opportunities and possibilities must be endless.
Yeah, and it also allows students to understand how to speak to different groups because we don't speak the same language. We really don't. And equity is a good example. So equity to me might have a certain meaning, but equity to, the health policy expert might have a different meaning. And so even, understanding how we speak to other groups is so important, and being able to translate something in a simple language that other people get is really key.
Absolutely.
Yeah.
Here we are. Tomorrow is International Women's Day.
Exciting.
And it is exciting. In Women's History Month, we get a whole month to ourselves, which is
Love it.
fantastic. But one of the things, when we look at the data, 50, the workforce 50-50, males and females, but the STEM positions are still so low, below 25%. Are you seeing, obviously WiDS is a positive step in that direction to start shifting that, but what do you tell the younger set in terms of
it is a
pursuing
challenge.
their interests?
It is a challenge to really, and this is the example I always give, as a woman, we've all walked into these rooms that are all male.
Oh, yes.
We've all walked into these rooms where you're sitting at the table, oh, can you take notes? And it's hard. It's really hard. But you know what? It takes courage. So again, that mentorship, being able to speak up, being able to set your place at that table, I think is really important. And we're doing better, but it really is through consistent mentorship, consistent confidence building, et cetera.
It is.
Yeah.
And this event is fantastic for that. It's going to reach about 100,000 people annually.
Amazing. Yeah.
Men and women of all ages, of all different career backgrounds, which is fantastic. Yeah. But the International Women's Day theme tomorrow is breaking the bias, #breaking the bias.
Yes.
Where do you think we are on that?
I think we have a lot of ways to go,
Yeah.
right? And so there's bias in our teams, there's bias in the way we think, there's bias in our data. And there's been a lot of publicity and hype about the bias in the data. And it is so true, and certainly in healthcare systems. And it's important to understand that when we're developing AI and all these machine learning or data-driven models, they learn from the data we give it. So if we're giving it a biased data sample or an unrepresentative data sample, it's going to learn those characteristics. And so I think it's important that we think about, how do we do a better job at capturing data, diversity, voices from different populations? And it's not just using the same tools and technology we have today and going to another community and saying, okay, here's what I have. It's not working that way. So I think we need to think outside of the box to think, how do these people want to communicate with us? How do they want to share our data? It's about trust too, because trust is a big issue with that. So I think there's a lot of opportunities there to just further develop that.
Do you think there really is going to be such a thing one of these days of a non-biased, unbiased set of data?
I don't think so. I don't think so, because the more we dig, the more biases we find. And so while we're making great strides in race and ethnicity diversity in our data sets, there's other biases, male, female, age biases, disease biases, et cetera. So just the more we dig into this, the more we identify. But it's great, because when we find these gaps in our data or gaps, we take steps to address that and to mitigate those biases. So we're moving in the right direction for sure. And putting a spotlight on it and being transparent about it, I think, is key to move forward.
I agree. That transparency is critical.
Yes, absolutely.
And we often say she can't be what she can't see.
Right.
And so from a transparency perspective in the data, and also in the visibility of the leaders and the mentors and the sponsors, that transparency is table stakes.
Absolutely, absolutely.
What are some of the things that you're looking forward to as we hopefully move out of the pandemic into the endemic? I can imagine with a master's in public health, you have an MPH?
Yes.
Your perspectives must be so interesting on living through a global pandemic.
It is, and it's interesting because we've gone through the pandemic and now it's turning into this endemic, right? And so how do we deal with that? And one of the things I think that is really important is we find a way to still meet and collaborate face-to-face, share ideas. This conference is amazing, where we can share ideas, we can meet new people, we can learn new perspectives, and being able to continue to do that is so important. I think that during the pandemic, we really took a big hit in the transfer of learning in our labs and in our teams. And now it's funny, because my team, they're like, let's go to lunch, let's do a happy hour, they just want that social interaction. And it's more to better understand the perspectives of where they're coming from with their questions, better understanding the skills they bring to the table. But it's just this wonderful opportunity to think about how we move forward now in our new world, right?
Yes, we're getting there slowly but surely. Well, Tina, thank you for joining me, talking about your role, what you're doing, the importance of mentors and sponsors, and the opportunity for data science in healthcare. We appreciate your insights.
Absolutely. Thank you for having me. It's been a wonderful, wonderful
Excellent.
day. Thank you.
For Tina Hernandez-Boussard, I'm Lisa Martin. You're watching theCUBE's live coverage of Women in Data Science Worldwide Conference 2022. Stick around. My next guest will join me shortly.
Welcome back, everyone. I want to congratulate you. This is the first time in the history of this conference that people are back in the room and sort of quiet when we start up again. So I hope you enjoyed your lunch and met a lot of people. As we were going through the lunch break, we were showing pictures here of all the events that are going on around the world. And I just wanted to tell you, we have today 21 events that are happening all around the world in places like Center of the Universe, Las Vegas, Romania, Berkeley, we have to mention them, Tel Aviv, Hobart, Purdue, Dallas, San Diego, you name it. We've already had events in Cairo, Hyderabad, Hiroshima, and Bengaluru. So there's a lot of events taking place, and you can see this on the map. But now we're back to the program. Very, very excited to announce our keynote speaker for the afternoon, Vidya Sedler, who is the director of Tableau Research. Vidya, the floor is yours.
Thank you so much for having me here, and thank you, Margot, for introducing me. Good afternoon. Good afternoon. Great. I'm glad that my talk is not before lunch, but it's after lunch, but I'll hopefully keep you all awake. It's fantastic to be here and talk in person in front of all of you, and also a warm welcome to folks who are listening online. So as part of this keynote, I thought, we're hearing so much about AI and machine intelligence that I really just wanted to talk about what really makes these tools intelligent, especially for data visualization. And so as part of this keynote, I will walk through some various examples, try to motivate where humans are really good at and where they may need some help, and just walk you through a journey, and hopefully you'll get some takeaways that you could probably take to your own organization and apply it in your own work. So let's get started. So just walking through some early inventions, the first one that comes to mind are tools. And tools are inventions that happened way before the Homo sapiens walked the earth, more than 2.5 million years ago. And they have been really profound in helping people do work more efficiently and just being overall more productive. And we can't really forget the compass. I mean, the compass back in the day was really critical in helping people navigate and find new places with discovery, and it's really an essential aspect of wayfinding. And this bright idea, where Thomas Edison took metal filaments to produce light, really changed how we go about doing our work. Light is pretty much an essential aspect of our life, and it's really hard to think about what we would do without it. And I wanted to throw in a more kind of a fun invention, movies, which is sort of an umbrella topic for a range of inventions, starting from mechanical slides, figuring out how animation works, graphics, sound. And I thought this was kind of relevant, especially for a lot of us who were hunkered down at home. I was Netflix binge watching a lot. Probably a lot of you too can kind of relate to that. But a lot of the cluster of inventions, particularly in movies, really opened up the space for what humans do best at. We like to ideate, we like to create, we like to analyze, and we like to imagine. So the cluster of inventions here really help empower humans to do what they're best at. So let's figure out what does this all mean with respect to how humans are with data and patterns out in the world. So let me walk you through an example. So here's a table. This is a table of products by region, which shows a bunch of prices. And if I ask you a question, go through this table and try to find out the product that is least profitable. And as I ask you this question, you're probably scanning this table from left to right, up and down, trying to make sense of it. But let me make it easier for you. What if I highlight these numbers in red that are not doing well? All of a sudden, your eyes go to the red, and you're able to read these numbers, but you still have to do a mental comparison in your head, taking these 4-digit numbers and trying to figure out which one is the lowest. But then if you take this table and convert it into a simple data visualization, the patterns are immediately clear. The amount of profit is on the hue of red, and you can actually look at the amount with respect to the length of the bar, and your eye immediately goes to the relevant bars to make that judgment. So the point that I'm trying to make is the human visual system is a really strong and powerful entity. And we're very good in making sense of information and patterns by taking advantage of our human visual system. So there have been a cluster of really good, inspiring examples from data visualization that has really taken advantage of this very premise about the human visual system. So let me present to you an example that has really inspired the visualization community. So Charles Menard sketched this visualization back in the day, and this is a visualization that really talks about the beginning of the end of the French Empire. So let me walk you through the story. So Napoleon, in June 1812, gathered his army from Poland on the west and was moving towards Russia to invade Russia. And the orange line that you see from left to right, west to east, indicates the number of troops. And as you see, the width of this orange line diminishes. And so the Russians were pretty good at fighting against the French, and the army dwindled. And finally, when Napoleon reached Russia, the Russians had abandoned their capital. So there was really nobody to surrender to Napoleon. And so he had to head back with his troops. And by then, the harsh winter had set in, which is indicated by the line graph at the bottom of the visualization. So Menard really skillfully wove in the temperature along with the number of troops, and the black line represents the troops heading back to Poland, to the west. And you see the thickness of that black line is substantially thinner than the orange line, and the combination of fighting against the Russians, the really cold temperatures, resulted in pretty much the French army getting wiped out. So this is a really skillful way where Menard very quickly learned how the human visual system makes sense of color and patterns and the juxtaposition of images to communicate a data story. Now, why am I saying all of this? The point that I want to make is, there are a couple of points actually. As humans, we are innately curious about the world. We want to make sense of it. We try to find patterns. We try to glean meaning out of these patterns. And we really have a strong visual system that supports that. So in a sense, we are all our own Sherlock Holmes. And so as part of playing that role of a Sherlock Holmes, we're really, really good at analytical thinking, which is the structured approach in trying to answer questions and making decisions about what we see. And I'll walk you through a couple of examples where people in their regular activities play that role. So this is a Tableau visualization. It's a woman who is a biker, and she realized, that she hasn't been biking that often, and she decided to take a new route in a new neighborhood in Seattle, and decided to use Strava to log her bike rides. And she put out this dashboard, and she asked herself this question: am I riding more recently? Here's another example. This is a dashboard, again in Tableau, that was created by this organization called NetHope, which was really looking at ways in which it could coordinate medication for Ebola between profit and nonprofit organizations in Sierra Leone. So this is a set of charts that people on the ground use to answer this basic question: is the medication program working? And if not, what can be done? What are we seeing? What are the patterns? So these two examples, including the one that I showed from Menard, really takes information on one end and tries to weave in stories on the other end. And as readers, when we look at these examples, we only see the stories, but there's so much going on behind the scenes. For these users to actually create compelling and useful data stories to communicate to themselves or to an audience, there's a lot going on. The data needs to be connected. We heard in the panel earlier before lunch that there's a lot of dirty data. It needs to be transformed. It needs to be cleaned. There can be missing data. And there's so much that has to be done behind the scenes in order to create these stories. So how do we actually come up with tools that can automate some of these pain points so we can really get the human or the user to do what they really enjoy doing most and what they're good at? In other words, how do we create tools that can support a human in their analytical reasoning? So I present 4 main ideas, and I'll try to address these in the various research examples that I present during the talk. So the first one is, we need tools to support the cycle of analysis. And analysis is not linear. It goes through so many processes. People go back to the data, import more data, try to connect it with existing data. And these tools need to help answer a question by composing a picture. And these pictures need to be meaningful, because the best visualizations really support a task or an intent that the user has in mind. And finally, these tools have to also be easy to use. You can't have a complicated Swiss Army knife that can do everything, but it's simply hard to use. So given those 4 main ideas, I'm going to walk you through kind of a vignette flow of different aspects in which tools can be used to help users see and understand their data. And as you see here from the left, I start with a really solid line, and it gets jagged towards the end, which indicates these are kind of more speculative, future-forward ideas. So let's get started. The first aspect is data encodings and transformations. So a big piece of creating meaningful visualizations is really figuring out the meaning of the data and coming up with sensible ways of representing and transforming that data. And I will say that semantics plays a really important role in transforming the data into a form that is meaningful. And what is semantics? We all know that, as we're trying to make sense of the world and figure out meanings and patterns, it's really an abstract concept. And semantics is a way to take that abstract concept and try to operationalize it. So it really tries to formalize the notion of meaning. It tries to take into account the context and the task of the user and trying to make this information meaningful. So let me walk you through an example here where semantics, a little bit of semantics, actually goes a long way in making a chart meaningful. So this is a plot of brain and body mass created by Carl Sagan. It's called the Sagan plot, commonly in the community. And as you're trying to make sense of this chart, your eye is probably hovering over the blue dots, the labels associated with the dots. Because of space, some of the labels are shifted, and you have to look at the arrows and see where they're pointing to. But if you have an algorithm that can take those labels and replace it with semantically meaningful icons that represent these various animals and birds depicted in the chart, all of a sudden the patterns become more meaningful, where you might see this blue whale in the extreme right corner and the hummingbird at the bottom left. Another example where algorithms can really play a role in meaningful data transformations by just understanding the semantics is parsing dates. For those of you who have traveled from other countries, you probably can see this with dates. I mean, at least from India, we follow a different format when compared to those over here in the US. And it turns out that parsing dates is a gnarly problem. There's simply a lot of formats. And so the problem that a lot of users have when they're representing their data is importing a table, and quite often these dates are represented as strings, and they need to figure out not only which of these columns need to be marked as dates, but what is the format. And at Tableau, we identified that that was a common problem, and we wrote an algorithm that tries to automate that. So if you look carefully at these dates in the column that I've highlighted by the red box, you'll see the second row, which says 4/15/08, and you're like, yeah, I mean, there can't be months more than 12, so that's a month, date, year format. And so we took this and we implemented an algorithm where the system looks at the context of dates rather than an individual date and tries to come up with an automated way for detecting the date format. And you might say, this is really simple, but this really goes a long way because people don't want to be distracted from their main goal when they're trying to create these data stories. So these little defaults where a system can actually cooperate and work with a human goes a really long way. Another aspect of data transformations are joins. So quite often when people are importing their data to create a visualization, they draw information from multiple tables where they try to join these tables along a common piece of information. And a lot of the previous literature around joins tend to be what we call equijoins, where the strings or the data values are equivalent in both tables. But if you look at this example, both these tables have a country column, but their formats are different. One is a country code and one is a country name. And we see this for a lot of examples, including currency. You know, you might have a table in US dollars and another in euro. So these are what we call semantic joins. So for a computer to actually identify these common semantic properties, it needs to understand that they share some shared meaning, and it comes up with a suggestion as to how these tables can be joined. So given that, that aspect of using tools for data transformation, I'll walk you through a few examples around question and answering. So a common way that people interact with data is asking a question in language. So I'm looking at earthquake data, and I'm here in the Bay Area, so earthquakes are a topic of concern. And I ask, find large earthquakes near California, and the system highlights a bunch of earthquakes with large magnitudes in this area. And I can ask a follow-up question, how about near Texas? And notice that I didn't specify large earthquakes, but the system understands the context of my previous question and is able to respond accordingly. And these sorts of questions get more nuanced because I could ask for trends in the next month, where the system will have to connect the question to a forecasting algorithm under the tool. And there's even more complications around language. So let me walk you through another quick example where I might have a table of housing information, and I ask a question, show me house prices. Here, prices maps to the attribute price, which is an easy thing for a system to do. But then what if I ask, show me expensive house prices? And here, expensive does not map to a particular column in the table, and the system will have to pull up the definition for expensive and reconcile that to price, and more specifically, high price, in order to understand the question. And then it gets even more complicated if I ask a question, show me large houses, and when the system pulls out the definition for large and tries to look at the definitions for all the attributes, it has to figure out the common words in these definitions to map large to an appropriate attribute. And so as we see here, for these tools to be intelligent, external knowledge is really important. And these are some corpuses that a lot of tools tend to use, like Wolfram Alpha or Wikipedia, where questions that support units, like Fahrenheit, and seasons, like fall, can be properly interpreted by the system, even though it's not in the data, to show a sensible visualization response. In addition to asking questions about the data, people also might ask questions about the visualization or the dashboard itself. So a query, what's the spike in that blue line, is actually more complicated than you may think, because spike has to be mapped to a line chart, the word blue has to be mapped to a color property, in this case the blue line for townhome, in order to show an appropriate result. So just as tools need to understand what a user is asking, we also need to think about tools that can help a user even ask a question in the first place. And we're all pretty familiar with auto-completion. We use that when we're searching on Google or we're trying to buy a product in Amazon. And so the question is, how do we create tools that help users ask the right question for data discovery? So this is another piece of research that came out of Tableau, where I'm looking at COVID cases, and I ask, show me cases in, and map widgets show up that provide a sneak peek into the underlying data so that I can complete a question. So I kind of quickly walk you through this journey of data transformations and question and answering. And then the next aspect of it is really figuring out the nuances between language and charts, because just as important for a human to be able to ask questions about their data, a machine needs to respond appropriately as well. So kind of revisiting a similar example that I showed earlier, if I'm looking at disease outbreaks around the world and I ask a question, show me the orange spike, sure, the system can find the appropriate part of the chart that's relevant, but as part of that process also needs to generate a pithy annotation in response that provides a little bit more detail to answer that question. And questions like drop in July 2016, when I'm looking at pound versus dollar, would require the tool to go out to the web, figure out that it was actually due to Brexit, parse that data, and present a response back to the user. Data summaries have become really popular now. This is a data summary created by Narrative Science, which was recently acquired by Tableau. And it's really useful to create these insights and reporting. Interacting with text and charts is also important for people to read the text that accompanies these charts. So lastly, as we move to other mediums like Slack and chatbots, the medium really becomes the message in terms of communicating with data. And we all probably have an Alexa or a Google device at home, so that really changes how we explore and interact with data as well, and this is kind of more future-forward work. So to wrap up, I provided a bunch of examples to really impress on ways in which tools can work with humans to support humans in terms of what they're good at. And I'd kind of like to end this talk by saying, there's a lot of data enthusiasts out there who are intrinsically analytical thinkers. So how do we actually create tools to support these people and provide smart defaults? And with that, I'd like to end my talk. These are some details if you want to reach me. And just a shameless plug, I have a book coming out with another female author who's pretty kick-ass, and it's end of summer. And yeah, feel free to reach me afterwards, and I'd love to network. So thank you very much.
For the wonderful talk. Well, we're immediately moving on to our next speaker, and the Tech Vision talk by Nadia Fawaz from Pinterest.
I'm Nadia Fawaz, an applied research scientist at Pinterest and the technical lead for Inclusive AI. And this work is a cross-functional collaboration with many talented peers at Pinterest, because deploying Inclusive AI in the product requires a multidisciplinary approach, not just technical skills. So I would like to start by sharing some feedback a pinner sent us a few years ago. She told us that to see people of color in our app, she needed to physically type the word black. And that when she looked at our app, it told her that people who looked like her were not the norm. Pinterest's vision is to bring everyone the inspiration to create a life they love, and to truly be a place where everyone can find the most inspiring and relevant content for them. Pinterest is committed to content diversity and to building an inclusive experience on the platform. So AI powers many advanced search and recommendation systems at Pinterest. And these systems tend to be very complex. They have many components because they need to operate at the very large scale of over 400 million global monthly active users who have saved more than 300 billion pins to over 7 billion boards in over 35 languages. And we strive to be a place filled with positivity for pinners. Now, a top request we hear from pinners is that they want to feel represented in the product. This is why we launched the skin tone ranges and hair pattern search. These inclusive features give control to users on their experience in search and AR try-on similar looks by enabling them to narrow down search results for beauty according to a skin tone range or hair pattern of their choice. Now, how did we build the skin tone ranges? I would like to walk you through that journey. In the early days, to understand the skin tone range in a beauty image, we considered a third-party closed-box computer vision library. It had a deep learning module for face detection, followed by color extraction. We got the LAB coordinates, threshold on the L score, and estimated the skin tone range. We launched this in production, and we heard positive feedback from our pinners who saw their experience improved. In particular, it became easier for them to find more relevant content in the darker skin tone ranges. However, over time, we started noticing issues with the closed box version based on visual inspection. But to be able to make progress, we needed to quantify the extent of the issues. So we collected a diverse data set and conducted an evaluation of the closed box on this data. The confusion matrix on the left revealed a major coverage issue in the darker ranges. And we also noticed performance disparities in the granular precision, recall, and F1 score for the closed box prediction. So in an image, this is how it looked like. The top row shows ground truth data set, diverse data set labeled by the specialist. And the middle row shows how the closed box understands the skin tone ranges for these images. As you can notice, it has a major coverage issue in the darker skin tone ranges. And it also failed to understand accurately the skin tone range for many images. Now, to understand why this was happening, we conducted an error analysis of the components of the system. The score distributions per skin tone range showed at the top right corner were not really separable. They overlapped. And the thresholds were out of tune with the diverse data. And these issues can be amplified by challenging lighting conditions and by shadows. Then when we looked at the output of the face detection module, we realized that the coverage issue was coming from there, because the face detection module was failing to detect faces at much higher rates for darker skin tone images than for lighter skin tone images. And this type of bias in face detection technology has been studied and documented by Joy Buolamwini and Timnit Gebru a few years ago. So we reached the conclusion that there was no amount of post-processing for fairness that we could do on the output of the closed box that could fix the built-in biases in its components on which we didn't have control. And so we needed to build our own system end-to-end in-house, and this is what we did. So in the first version of the visual skin tone developed in-house, we built a system with several machine learning components. After exposure correction, it detected the location of the face, extracted facial landmarks such as eyes, nose, and mouth, segmented them out to produce a skin mask. And in the cases where the face detection did not detect a face, the hue saturation value module detected patches of skin pixels in the image. The skin mask was then fed into color extraction. We got the LAB coordinates, computed the individual topology angle, and we fed that into a fairness-aware tuning phase that took as input diverse data to estimate the skin tone range. Now, when we evaluated this on the diverse data set, it was performing much better. The confusion matrix was closer to a diagonal and more symmetric. The score distribution per skin tone ranges were more separables, and the per skin tone range precision, recall, and F1 scores were not only higher for every skin tone range, but also the disparities in performance had reduced, meaning that we had reduced bias. Now, you've seen the top portions of this image, and the bottom row shows how the visual skin tone performs on this diverse data. We didn't have anymore the coverage issue for the darker skin tone range images, and while it was not perfect, we had made a lot of progress. But that was not the end. Even our in-house visual skin tone could make errors. And we learned from those errors and made the model learn from these errors too. So I'd like to share a few examples that tripped the model with you. Extreme lighting conditions are challenging. Occlusions, such as beards and sunglasses, can lead to errors. And then the pandemic happened. And as the world changed, so did images on Pinterest. The pandemic caused a surge of face mask images to which the model had to adapt. In some images, you have multiple faces or a combination of faces. In some images, the face is not visible, or there is no face at all because we also have other body parts. And so these use cases prompted us to search for a more robust approach. So we invested in collecting our largest and most diverse data set for skin tone ranges. It consisted of errors from the previous models, partial faces and body parts to handle new use cases such as lips and nails, other verticals beyond beauty such as fashion and internationalization. And for this model to handle more complex images, we decided to move away from face detection entirely, and we explored different machine learning architectures. This ResNet model, when evaluated on this more diverse and complex data set, outperformed the face detection approach. Next, we integrated the skin tone predictions into Pinterest multitask visual embedding model and added a skin tone classification task. And that model outperformed face detection and the ResNet model. Now, we built on our learnings from building the skin tone ranges with bias mitigation to develop hair pattern search. Hair pattern search is also powered by a computer vision model trained on diverse data to understand the visible hair pattern in an image. To define the hair patterns categories, we worked with hair experts who work with Black, Indigenous, and people of color, such as Naïma Lafont, who is a Pinterest creator and the global artistic director for Amica, a hair brand. Their guidance, the help of our beauty and fashion specialists, and our user research team guided the development and our technical choices throughout the efforts to build hair pattern search. To mitigate bias and ensure that this system performed well across various segments of Pinterest data, we collected a large, diverse data set for hair-related images across skin tones and genders and hair patterns and hair-related interests. We integrated hair pattern prediction into Pinterest's latest multitask visual embedding model that leverages the vision transformers and also our investments into our computer vision infrastructure to scale to billions of images. Now, the skin tone ranges and hair pattern search provide a more inclusive experience by giving control to the users on their experience. But we would like also for everyone to feel welcome and represented on Pinterest from the start of their journey. This is why we launched skin tone diversification in various surfaces, so that no one has to work harder to find content that's relevant for them. We've diversified according to skin tone, search results for beauty and search queries, fashion products in our shopping discovery surfaces, and we welcome new users with a diverse initial home feed when they first join Pinterest. Diversification approaches aim at re-ranking the contents so that the pins that are surfaced to the users are diverse by default. One common and simple approach is to boost the utility scores of pins that match a certain diversity attribute. While boosters are simple to implement, they tend to become tech debt, as they are tuned at the time where they are introduced, then forgotten. More boosters get added and are not jointly optimized. So an alternative is diversity-aware re-ranking. And our approaches to diversification evolved over the past couple of years from simple greedy re-rankers to multi-objective optimization. So we started with simple greedy re-rankers that take as input a list of pins ranked by their utility scores and the skin tones of those pins and score thresholds. And those re-rankers iterate on that set of pins to produce a diversified ranking. We deployed that in production, and it proved to be an efficient approach to increase diversity while having a neutral to positive impact on utility metrics. However, greedy re-rankers do not balance the diversity-utility trade-off. They do not generalize easily to multiple diversity dimensions, and handling multiple thresholds for various scores is just not scalable. So we evolved our diversification approach to a multi-objective optimization framework that can balance various utility functions and diversity using DPP, determinantal point processes. DPP is a machine-learnable probabilistic model that's used in physics to model repulsion and more recently in the recommender systems. DPP can be parameterized by a kernel matrix whose diagonal entries represent the utility of a pin, and the off-diagonal entries represent the similarity between pairs of pins according to some diversity feature. And per that model, the probability of an ordering of pins is proportional to the determinant of the kernel restricted to that subset. It increases with the utility of the sub-selected pins and decreases with their similarity. So when we try to maximize the determinant, we obtain an ordering of pins that's high utility and high diversity. And thanks to its submodular property, a DPP solution can be efficiently approximated using a greedy algorithm. So DPP, when we launched it in an experiment, it performed on par in terms of utility and diversity when compared to greedy rankers. But it was able to balance diversity and utility in a flexible way that allowed us to expand the coverage of diversification to more queries in beauty and fashion, and to more diversity dimensions. So this is an example for the query short hair, where the score thresholds in the greedy re-rankers limited its ability to diversify, whereas DPP's flexibility allowed it to generate a ranking that was both high utility and high diversity. So to conclude, I would like to share with you some recent feedback that pinners sent us. Hearing from pinners that we are making a positive difference in their lives has been the most encouraging reward for our teams. And I would like to leave you with a message of hope that change in technology is feasible if one is intentional about it. Thank you very much.
Thank you so much, Nadia, particularly for that last comment, which was wonderful. And I also really enjoyed how you found this cross-fertilization between physics and what you do in Pinterest. And that's a common theme that we see, that you can learn from all these different fields and how they come together and help each other. So thanks again.
Thank you.
Yep. Now, Nadia also made this perfect transition to the next speaker because she showed some mathematical formulas. And believe it or not, but we're going to hear from a mathematician next. So I want to welcome to stage Tammy Calder.
Welcome, everybody. Let's talk about math. So I'm going to give you a mathematician's view. That is my view of machine learning, and I'm going to hopefully convince you why it matters. So we just saw kernel machines. So that's great. I think of machine learning as something that takes inputs and translates them into outputs. So just to give a few examples to set the stage, I have my smartwatch here. It's constantly reading what's happening, my heart rate, whether or not I'm moving, my location, what other apps I'm using. And then I think it puts it through a machine learning model to tell me, to make predictions about what I'm doing. So it could tell I was washing my hands earlier and gave me a little buzz when I'd washed them long enough. It detects when I'm working out or when I'm done working out and I forgot to turn it off. You can think of unsupervised situations. So maybe I just have a bunch of data about customers. What did they purchase? When did they purchase? Where did they purchase? What coupons did they use? If it's online, they can look at what was in the shopping basket and what got taken out. You can put that into a machine learning model and just sort of group the data into something like clusters. These often don't come with labels, but people often go back in later and sort of say, oh, maybe I can segment my shoppers at the grocery store into people who are shopping for families and buying hot dogs, or people who are buying lots of wine. And so these are sort of things you can do. And then there's, of course, many important applications for machine learning. So as one example is medical diagnostics. It has a lot of roles to play there. So we can think about imagery coming from various measurement systems like MRI. We can think about measurements that come from devices, but also from blood tests. We think about the genome and various medical histories. You could, in theory, put all those together. Most don't. And then you can put it through a machine learning model. And so I kind of give an image here of sort of maybe tumor detection in a brain. So trying to find regions of abnormalities. So many applications, we think of these as going from inputs to outputs. So as a mathematician, I think, oh, it's a function. So I have some set of inputs, which I think of a vector x. So it could be a list of D features. And I put that into this machine learning black box. And I get out some sort of answer, which I think of as an f of x. So here's my function. And I want to convince you that everything you're seeing is functions. I had kernels on there. We just saw kernels in the last talk. I took it out because I thought, oh, maybe doesn't everybody know kernels? But now you do, so too bad. But, and these aren't just functions. They're actually parameterized functions. And so this is sort of the key for machine learning is you learn a bit about the function as you go. So you have some theta, which is learned during the training phase. And so that's an important part as well. And so what are our functions? So I say theta as a generic term. Theta is something different for every sort of model. So if we think of just the simplest thing of linear regression, so our function is just some weights multiplied times our input features, and then plus some bias term. And so those are the parameters. Those are the theta for linear regression. You can think about clustering. So we can think of the k-means algorithm as one of the major algorithms. You're finding the centers of the clusters. If you put in a new point, you could tell you which cluster center is closest, so give you the index of the cluster it belongs in. You can do, how could I give a talk about machine learning without mentioning deep learning? So we have our deep neural network. At each stage, we have, at each level of the network, we have weights. What's the weight going from a node at level I to a node at level I plus 1? And then the biases, and you put that through an activation function. And this is super cool because it's a composition of functions, so super fancy for us mathematicians. And so you do that same process at every level with different weights and biases. And so mathematicians like to think a lot about functions and their general properties. So what are mathy questions people might ask about machine learning models? So we think we have some input that's in a domain, a subdomain of d-dimensional space. We often assume there's some true mapping that we just get to see hints of. So some oracle that is actually the F star is what we're trying to find in our machine learning model. And we also get training data. So in the unsupervised case, we just get a set of points, x sub i's. And then in the supervised case, we get some set of labels. But these labels aren't always exactly what the oracle would tell us. It's usually a noisy version of what we see, so you also have to deal with that. And then we are trying often to learn a model that's inside a larger family of models. So we're going to try and learn a deep learning model, or we're trying to learn a regression model, or a random forest model. So we have families of models, and then we try to learn a function from within that family. So we can ask questions. How well can a function in a given family learn an arbitrary function? Maybe I even know a little bit about F star. So can I say how well we can approximate this F star with a deep learning model versus a random forest model? How many samples do we need to build a good model? What if we have noise in our labels? How does that affect the answers? Are there certain families of models? I think we all spend a lot of time thinking, what model should I use that have advantages in my context? Is one more flexible? Is another more parsimonious? Is some more computable than another? And then how does the model complexity impact generalization? So you might think of this as just the number of parameters of a model. We'll talk a little bit more about that. And then also, how can we just learn the parameters of a model? If I can write down any math model I want, but how can I learn that theta for that model? We'll talk a little bit more about that as well. So, and I should say, I could talk about all those topics, or I would like to, but then everybody would fall asleep, because I can make a room go silent with my love of mathematics. So how does model complexity, so the number of parameters is maybe the best way to think of it, impact generalization? And can we sort of explain mathematically the power of deep learning? So this has inspired, or it's highly complex models, so I kind of gave myself away. So we're going to try to fit an ML model, and so what are you normally learn? So you don't want to underfit. So I want to separate here the red circles and the blue crosses. So if I just draw a straight line, I don't get a very good separation. So that's underfit. I could draw a really complex line, and then I could overfit this model. But normally we want to get like sort of happy medium. So we fit most of the data, but not all of it. And so you see this in this sort of classic trade-off curve where we have error or risk on the y-axis and model complexity or number of parameters on the x-axis. And then if you train a more and more complex model, you can eventually drive your error on the data that you get to see, your training error, to 0. And normally the 0 point is basically where the number of parameters is equal to the number of data points, loosely speaking. And then if you look at what happens with the testing data, this is data that your model has not seen. It gets better and better in terms of the error, and then it starts getting worse again. And so that's, we all know that's like how it is. But then people started to ask, math people started to ask, what if you keep adding more parameters? This is craziness. What if you kept adding more parameters? It actually can improve beyond what you saw originally. So it can actually get a lower error than if you sort of stopped at this happy medium. And actually, if you stare at this overfit picture, I think that's a pretty good fit. It's a pretty smooth line between those X's and O's, and you could sort of argue that that could be good. And so this was something that's seen a lot in deep learning, is that using way, way too many parameters, a ridiculous number, can actually be better. And there's a lot of mathematical thoughts about this. And so there's this paper that came out in the Proceedings of National Academy by Misha Belkin, Daniel Su, and Ma and Mandal that really sort of opened the door and sort of took a mathematical approach at looking at this and sort of began to highlight that this happens not just in deep learning. So one question was, why is deep learning so good? But maybe there are other models that can be equally good. This also happens in random forests. It even happens in regression. And so there's a nice paper in a journal that I'm actually editor-in-chief of and helped to found called the SciEM Journal on Math of Data Science, which even looks at this phenomena of adding too many parameters, even in the context of regression, and sort of looks at trade-offs of different ways of doing that. And so there's many ways that you can look at this. And so mathematics sort of asks this question of why does it work and come up with some answers. And I should say one of the answers is that the models tend to get smoother as you add more and more parameters. So it takes out those high kinkiness and becomes smoother, and that's sort of the basic thought of why these are starting to work better. And then I'll also talk a little about some work that I've been involved with, is how can we find the parameters of a model? And in particular, can modern mathematics open new avenues? So deep learning sort of became repopularized. It had been around for a long time as a idea of neural networks when we learned how to fit models more efficiently with mathematics and also more data. So can we apply that in other regimes? So let's look at the problem of data clustering, which has applications in things like density estimation and anomaly detection. And so here, one popular model is something called Gaussian mixture model or soft clustering. You can find this in every sort of package out there to do clustering. And so you want to find some model. It has a bunch of parameters. I'm not going to go into the details here. But you're basically trying to find these hills that describe your data. So the top of each peak is the center of a cluster, and then it sort of falls off from there. And it's soft clustering because any given point, you can say what's its closest peak, what's its next closest peak, and so on. So that's what we're trying to find. The standard method to fit this type of model is something called likelihood maximization, and you use the expectation maximization algorithm. So we can look at a different way to fit that. So another way that people used in 1D a lot was something called method of moments. And so what's the idea there? So remember, there's this weird property of a random variable, at least it's very weird to me, that the expected value of the random variable x squared is not the same as taking the mean of the random variable and then squaring it. And so the idea behind the method of moments is you look at what all these things do, the x squared, the x cubed, and then I put this funny x circle 2, which is what you do with multidimensional variables. So this example I showed just has 2 variables. Suppose you want to do the third moment of a model with 2 variables. What would you be looking at? You'd be looking at the expectation of x1, the expectation of x2, the expectation of x1 squared, the expectation of x1 times x2, the expectation of x2 squared, the expectation of x1 cubed, the expectation of x1 times x2 squared, of x1 squared times x2, and x2 cubed. That's just 2 variables in the third moment. You want to do this for tens, hundreds, thousands of variables, and then 4th, 5th, 6th order moments. And I'm going to tell you, we can now do this. And the reason that this is interesting is you think this is like polynomial functions of your variables. Those might actually be very interesting in understanding what to do with your features, because you don't always have the raw features that you want. Sometimes you need derived features. And this, you can take data and then build a model and try to match these moments. That's what the goal is with moment matching. And so I'm involved with the paper that just came out. And so this is our visualization of how to compute the third order moment of a Gaussian mixture model. I don't expect that to make sense. It's just a teaser if that picture looks interesting to you, of sort of an outer product of a vector and a matrix on that right-hand side, and you symmetrize it. It's very fancy mathematics, and so that paper is just posted on arXiv recently, and I encourage you to go check it out. What I hope I'm starting to convince you of is the important role of mathematics in machine learning, especially for addressing the challenges of machine learning. So many challenges that we've heard about today: robustness and generalization, bias in many places, in the models, in the training, in the definitional loss functions, of course also in the data, model approximation properties, numerical accuracy, computational efficiencies, uncertainty estimation. A lot of times when you get the probability that some classification is true, there's a very ad hoc measure that they've given you. It's not really based in a lot of firm statistics. I also want to mention that a lot of things are thought if we just get more data, if we just get a bigger model, we can now answer that question. And I think math has a lot to say that maybe that will actually be impossible in some cases. That it's not always a matter of just more data and just bigger models. And it's important to know when you can do that. And then you can also think about feature sensitivity, importance, and much, much more. And then some of the areas of math, of course, people get trained in data science programs: linear algebra, numerical optimization, statistics. But there's many more areas that could potentially be relevant. The paper I just talked about, I was involving colleagues from abstract geometry, and we use things like Bell polynomials and enumerative combinatorics. So really interesting topics, and there's many topics of math that will be relevant to data science. So thank you. And I'd love to connect. Here's my information. Thanks so much.
All right, now I'm interested in learning more about mathematics. And you didn't do such a bad job for a mathematician, Tammy. Huh? I've known her for a long time, so I can tease her. Thank you so much, Tammy Calder. Great. So before we move on to the next panel, we're going to meet Andrea Gagliano from Getty Images.
How do we get to this? Technology rooms and conversations that are highly diverse, inclusive, and representative, making this the norm instead of the exception. I'm Andrea Gagliano, Head of Artificial Intelligence and Machine Learning at Getty Images. And here's me at the 2020 WiDS conference, where I shared my creative artwork using data science to depict all of the US presidents as females, posing the question, how many more female leaders would there be today if little girls would have seen themselves as leaders? It was a question of representation. After working in data science and technology for 10 years, this WiDS conference was the first time I ever felt like I actually belonged. Just seeing other talented women in the room gave me that shoulder-relaxing awe and sense of relief where I could just relax and be myself. Imagine if that's how we felt every day, every conversation, every meeting. If we see ourselves in an aspirational role, it's a lot easier to become that person. For many of us, we grew up not seeing it. When I was 8, I was in computer club, but I quit because I was the only girl. When I was 19, I dropped my mechanical engineering major because my dad said he couldn't see me holding a tool. I made those choices because of what I saw and what others saw. Some roles were just not for girls. So I ask again, how do we get to this? Making this the norm instead of the exception. As the old adage goes, you have to see it to believe it. The images we encounter every day influence how we see ourselves and others. And it's not just women, but also people of different races and genders, ages, and backgrounds. People who have traditionally been on the fringes, perhaps doing very important work just outside the frame. Seeing ourselves, no matter who we are or where we come from, as the data scientist as the robotics engineer, as the CEO, reinforces what's possible. Today, through my work, I'm able to actually do something about it. Last year, at Getty Images, we released a search algorithm update in the US that increased representation of ethnicities in our search results. Meaning more underrepresented ethnicities were appearing on page 1 in search, making those images easier to find, to download, and then use in the world. What we saw in the data is that the downloads of underrepresented people grew 20% on average. That means that images and videos of real people and real lived experiences are being used more frequently. So there's a higher chance that you or your daughter or your niece or your mother will see themselves in a way they hadn't before, no matter who they are, where they come from, or what they look like. If you can see it, you can believe it. And if you can believe it, you can make it happen for yourself and others. That's the power of imagery and data science to move the world. And it's something I'm proud to be a part of.
And what is wonderful is that Andrea is here with us today. Where are you? Yeah, there. So Andre, if you want to meet with her, there's a break after our career panel and you'll have a chance to speak with her. She's very inspirational. And talking about inspiration, we're going to do something now that is always a big highlight of our conference, and that's the career panel. And I'm very, very pleased that today's career panel will be moderated by my friend Suzanne Weeks. She's the Executive Director for the Society of Industrial and Applied Mathematics. Suzanne, you flew over from the East Coast to be here. Thanks so much for joining us today. And you will introduce all your panelists. You will recognize some of them already, and some of them are new to you. So thanks very much.
Thank you so much, Margot. Hi, everyone. Beautiful. So let me say hi again so everybody all over the world can hear us. Hi, everyone. Andrea, that was a beautiful video, and we got to make that video go viral. That was fantastic. So thank you, Margot, for the introduction. And yes, I'm from the Society for Industrial and Applied Mathematics, and I'm hoping all of you, if you're not already members of SIAM, will join SIAM. SIAM is an organization. We do conferences, we do networking, we're a community, professional development, research, journals. Tammy talked about the SIAM Journal of Mathematics of Data Science books. We want you to be members of our community. So I'm so happy today we have 4 wonderful panelists. You've already met Tammy Kolda, and Tammy is a mathematical consultant, and her company is mathsci.ai. You've already met this morning our first plenary speaker, Cecilia Aragon, who's the professor of human-centered design and engineering at the University of Washington. It's good to see you again. And then we have Maggie Wang, robotic software engineer at Skydio. Okay, and we'll hear more from Maggie as we go along. And then finally, we have Sharon Hutchkins, who's the VP and Chief of Operations in the AI plus Data organization of Intuit. So thank you so much for, I'm really excited. And hopefully I won't take up all of our time, and we'll have time for questions. But I'm also hoping in our discussion we answer every possible question you could ever have. So I want to start by finding out what you all do when you're not here with us at WiDS, okay? We only get to come here once a year, but what do you do in your regular life, Sharon? What's your day job like? And what's your path to your current position?
Okay, let me first say my heart goes out to the people in Ukraine. I have to get that off my chest and remind everyone that there are over 80 million refugees around the world. But when I'm not sitting here, I am, as you mentioned, the Vice President and Chief operations officer for the AI plus data organization at Intuit. I have a lot of pride for Intuit, and I love how we are using AI to further our mission of powering prosperity around the world for 100 million customers using TurboTax, QuickBooks, Mint, Credit Karma, and MailChimp. My journey to AI and data has been very unique. I've worked for Intuit for over 20 years, and I actually started on the business side of the house. I supported our small business products. From there, I moved to our IT organization, where I led data security and data privacy initiatives, dabbled in M&A, and so I bring a different perspective to IT, deep business knowledge, and a background in mathematics. My path, as I just mentioned, wasn't a ladder. It was sort of a net with side-to-side movements, diagonal, and it's probably not different from most professionals. Most professionals move in a non-linear path. The real key is really just figuring out, and you heard it this morning, figuring out what you're passionate about, the things that you love, and it is equally important to figure out the things that you don't love. So at 17, yes, I worked at a chicken shack, making chicken sandwiches, and no offense if you work in a chicken shack. But I quickly figured out I gotta stay in school and do something different. And so finding out what you don't love is equally important.
Absolutely, thanks, Sharon. How about you, Maggie?
Yeah, so my job is being an autonomy engineer at a startup called Skydio. And Skydio does autonomous drones. So we're actually trying to make drones more autonomous and being able to understand the environment, being able to avoid obstacles, and just be the second eyes in anywhere in the world. So my job as an autonomy engineer is to create these algorithms that we can run on these drones, and also run these algorithms in simulation, and also run it in the real world. So what's really exciting to me personally is being able to design some algorithm, have it materialize in my mind, put it into code, and then fly it in simulation, and then also fly it in the real world, all in the same day sometimes. So it's really exciting to me to see the drones move in the real world, and I think that's what brings me a lot of fulfillment, and being able to see my creations come to life almost. And I think there's a lot of potential in robotics in all different kinds of industries. So if you are passionate about environmental sciences, there's a bunch of applications for robotics there. If you're passionate about climate change or any search and rescue mission, you can use robotics in these types of situations where it's difficult for humans to be in. So I think robotics can sometimes be a niche field, but if you actually think about it, it's actually super applicable in all different areas. And I think that's what really drew me to robotics, the interdisciplinary nature of it. And actually, I think what I'm most passionate about is combining the arts and humanities with engineering. And I think robotics is one way to do that, because at a deep level, it's almost very philosophical. It's about understanding how humans think and perceive and move in the real world. And I think these are some questions that roboticists think about on a daily basis, is how do we have human level intelligence, or even better than human intelligence, and put it into these robots? And I think it's just an amazing field to be in, and I'm super happy to be here and talk about my path towards robotics and why I'm so passionate about it.
Thank you. And then we heard a little bit about your path this morning and what you do, Cecilia. So I just wanted to jump over a little bit, jump the line to Tammy and say, Tammy, what are you up to when you're not here?
Yeah, so what's my day job? So I say 9 months ago, I made a big switch. I spent over 2 decades working at Sandia National Lab, which is a Department of Energy laboratory, which works on a range of science problems. And I did data science there, but I wanted to do even more data science. But I'd say my typical day is like proving theorems and having meetings with other mathematicians. And you think, well, I'm doing this independent consulting. What does that look like? They do not come to me and say, Tammy, we wish you would help us with the method of moments, the Gaussian mixture model. I don't get those calls. I get a call that says, we have a pile of data, and we kind of want to do stuff with it. Can you, we were thinking about doing this. What do you think? And so that's sort of what the consulting work is more like that. But this is actually very inspiring to me because I really, even though I'm a mathematician and I sort of enjoy proving theorems and writing algorithms and implementing stuff, I'm inspired completely 100% by challenges that people have in working with real data. And so this is sort of my way to keep my hands still in that. So this is the things I do. I work with people to try to figure out what to do with their data. And then now and then they have a problem that's really interesting, and I get to go off and do some fun mathematical research. And then I come back like 5 years later with a solution.
So I'm also interested in hearing what is this profession of data scientist, right? And how has it evolved in the last 5 years or even, I'd say 10 years? Yeah, what do you think, Cecilia?
So I've actually been in this profession for a lot longer than 10 years, but it wasn't called a data scientist then. And actually, I've heard a lot of people saying, I just want to take a little aside. I've heard a lot of people saying, well, you have to find out what you're passionate about and then do that. But the problem is, what you're passionate about may be shaped by a professor or a teacher you had that really inspired you, or a mentor. Or contrary-wise, you might have loved math, but then you had a math teacher who really was kind of harsh on you and made you think you weren't very good. So be cautious. Is your passion truly for the subject, or has it been shaped by the world around you? And what I would say, that I have seen the profession of data scientist change because it has broadened tremendously. So when I started out, I was one of the few people I knew working with very large amounts of data and doing machine learning and neural networks back in the 80s. And it was, what's kind of interesting is that it's just become a lot more popular now, but a lot of the work is still the same. I mean, I have a company came to us in the 80s with a bunch of data, and they wanted to make sense out of it. They wanted to process it. They wanted to get rid of paper. And we sat down and came up with algorithms and proved some theorems and then solved their problem, and then actually implemented it in the hardware and built the tools to do it. And to a certain extent, that's really what's going on now, except the tools, I think, are better and wider, and the range of data that is in the world has just become so much greater. So it's really everywhere now. It used to be kind of specialized to have very large data sets, and now everybody has it.
Yeah. So Tammy, could you chime in on that evolution from your perspective as well?
Yeah, I think I witnessed a lot of the same stuff as Cecilia. I kind of classify it like this. That before the 1990s, there really wasn't internet, okay? So 1990s was just the beginning of the internet, and so that was a big thing. Then we started to see data collection, and I feel like the 2000s was wrangling of data and learning how do you store it, there's a lot of innovations in database and storage type technology. It changed everything. And even in those years, I remember going to a panel, I spoke about big data, and I said, okay, here's big data. I have this box of hard drives that someone mailed to me. Okay, we really did this. We had to buy the data, and it came in a FedEx box, and there's a bunch of hard drives we had to hook up because you really couldn't download data. Now, that's nothing. I could probably download it, and I probably have the storage in my house to hold all that data. So it's really changed. And so in the last decade, what we've seen is now that all this data is accessible, available, slightly wrangled, at least way better than it was a decade or two ago, now we can start to apply analytics to it. So now we're seeing a big increase in development in these sort of ways, methods for handling data science. And so I'm really excited to see these kind of breakthroughs and a lot of things about scalability, about randomization, which I forgot to put in my list of math topics, about randomized methods for dealing with really massive data. And I think it's only going to get more interesting as time goes on and the data is exploding even more. We hear more and more about people having more data than they can really reasonably process, and so what are we going to do about that?
Thank you. And I don't want to spend too much time on this, but I had this on my list of questions, and I think I heard someone ask about this earlier. But can anyone speak to like the different flavors of data science? And maybe there are some flavors that are missing from your company and the work that you see around you. And also maybe, I know the answer to this, but also not just what the different flavors are and what's missing, but also who is missing from data sciences.
Well, it's kind of obvious to me, of course, that women are missing and the human-centered piece is missing. So many times I have students, particularly female students, who say, well, I thought I was interested in computer science, but I really want to do something that's involved with people. And then I say, well, computer science and data science are about people. And it's a matter of how it's presented. Again, it's these mental models that, you know, you see, right? What is it? What you see is what you, you know, if you can't see it, you can't be it, right? If you think that the data science is all about, you know, some guy, you know, bending over his you know, and not being those of us right here, and you've seen this amazing diversity right here in this conference, that we're doing all these really cool things, and that young people today can do that too. And that's what I think we need to do, is bring in all those people who are excited about climate change, or maybe not excited, worried about climate change, excited about doing something to improve it, and vice versa, you know, I mean, what can we do with autonomous drones? I mean, the potential for good and for evil is so great. So we want people who care and who are going to do the right thing.
Yeah, good. Thank you. And so I also want to hear from Maggie and Sharon, if you would. What, in your world, right, because you each are occupying different spheres, what are the big questions, right? If we have an audience of practitioners, active researchers, learners, right? If you had your choice, what would you have them spend more time on? And I already know you should follow your heart and do what, but I'm just saying, from your sphere, what would you like to see more people-powered?
I would say data quality. Yes, we need more women on the data side of the house. We need data engineers, but data quality. Data fuels AI. You guys all know that, right? I look at AI as the heart, data as the blood. And the heart is useless without the blood. And I'm quoting a data scientist from Intuit. So we have an AI-driven platform, and so it's critically important that data is clean and data is understandable. We have a data-first strategy, which includes data stewardship. I'm actually leading that effort, where we have created data stewards across the company, and their role is to make sure that data is compliant, there's high data quality, and they're creating clean data entities for our data scientists in what we call a data map. And so our goal is to make sure that our data scientists have faster access to well-organized and well-documented data. And so by far, that is one of the platforms that I would love women to get involved in, data quality.
Beautiful, good, thank you. And how about you, Maggie?
Yeah, so in the robotics sphere, you can kind of see a lot of successful robots working in very specialized environments, such as factories that do simple picking and placing. So I think there's a lot of potential in using robots for generalized goods, and I think Skydio is definitely working on that. So being able to fly a drone in any environment, regardless of where it is, and potentially even in dark environments, or even if there's sun glaring near the drone, I think there's a lot of potential in finding these really difficult corner cases and being able to drill down and understanding why these corner cases are important, and being able to generalize robotics to not just a specialized field, but something that can be used in the real world. So that's something that roboticists are very interested in, and also something that borders on, as I was mentioning, philosophy, even just understanding the human mind. And I think that those are really interesting problems, and being able to understand what needs to be done in the very tail distribution of the failure cases. So very rare scenarios, but scenarios that might end up to be deadly or potentially life-threatening.
And so how would someone get better prepared to do more work with data quality or work on those tail cases that you're talking about?
Yeah, I think, first of all, like being very rigorous in math and science and just getting deep into these algorithms is very important, because at the end of the day, I think all of this boils down to first principles in physics and math. And I think for young women in particular, do not be afraid to dive deep into these subjects. And it's going to be hard. It's definitely not always intuitive, but I think just understanding that these principles are important and part of the process of making data better, I think that's what women should continue to do and strive to do.
So what I get from this is all women should be mathematicians.
Yes!
I'm a mathematician, by the way, so I'm running away with your comment there.
If it's hard to do, that means you should do it.
Yes, exactly. And how about you, Sharon, with regards to getting well prepared to do data quality? Are there specific things that people should get trained up more on?
I think data engineering, just just data in general, but that's the start.
Very good. Good. Yeah. So as we heard this morning, and everybody knows, tomorrow is
International Women's Day.
Right, International Women's Day. And so I was wondering if there's anybody on the panel, if there's anything that you're doing at your job in particular to mark Women's History Month, International Women's Day, or even more broadly than that. Are there specific initiatives that you're involved in to help women thrive and be successful in your workplace?
I would say that, yes, we're doing quite a bit at Intuit. And in honor of National Women's Day, I would like to see everyone push harder in moving from representation of women to power and influence. Intuit is partnering with the National Center for Women and Information Technology on a study that examines power, influence, and the myth of meritocracy within technology teams. Ultimately, this work will result in a power tilt assessment tool that companies can use to determine how influence operates on a specific team. And in addition to that, it will help companies determine patterns of favoritism or who might be disadvantaged on a specific team. Mm-hmm. And so I'm excited about the possibilities, but I think it's time to move beyond the numbers to power and influence.
So I hear math. I'm just kidding. I hear power and influence. Can we hear power and influence?
Yes.
Great. Excellent. Good. So we're going to be able to wrap up. So I hope people are making notes with questions. I should have told you earlier. We should have some time for questions. But what are some of the big lessons you've each learned from your own career journey? And especially lessons that would have been helpful if you had learned them even earlier.
Looking at me?
Sure, anyone can jump in.
I'll jump in. So I had a few different ones, so I'll give you some of the best advice. One advice I did get early was networking, the power of networking. And it's not just going up and introducing yourself at a conference, it's really following up and getting to know a person and establishing a relationship. And the reason that this is important, which I learned much later, luckily I had done it, is you need to have sponsors in your career. And so sponsors are more than mentors. They're people that open doors for you and help get you kind of have opportunities that you didn't even know were there. Sponsorship is really important. As you rise up, you see how people are missing opportunities because they don't have someone putting their name forward. And so part of this, what you can do about this is to network and get to know a lot of people who can become your sponsors. I also echo what Cecilia just said. If it's not hard, or if you're not failing now and then, not every day, you don't want to be failing every day, but if you're not occasionally failing, then you might not be pushing yourself hard enough and high enough. So don't be afraid to fail now and then. I also say that you have to be the one who goes out and is sort of doing the advertisements for your work. You have to do a little bit of your own self-promotion. You can have the most brilliant, theorem. I'm gonna lean into the math. And it could be world-changing, but if you don't go and tell people about that theorem, it's really not going to change the world. You're going to wait for someone else to sort of tell people about it. This doesn't work super well. So you got to get out there and communicate your work, and this happens whether you're in business or not. And I learned this by watching people who I didn't think were doing that much, but seemed to be really successful. And they would just walk around, and they'd go to each office, and they would tell them, each person, how great they were. You don't necessarily tell about yourself, but you tell about the work you're doing, and you kind of talk to people. And they actually need to know about it, because they can actually, I know you've done work that other people can use, and it's actually going to help them. So you can help them to learn about the work that you've done. And then the last thing, which is something that I learned at Anita Borg conference from Anita Borg, was that it's a Grace Hopper conference, and Anita Borg was the speaker. And she told us, and this was shocking to me at the time, I was like pretty young, that the forward progress of women is not inevitable. And this blew my mind, because I had always been taught that the forward progress of women was just a matter of time. And I heard this over and over again, and then she told me it wasn't, and then she was right. And so I just want to remind you that it's not just a matter of time. We have to keep working. The WiDS conference is a great way to do this, but don't take it for granted. Keep working. It's really hard work. I know we can do it, and you all are going to be a big part of making that happen. So that's all my advice summed up. Well, it's not all of it, but it's all I'm going to say right now.
That's all great advice. Thank you. I'm listening. Maybe the most important piece of advice I have for you is, when you're deciding what to work in, don't just do what everybody else is doing right now that seems interesting. Think about what feels important to you but is not getting as much attention. That is likely what will be the hot topic in 5 to 10 years, because I think it was maybe 15 years ago, I was working on these very large data sets, and I said, you know what? Look at all these sensors proliferating. There's going to be this explosion of data. We're going to need to do something about it. Okay, well, I wasn't in a position of power and authority at the time. If I had been, my company would have made billions, right? What can I say? But the fact is that by moving into data science, I was able to get a job in academia, something that I had never believed I could do, because there's 400 applicants for every open position. I'm not smart enough to get one of those. But hey, by the time I got into data science was getting hot, and hey, guess what? I've been working in it for 5 or 10 years. So think about, what is it that's going to be hot 5 to 10 years from today? This is what I tell my PhD students all the time. Don't do the topic that everybody else wants to work on right now. Everybody's going to be talking about the pandemic. Yes, it's very important. But 5 years from now, there's going to be a new hot topic. You want to figure out what it is now and start working in that one. And that's the guidance I give my students. And I'm happy to give tips on what is going to be good in 5 years. I have a really good track record. So.
Okay, so for my advice, I think I definitely agree with everything you guys both said about embracing failure. And then I would also add trusting the process. So just being consistent in your work and following through and showing up even when the data is making you pull your hair out, and making sure that you just show up and do the work and just take initiative as much as you can, and just make sure that you're striving to not only improve yourself, but also bring others along with you. So I think just having this holistic view on how you have the power to not only change yourself, but through changing yourself, you can change others. I think that's what has really stuck with me.
Wonderful, thank you. Persisting, right? Yeah, persisting through, that's great.
I would say you have to be aggressive at managing your career. And I thought for a long time that if you did really good work, you would get noticed. Someone would tap you on your shoulder and propel your career.
Nope.
Doesn't happen that way.
Okay.
I've learned that nobody cares more about your career than you do. Don't look to your manager to manage your career because they're busy managing their own career. So you've got to be in the driver's seat in partnership with your manager, but you've got to manage your career. Raise your hand, do what all of these lovely ladies said, take the hard stuff, the jobs that no one wants, and just make sure you're in the driver's seat.
Beautiful, wonderful, thank you. I'd like to give you a round of applause. We're not done, but still. Thank you for that great advice. This is wonderful. You see me vigorously taking notes. So where are our microphones? We're going to Oprah ourselves today. So questions? Okay, I see a question over there.
Hello, my name is Anna, and I'm currently in industry in product analytics for an ISP. And I actually have a background in humanities, so this is mainly for Maggie, but really anyone that's interested. So you mentioned, I think other speakers mentioned today too, how influential the introduction of humanities disciplines and critical thinking and the humanities discipline can be to data science. And so I'm wondering, from all your perspectives, like how did you integrate that into your career? Was it through your studies? Was it through just practical application? Was it, reading as an adult? I'm really interested to know what you think the best way to achieve that and integrate that is, especially if you spent so much time already in the technical industry.
Yeah, thanks for the question. I think when I was in college, I went through many different existential crises because I was going through wondering whether technology was truly the best way to progress society because growing up in Silicon Valley, I had always had this idealized version of how technology can help the world. And I think as I grew older, I realized that there's just so much potential for technology to do harm. And perhaps the best way to even progress society is through politics, through humanities, through art, and understanding society or sociology. So I think as I was going through these existential crises, I watched a lot of TED Talks that actually helped spur my inspiration more for STEM topics. And I think just seeing these TED Talks about all of these different technology uses and just seeing that, for instance, in my field that I was passionate about, robotics could be used in so many different areas that I was truly passionate in, made me realize that my understanding of how humanities could potentially help the world, I think, allowed me to see that technology can also bring great good to the world by understanding that technology is a force for good. It's not necessarily by default the force for good. I think we have to all make the effort to try to use technology as a benefit to society. So it's not like a default, it's something that we need to work very hard towards, and conferences like these is just one way to do this. And I think by understanding humanities, we can best understand how to use technology as we move forward.
Do we have a question from this section? Can I see someone here? Okay, you have someone over there, sure.
Thank you. Hi, my name is Jessica Lee. I work in technology consulting in data and analytics, and I just want to thank all the panelists for, not only having fantastic careers, but also taking the time to inspire us. I'm a really proud leader for our National Women in Technology group, so just love to be around this energy. My question is specifically for Sharon, though I would love to hear from the other panelists as well. I myself am a Berkeley Haas grad and also had the statistics and math background. And I started off thinking, I'm going to be a data scientist. I'm going to do all these cool models and cool insights. And the more I got involved with my clients, a lot of Fortune 500s, it all became a data exercise. And more as I went deeper into the business world, it was a lot of data quality, data cleanliness. I'm sure everyone's professor has said garbage in, garbage out before to them. So my question is, there's theme of so much data work to support data science and modeling. How do you translate that implicit value that I think makes a lot of sense to people in the field, to your other business leaders who might come from, a more traditional finance, back office, executive viewpoint, and keep them kind of abreast of the trends in this field to realize the business value from their data?
Yeah, that's a really good question, which is why I made the comment earlier, we need more women, we need more people focused on data. It is one of our #1 concerns. And I think, as I mentioned, we've got a data-first strategy at Intuit. We're building an AI-driven platform to support our smart products. And I think it's just the realization when you make AI your company priority and your biggest strategy, you can't help but make data your biggest focus and strategy. And actually, you probably heard in my introduction that I'm the VP of Data and AI, because we've merged the two organizations together. You can't do AI without data. And so we're now one organization for the company. But I think just, you gotta just stay with it. I think companies are finally getting it. I see more and more companies have a data-first strategy. They've got more investments in data curation and in data quality, data privacy. And so, I don't know, maybe I can talk to you. It's hard to see out there. At the break, some of our approaches at Intuit to, just to move up the agenda. The other thing is, I think, data and AI is not just about the technology. I think that the ability to collaborate across the business, because you can't go to a business product leader talking mathematics. Right. You've got to make sure that you can make that business connection and talk customer back. And so that's part of my role as the operations leader. I try to translate what we do in data science and AI from a business and customer perspective, because you've got to make those connections within your business.
Thank you. So there's a question here. Oops. All right, I'm seeing you. You're in my range, but we'll get to you next, okay? At this table here. Okay, good.
Hi, my name is Gina. I'm a postdoc here in the Biomedical Data Science Department. I really want to continue this discussion over quality of data, because my perspective is I generate way more data than actually analyze it. Where do we start to produce high quality data? What are the challenges for biomedical data scientists that comes with cleaning the data? Like, how do we communicate better to generate high quality data?
I think it's a similar question. No?
Yeah, I mean, do you want to take that?
Well, yeah. It starts with data ownership, data stewardship. And so you've got to make sure that data is owned across your company, that you've got great ownership, and you've got great stewardship of the data. The people closest to the data that understands the data, I say, are the caretakers of that data. And if they can structure that in a way that is well organized, well documented, it makes it easier for data scientists to engage with the data. And so that's one of our key focuses, as I mentioned, where our goal is to cut 50% of the data preparation and data wrangling from our data scientists by creating what we call a data map with clean data entities so that it's easy for folks to engage with the data.
I mean, I completely agree with Sharon, and this gets back to one of the points where humans touch the data. Yeah. This data curation, data cleaning. It's important not to just collect data and store it away. It's important the human collecting the data to look at it carefully and to make sure you're adding quality to it at every stage, at each one of these 5 points. That's what leads to high quality data and high quality data science, is not assuming everything will be automated.
All right. So I promised it has to be a really quick question. Go ahead.
Yeah, it will be very quick. My name is Hannah Atik. I work as a senior business analyst for a healthcare consulting company. My question is more related to coping techniques. For me, I feel like I deal with depression and anxiety. So first of all, I want to thank you guys for being here because you're all inspiring leaders. But my question for all 4 of you is, how do you cope with dealing with some either mental illness, being able to be vulnerable, and then also be aggressive about pursuing a strong career?
Will I comment?
Sure. Go for it.
Yeah, so I was diagnosed with panic attacks at one point in my career, and I didn't even know what they were, and so that was really interesting to deal with, and you have to be very proactive in working with your medical team to figure out what's going on, like tell them that you're having these symptoms was a good start. And then, but you're always going to feel uncomfortable. The anxiety attacks, I'm surprised I didn't have them before. And so a part of it, one thing I always ask myself is I have sort of this role model, it doesn't matter who it is, but I always say, what would my role model do? And so I had a particular role model who was sort of senior to me in my field. And honestly, I bluffed my way through so much on that. And so I just pretend I'm a different person sometimes. And it gets me a long way.
Okay, beautiful. So let's thank our panelists again. Thank you so much.
Thank you. Thank you so much. Susie, thank you all. You can now leave again. Yeah. And this question of vulnerability, one of the things that I like so much about this Women in Data Science conference, compared to other conferences I go to, is that people are much more open about these challenges and also often a little bit more humble. And this is a perfect thing to talk about and share and open up to each other in the break. We'll have a break now. For those of you online, you will be treated to some more interviews. Here, we're going to be back at 3 p.m. to meet the CEO of YouTube and the fellow of Google. I'm looking forward to that. Have a wonderful break. 3 o'clock, we're back here.
Welcome everyone to theCUBE's coverage of Women in Data Science Worldwide Conference 2022. I'm Lisa Martin, coming to you live from Stanford University at the Arriaga Alumni Center. It's great to be back at WiDS in person, and I'm pleased to welcome fresh from the main stage, Tiara Bills, Assistant Professor at UCLA. Tiara, welcome to the program.
I'm glad to be here. Thank you for having me.
Tell me a little bit about your background. You're a civil engineer, and I was telling you so was my dad, so I'm partial to civil engineers. But give our audience an overview of your background, what you studied, and all that good stuff.
Yeah, so I'm a civil engineer, specifically transportation engineer. At UCLA, I also have an appointment in the public policy department, and so I'm split between the two. My work focuses on travel demand modeling and how to use these tools to better inform and learn more about transportation equity and how to advance transportation equity. And what that means is that we are prioritizing the needs of vulnerable communities in terms of the data that we're using, the models that we're using to guide decision making, in terms of the very projects that we evaluate and ultimately the decisions that we make to invest in certain transportation improvements.
How did you get interested in transportation equity?
Yeah, so I think it stems from growing up in Detroit. So I'm a Detroit born and raised native. And it stems from growing up in an environment where it was very clear that space matters, that where you live, the modes that you have access to, whether you have a car or not, whether you have flexibility in your travel, it all matters, and it all governs the opportunities that you have access to. So it was very clear to me when I would realize that certain kids didn't really leave their neighborhood. You know, they didn't travel about the city, let alone outside of the city and abroad. And so, and there are also other, examples of, there are examples and cases after case where it's clear that communities are being exposed to a high level of emissions, for example, that might result from transportation, but they're not positioned to benefit in the same ways as the people who own the infrastructure or own the freight or what have you. So these are all very real experiences that have motivated my interest in transportation equity.
Interesting. It's something I actually had never thought about, but you bring up a great point. Talk to me about the travel demand models, how they're relevant, and where some of the biases are in travel data.
Right, so travel demand models, they're computational tools. They're empirically estimated, meaning that they're estimated from raw data. Everything about them is driven by the data that you have access to, and how they're used is largely in regional transportation planning, when it is necessary for regions to assess 10, maybe 15, 20 years into the future, how is transportation going to change as a result of changes in travel patterns, growth in the population, changes in how firms are distributed across the landscape, environmental changes, all sorts of changes that guide and direct our transportation decisions at an individual level. So regions are assessing these things over time, and they need these powerful travel demand models in order to perform those assessments. And then they also, once they have an understanding of what the need is, because, for example, they expect traffic congestion to increase over time, there needs to be a means of assessing alternatives for mitigating those issues. And so they use the same types of models to understand if we expand highway capacity, if we build a new form of transit, is that going to mitigate the challenges that we're going to face in the future?
And travel demand modeling and equity, what's the connection there? I imagine there's a pretty deep connection.
Right, so the connection is that so we're using these tools to decide on the future of transportation investments. And because of a history of understanding that we have around how ignoring the conditions for vulnerable communities, ignoring how transportation decisions might differentially impact different groups, different segments, if we ignore that, then it can lead to devastating outcomes. And so I'm citing examples of the construction of the Eisenhower interstate system back in the 50s and 60s, where we know today that there were millions of Black and minoritized communities that were displaced. They weren't fairly compensated, all because of lack of consideration for outcomes to these communities in the planning process. And so we're aware that these kinds of things can happen. And because of that, we now have federal regulations that require equity analysis to occur for any project that's going to leverage federal funding.
Okay.
And so it's tied to our understanding of what can happen when we don't focus on equity. It's also tied to what the current regulations are. The challenge is that we need better guidance on how to do this, how to perform the equity analysis, what types of improvements are actually going to move the needle and advance us toward a state where we can prioritize the needs of the vulnerable travelers and residents.
What excites you about the work that you're doing?
I have a vested interest in seeing conditions improve for the underdog, if you will, for folks who they work hard but they still struggle. for folks who experience discrimination in different forms. And so I have a vested interest in seeing conditions improve for them. And so I'm really excited about the time that we're in. I'm excited that equity is now at the height of many discussions because it's opening up resources, right, to have more folks paying attention, more folks researching, more folks developing methods and processes that will actually help to advance equity.
Advancing equity, we definitely need that. And you're right, there's good visibility on it right now, and let's
Absolutely.
take advantage of that for the good things that can come out of it. Talk to me a little bit about what you talked about in your talk earlier today here at WiDS.
Right, so today I got a chance to elaborate on how travel demand models can end up with issues of bias and underrepresentation. And it's tied to a number of things, but one of them is the data that we're using. Because these are empirically estimated tools, they take their form, they take their significance, everything about them is shaped by the data that we use. And at the same time, we are aware that vulnerable communities are more prone to issues that contribute to data bias and underrepresentation. So issues, for example, like non-response, issues like coverage bias, which means that certain groups are, for whatever reason, not in the sampling frame. And so because we know that these types of errors are more prevalent for vulnerable communities, it brings, it raises questions about the quality of the decisions that come out of these models that we estimate based on these data. And so I'm interested in weaving these parts together. And part of it has to do with understanding the conditions that, that underlie the data. So what do I mean by conditions? I gave an example of cases where there is discrimination, and as evidenced by the data that we have available, as evidenced, for example, by examining the quality of service across racial groups using Uber and Lyft, right? So we have information that presents this to us, but that information is still outside of what we typically use to estimate travel demand models. That information is not being used to understand the context under which people are making decisions. It's not being used to better understand the constraints that people are facing when they're making decisions. And so what is the connection? That means that we are using data that does not well capture the target group, people who are lower income, elderly, transit dependent. We're not capturing these groups very well because of the prevalence of various types of survey bias. And it is shaping our models in unknown ways. And so my group is really trying to make that connection between, okay, how do we collect better data, first of all? But second, what does that mean? What are the ramifications for prediction accuracy for various groups? And then beyond that, what are the policy implications, right? I think that the risk is that we might be making wrong decisions, right? We might be assuming that certain types of improvements are actually going to improve the quality of service for vulnerable communities when they actually don't. And so that's the worry, and that's part of the unknown, and that's why I'm working in this area.
Part of the unknown, but also, I'm sure, part of your passion and your interest.
Absolutely.
International Women's Day is tomorrow, and the theme this year is Break the Bias, or Breaking the Bias. With
Worthy theme.
respect to travel equity, where do you think we are on being able to start mitigating some of the biases that you talked about?
I think that it's all about phasing. I think that there are things that we can do now, right? And so at the point of making decisions, we can view the results that we have through this lens, that it might be an incomplete picture. We can view it through a historical lens. We can also view it using emerging data that allows for us to explore some of these constraints that might be exogenous to the models or not included in how we estimate the models. And so that's one thing that we can do in practice is, okay, we already know that there's some challenges. Let's view this from a different lens as opposed to assuming that it's giving us the complete picture.
Right.
And that's kind of been my theme today is that, as decision makers, as analysts, as data scientists, as researchers, we do have this tendency of assuming that the data that we have, the results that we have is giving us the complete picture.
Right.
When we know that it's not.
We know that.
We act as if it is, but we know that it's not.
Right.
And so, we need to, there's a lot of learning and changing of behaviors that has to happen.
Changing of behaviors is challenging.
It is. Behavior change is tough.
But it's necessary.
But it's necessary. Right? It's necessary and it's urgent and it's critical, especially if we're going to improve conditions for vulnerable communities.
What are some of the things that excite you looking at where we are now? We've got a nice visibility on equity. There's the conscious understanding of the bias in data and the work to help to mitigate that. What are some of the things that excite you about what you're doing? And maybe even some of the policies that you think should be enacted as a result of more encompassing data sets?
It's a good question. One thing I will say is what excites me is it's also tied to the emerging data that we have available. So I'm trying to go back to an example that I gave about measuring constraints. I think that we can now do that in interesting ways because we're collecting data about everything. We're collecting data about not just about where we travel, but how we travel, why we travel. We collect information on who we're traveling with. So there's a lot more information that we can make use of, in particular to understand constraints. So it's really exciting to me. And when I say that, again, I'm talking about how when we make a choice to take a certain mode of transportation or to leave our house at a certain time in the morning to get to work, we're making that under some conditions, right? And those conditions aren't always observed in traditional data sets. I think now we're at a time where emerging data sources can start to capture some of that, and so we can ask questions that we weren't able to, or answer questions that we weren't able to answer before. And the reason why it's important in the modeling is because in the models you have this sort of choice-driven side and you have the alternatives. So you're making a choice among some set of alternatives. We model the choices and we spend a lot of time and pay a lot of attention to the decision process and what factors goes into making the choice, assuming that everyone really has the same set of universal choices.
Right.
I think that we need to pay a little more attention to understanding the constraints that people have and how that guides the overall outcomes. Right. So that's what I'm excited about. I mean, it's basically leveraging the new data in new ways that we weren't able to before.
Leveraging the data in new ways. Love it. Tira, thank you for joining me talking about transportation equity, what you're doing there, the opportunities, and kind of where we are on that road, if you will.
Thank you so much for having me.
My pleasure. I'm Lisa Martin. You're watching theCUBE's coverage of Women in Data Science Conference 2022. We'll be right back with our next guest.
All right, and we're back. It's 3 o'clock. And we have one more session to go. And I will just talk a little bit here while people come back from outside, warming up. I think we're still collecting data for Jessica. Hot, cold, hot, cold. But I wanted to just tell you a little bit about some of the other events that are happening around the world this week. So this coming week, we have WiDS in Africa. We have WiDS in Tokyo. We have WiDS at the American University of Beirut in Lebanon, despite everything that's been going on there. And we have WiDS in New Zealand and in Quito. So after this conference, I know we only have 2 more hours and a reception together, but after this conference, you can enjoy WiDS in other places as well. But now I'm incredibly happy to welcome to the stage Susan Wojcicki, CEO of YouTube, and Diane Tang, Fellow of Google. Please welcome them to our stage. And thanks so much for coming. And it's my great pleasure to have almost 30 minutes with them to ask them all kinds of questions. So I have to say that I'm a little bit nervous because I'm sitting next to a huge CEO. And I'm just a little professor here at Stanford University. And the other
I should be nervous. I mean, this is like some pretty amazing talent in the room here. And so I'm really glad to be here and see so many women interested in data science. So it's an honor for us to come and speak and meet all of you here for a short time.
Certainly. I was telling Susan, I almost never do external events, so I am crazy nervous right now.
Yeah, well, the other thing that came to my mind when I was thinking about, we got Susan from YouTube, is that I have to admit, I have a bit of a love-hate relationship with YouTube. I love it. You know, I'm a big cycling fanatic, and I rely on YouTube's recommendation system to keep me abreast. But I've been on YouTube with videos myself, and I really dislike those, especially the comments that people make. But Susan, I want to start with you because not too long ago, a woman in the conference, Anna, asked a question about the humanities and the importance of the humanities in work. And so this is for Anna. Because when I look at your bio, you started as a humanities major.
Yeah.
And then you studied history and literature. And then you went to economics and business. And now you found yourself a CEO of YouTube. So of course, the first question one asks is, how did that happen?
Yeah, well, I think it's really good to have a diverse background, and it's good to explore new and different areas. And I had been history and literature as an undergraduate. I only took my first computer science class when I was a senior in college. And it happened because I used to do temp work during my vacations, and I was assigned once to a startup, and I realized they were doing really interesting work, and I wanted to learn more, and I took a computer science class. I took CS50, which was the intro for a computer science major, and I loved it. And it was interesting because at the time I thought, like, it's too late for me. You know, I was only 21, right? And I thought, like, it's too late to be computer science. Like, my career's over. And so I do think it is really important for people to remember that you can make changes and learn and adjust your career over time. And it just appealed to me, the creative, the dynamic, fast-moving, many components of it. And then when I actually grew up here in the Bay Area. My dad was a professor at Stanford. So when I came back, I got a job at a startup. And I've been in tech now for almost 35 years.
So did you feel like a bit of an imposter when you first went into tech?
I was just surprised that I liked it, because the impression of tech was that it was this very, I had seen it's a not very interesting field, but what appealed to me was the ability to create, and I loved the fact that I could make something and it could be used by people all over the world, and that you could use tools and it could create something super meaningful. And so I immediately got that creative aspect of it. And I think, you know, having a diverse background is really good. We deal with hard issues as a CEO. You deal with things that are technical, but also things that are ethical and people, and understanding a lot of background and having a full context has been really helpful for me. So I do think having diverse backgrounds in what you study can be really helpful to understand any kind of issue from many different dimensions and backgrounds.
I was going to ask you what skills that you gained during your studies in a non-tech field really helped you as CEO, but you already answered that now. Diane, you're a fellow at Google, and you've been there for a long time. Now, it may not be very obvious to the audience what it means to be a Google Fellow, so maybe you can tell us a little bit about that. And the other thing I'm really curious about, you've been at Google at the forefront of technology for quite some time. During this whole incredible new hype around data science, and you've seen it become so very large, not just at the company, but also in the world. So tell us about that as well, if you can.
Sure thing. So a fellow at Google is effectively the highest level of individual contributor at Google. So it's equivalent to like a VP level, but it basically means that you get to tackle, quite frankly, whatever interesting problems really need a level of depth, but also across Google, cross-functional expertise. So I tend to focus more on analytics. I'll be honest with you, I use analytics and data science as my wedge in to go and talk about all sorts of strategic issues at Google. So I tend to stick my nose in, usually in a helpful way, into various different areas all throughout Google. So, you know, that's sort of a fellow job. It's effectively an individual contributor, really one about influence without authority, but really bringing a technical expertise and a technical depth. So that's sort of the job. It's crazy fun.
And when you first asked me to come, I was really glad to come because this is such an important group. But I was like, the person who really knows the most about data science is Diane. So I have to bring her. She answers basically all the hard questions that Google wants to know about. And so if there's something we haven't figured out or we want to have a lot more analysis on something, we go to Diane, and she provides a lot of insights for us.
Sometimes.
Well, there's sometimes not. I know you're going to ask about it, but sometimes not the insights we expected we would learn about.
That is
the
certainly
answer
true.
isn't what we expected, but she always gives us a very truthful answer.
That's good. So how has the role of data science changed in your job, Diane, and at the company over time?
I think it's been fascinating because when I certainly started at Google, there was no such thing as data science. You know, I might tell the story just in terms of how we've changed the name of the job over time. It originally started as a decision support analyst, because really the goal was to provide data to support decisions. Then we sort of broadened it to sort of think about quantitative analysis. And so it was called the quantitative analysis job for a long time. And then people were like, there's this thing called data science, and like maybe you should rename it. And I kept going, wow. Anyway, but we finally caved and renamed our internal job descriptions to be data science. So what I would say is that, you know, there's just a little bit of a story just in and of itself with regards to the names, but we've really sort of always viewed data science as making sense of what we're seeing through data, right? And like, you know, there's a question about what questions you can and can't answer, and it's really about how do you actually give that insight and give the insights to really be able to say, okay, what should the decision be? I think the other key piece of it is it's all about uncertainty, right? The key thing is that with the data, it's reasoning under uncertainty. So you have to be able to say, okay, I can give you this level of information and this level of uncertainty. The rest is up to you, right? And like, you know, I'm like, now it's your judgment time because I can't do anything else. This is the level of uncertainty that I can mitigate. And so that's sort of been an interesting thing, and just really working with leadership to basically say, here's what we can do, here's the limits, what do you want to do? And really to help frame the discussion, frame the decision in that way.
So you talked about how the idea behind the work that you've been doing has changed from, data-driven decision-making support to now data scientists. What are we going to call data scientists 5 years from now? Uncertainty quantifiers?
Who knows? Who knows? But I think that is a large part of what the job is. It's reasoning under uncertainty, and there are different types of uncertainty, right? And so there's the representational uncertainty. How should I represent the actual world? Through to what we sort of think about much more, which is statistical uncertainty. But it's really about the different types of uncertainty that we have to work with.
Now, data science and data science algorithms, of course, are a really, really big part of YouTube as well. And one of the prime examples of it is the recommender system that you have, which I use almost every day, right? And sometimes I like it and sometimes I don't, but I won't. I love it. I love it.
Yeah, we'll have to talk afterwards.
Yeah,
what you don't like about it.
Yeah. But I know you really like working on these recommender systems. And so I would love to hear how that has evolved over time, how you build those. And recently you did a total revamp. And so I'd love to hear about that too, and what kind of benefits that has given you and the company.
Sure. Well, recommendations are really essential to YouTube because of the volume that we operate at. So we have billions of people who come to YouTube every single day, and we have over 500 hours that are uploaded every minute to YouTube. So as a result, we need to figure out how do you match this large volume of users with content, and how do I know that you're interested in cycling, for example, right? And we'll have to talk afterwards about what you're not interested in. But ideally...
Botox, I'm not in.
So we look at those signals. We look at, for the users, what is the history in terms of what they've watched, what have they said they like, what have they said they dislike, and then we also survey the users to understand their feelings about some of those videos in terms of what was really positive or what was really negative, and then we include that into our learning system to better predict what is it to actually show to a user. Now, our systems generally evolved in terms of trying to, using new machine learning and new approaches to do that in a better, more efficient way. I believe we use over 80 billion signals, or some very large amount of data to better understand what are the right sets of content to recommend to you. But over the years, it got increasingly complex, and we had to, as YouTube moved more from entertainment to information, we had to make changes in terms of how our systems worked. So when you think about entertainment, it's okay if there's a song that came out yesterday and now in the first 24 hours, and we have some new hits that come out will have millions, 100 million views, for example, in 24 hours. And that's okay for entertainment, but when you deal with something like news or medical information, you don't want it to be from a new source that suddenly has this huge amount of views. You want to go back to trusted sources that you know are going to rely important information. So our systems had to diverge a little bit and to be able to understand, hey, here's a new movie trailer. It's okay if there are millions and millions of views, but if you're talking about the war in Ukraine, you want to make sure that you're bringing up sources that are trusted so that you're not conveying any kind of misinformation. And then, of course, we also have wanted to look at ML fairness to make sure that we have an understanding, too, to make sure that our systems have learned, or what they've learned has enabled us to be representative in terms of what we're recommending as well. So we have our overall system, but then we have these different layers in terms of how to make sure that our systems are responsible in terms of the recommendations that we deliver. So. We could talk about this for a long time, but...
yeah, well, let's talk about it just a little bit more. Because I would love to hear where you think the biggest change still needs to happen in the recommender system. What is the biggest challenge that you're going to ask Diane to solve for you?
Yeah, I know, we should ask Diane. But I mean, first of all, I will say our machine learning and our techniques have gotten a lot better over time. So that has been really positive, and I expect that to continue to get more and more sophisticated in terms of understanding what are the right content for us to use and recommend to you. And similar for our advertising, we use similar types of algorithms. But there are still lots of areas where I'd say there's more work for us to do. One of the areas that we're very challenged with is understanding what are areas that you're interested in that we don't yet know about. So that actually, I'm sure there are many areas, but we just don't know about it. And that's actually problematic because in order for us to find out what you're interested in, we actually have to show a lot of impressions of things probably you don't want to see. So actually, as we're moving to more short form content, in many ways, that actually gives us a new way to explore and try to understand. So we talk about exploration. How do we explore even more effectively? And there certainly are other areas where I think it'll be really hard for machines to really be 100%. So when we deal with really sensitive issues, like you could say hate or harassment or other areas like that, we can't just use machines to be able to determine that. We have to use humans in a lot of those cases to be able to understand the context that's associated with what's been said, how it's been said, but certainly over time, I expect our classifiers to get better and better to help us do more and more with machines effectively.
One of the reasons why it's so nice to have you both here today is that you're the person with the wishes and desires and the demands, and you're the person providing the solution. So Diane, I want to ask you, because this is something that is so common in the field of data science, how do you translate what the decision makers and executives want to something that is workable in technology?
It's actually, I think, where 90% of the work is, actually. And so the way I sort of think about it is, it's like, what do you actually want to do? It's like, I'll come and you'll be like, okay, I need this. And I'm like, why? Tell me why. What are you going to do with it? Right? Because I think it's very important to understand that why, because the answer may not lie in what you asked for, right? And so a large, it's like, I have interesting stories. Like, there was this time that a bunch of folks, in this case, I'll use, like it was like the head of search, the head of ads, and the head of engineering. So Alan, Amit, and Sridhar. And they came to me like, we have all these questions. And I'm like, great, I love questions. Tell me your questions. And I'm listening to their questions, and I'm listening to their questions. And I'm like, you don't really have questions that I can work with directly analytically. And so so much of the work was actually in saying, okay, here's where we are from a business perspective. And really what you're trying to understand is you're trying to understand things about how the users are going to be using devices and, understanding, things about what, is going to be, interesting from like a commercial perspective or things along those lines. And so much of our work was actually in saying, here are the business questions. Here's what's actually answerable analytically. Now let's sort of see where the matches are, because then part of my job is to go, okay, I see that you have this business question. I got nothing for you. You're going to have to find some other way of doing it. And then there are other times where I'm like, okay, here's what I got. And I'll give another example. I was asked a lot about how to come up with long-term value for users. I'm okay, what do you want? And I was like, I want the like the absolute value of the long-term value of users. I'm like, okay, why? And I keep asking and I keep asking. And what it comes down to is like, actually, what's much more useful? I'm like, I don't think you want that. What you really want, you want the relative change in value. That's going to be much more useful for what you're sort of doing. So, it's a lot of that interpretation, and it really requires understanding the domain expertise. And that's one of the fun things about data science is like the amount that you have to really understand the domain in order to be effective. But I guess I'll turn it over to you, Susan. How do you feel when I come back and I say, ha, it's on you. I got nothing for you.
Well, I don't think you actually come back that often and say you've got nothing.
That's true. I try to avoid that.
I think, a lot of times it will start where I'll ask a question, or, my equivalent, someone will ask a question, and you will refine our question. Like, oh, I think you really meant this, right? Is that really what you meant? Or could you explain, was it this or this, right? So you give us a lot more clarity and maybe how that question could get answered. And then I'm like, oh yeah, that's exactly what I meant, even though it wasn't really what I meant. You help me understand and get there. And then, like you said, there will be a lot of answers, and there are some set of things that data science can answer, and those answers can be unexpected. And then, when they're unexpected, we need to figure out, well, how do you explain them? This isn't what I thought I was going to get. Well, why is that? And in some ways, those are the most valuable moments, because that's actually when you're learning, and that's when the data is telling you something that you didn't expect or you didn't know. So you have to, I think you really have to pay attention and be willing to learn. And then there'll be times where you'll say, I don't, the data can't tease out what that actual answer is. And that's, I'd say, where more the business expertise and judgment needs to come in, saying based on what we know, we're going to have to deal with the uncertainty and make our best decision. Or we'll have to go back and ask a different set of questions to be able to figure out how do we get closer. So I think there's a lot of back and forth between how the business makes decision and our data science and analytics. And it is really important just to let the data lead. It is important to also interpret what does that mean. We spend a lot of time, I would say, across Google, like getting results and then asking, like, what did we mean, and was this right, and what if you had included this, and what if you had looked at the question a different way, would it have been the same result, let's go back, let's redo it. And I do think that is really healthy to get to what is ultimately the best set of knowledge about a specific set of issues, so.
And it's okay, apparently, to just say, I don't have a solution for that, because you haven't been fired yet, Diane.
I have not been fired yet.
No, so that's good. And it brings me to this next question, because you mentioned failing and not knowing. And here I'm sitting totally in awe of two people who have reached the pinnacle of their career, and by all definitions that we may use, are very, very successful. So I'd like to talk about failure and ask you how you've dealt with that over your career. This is a theme that has come up several times today. And for me, my own career has been one mistake after another. In fact, I always think that the definition of an expert is someone who's made every possible mistake. So tell me about how you approach failing, quote unquote, setbacks, not knowing, and how you've dealt with that throughout your career.
So failure is going to happen for anyone and everyone throughout your career. There's no way to always get everything right and to make all the right decisions. And I've always just approached it, which has been hard, but over time I've really tried to approach it by stepping back and being as unemotional from it as I can, just trying to understand it and accept it. Because what I've learned is that like our natural tendencies are to deny that failure. I mean, there are many things we can do. One is we can be like, no, I didn't fail. So in business, it's very easy for you to build a product, the product's not successful, and be like, oh no, it's gonna be successful. It's gonna be successful. If we just do this, it will get better. And not actually just acknowledge that there's probably something wrong, or we probably missed something, or there's a mistake. And so I think it's really important to just have a step back, not be personal about it, and to figure out, like, well, what should we do? Should we fix it? Should we cancel it? Should we move on? And that's a really hard thing to do, and it's really hard to accept the failure. But I've learned over time that if you don't, it just gets worse and worse and worse. You sort of dig yourself deeper and deeper into the hole, and it's better to just get out of the hole as quickly as you possibly can and move on. And it's sometimes those failures that give you insights into whatever you do next that will actually help you be super successful or achieve the success you didn't have in the first project, but to achieve it in the second project or when you do it in the future, in your future endeavor. So that's sort of how I approach it. And there've been many, I'm here as CEO of YouTube, but I used to work on Google Video, which was a competitor to YouTube. And at one point, we had to make a decision. Do we just continue with Google Video, or do we buy YouTube and sort of throw in the towel? And that was a really hard decision, but it was clear to me that was the right long-term decision for us to make. And a lot of people were really upset. A lot of people quit. A lot of people left. A lot of people didn't like that decision. But it was clear it was the right one. And so, I also just encourage people not to give up. I think there are times that people are really upset about something. I know I've been in there where you're really angry with whatever happened. You're like, I'm so angry. I'm just going to quit. Like, serve them right? I'll quit and leave and do my own thing, and like, they'll suffer. And like, but it never works that way. Like, if you quit, like, they won and you lost. So you need to stay in there. And I've I've been at Google now for over 20 years. So, you know, it's good. Like, you stay there, and over time, you work it out, you figure it out, it's good to just stick with it and keep arguing for what you believe in and what's important to you and what you think will make a difference for your users and customers and your product or whatever your mission is. So,
what about you, Diane?
It's interesting. I was going to echo a couple of things. I mean, I think the first piece of advice that I have, especially when I get really upset about certain failures, is the first thing is sleep on it. It's always better the next day. it's like a lot of these things. It's better with perspective, is what I would say. So that's just one thing. The other thing is, practically speaking, one of the things I found the most useful to do, and we do this actually within engineering all the time. It's got a horribly morbid name, which is a postmortem. Right? And the question is, why? Why did it fail? What happened? What did we learn from it? And I think, that question of why is the really critical one. And I think the key thing is why did it happen? You get an answer, okay, but why did that happen? And you have to just keep going and keep iterating so that you can really learn from what happened, right? Because that's the only way to really get better and to really do it better the next time. And so, the thing I sort of say is learn from the failure. Otherwise, it's a waste. Right? If you're going to try the thing, take the risk. When you fail, learn from it so that when you take the next risk, you don't make the same mistake. There was someone that I used to work for. His name is Jeff Huber. And, you'd come and you'd be like, okay, you made a mistake and so on and so forth. It's like, okay, did we get, did the learnings that we learned from that mistake, was it worth it? Are we not going to make that mistake again? And it's until you can actually say yes to that question, like, yes, we've learned all that we can learn so that we don't do it again, that's when you've learned from that failure.
Yeah, love it. So it's amazing how fast time flies when you're talking to two people like this. But we have a few more minutes. And before we close, I just wanted to ask you, we have all these people in the audience, a lot of whom are just starting their career, a lot of whom are still starting their studies or are studying. You just talked about failure and how you deal with that. There's great pieces of advice. What else would you like to leave the audience with? What other pieces of advice do you have? So they can be the next CEO of YouTube, right? 20 years from now, some of you, maybe?
I would just encourage all of you to be curious and to think about the future and think about what's really meaningful to you. And when I actually joined Google, I joined Google as a company. I was officially employee 16, but about 4 people joined the day before. So I was very early in my joining Google, and I just joined it because at the end of the day, I thought it was going to be they had no revenue at the time. I just thought, this is going to be an interesting place because it's delivering value to people, it's delivering information to users. I could see people writing to us. We used to have an email queue that we would all get when users wrote to support at Google. Everyone was on it. People would write about how it had made a difference for them. And so I just encourage you to be very open about looking for what is meaningful for you and how can you make a difference, and being curious about the world and believing that it will change and it will be different. So things that are growing fast will be very different 5 years from now. So I think if you find something that's meaningful, you feel like you're doing a good job, you feel like you can make a difference and grow, and it's something you love doing and you love the people that are there, then that will take you far.
Diane, you have a minute to add something.
So what I tend to say more than anything is to stay flexible. Everyone likes to ask us well, how did you plan your career? How did you get here? And I'm like, honestly, I never made any plans. And don't get me wrong, I think I was very lucky in many different ways, but there is a level of being open to opportunity, being open to possibility, staying flexible, dealing with whatever changes are happening around you that you may not have control over. And it's not a matter of actually having the control over those changes, but it's about how you actually react to them. And what do you do with that? And how do you sort of start owning your path and what choices you make? And so, dealing with ambiguity, dealing with flexibility, and basically adapting to the situation. It's like, yeah, you may have a planned path, may or may not happen that way. So the question is, how do you sort of manage, whatever's going to come? There's a famous question, like all new Google, it's like, what is the one thing you want me to learn? When I'm new to Google, what do you want me to, what should I, learn? I'm like, learn how to roll with the punches.
That is a great way to end this. Thank you so much, both of you, for coming out and being here with us. Susan, Diane, thanks.
Thank you.
And I have to quickly jump to my table and get my program, so I actually know what I'm doing next. Right, I'm delighted that we're going back to Tech Vision Talks, and the next speaker deserves a fantastic round of applause. It's Maggie Wang, who was with us in the career panel earlier. This is one of her very first presentations at the conference. She is talking about Skydio, and she's only been there for 7 months, and this takes a lot of courage. So Maggie, thanks so much for coming out.
Hi, I'm so excited to be here today to talk to you about drones. So let me start with a quick example of how drones can be so effective. So imagine you need to inspect a landslide. In the past, humans had to risk their life in order to climb among unstable rocks and take pictures with their cell phone. When we bring in a Skydio drone, we can create a high-quality 3D reconstruction of the scene without risking any human lives. So this is just one example of how drones can be used for good. If a drone can fly without ever crashing and with full understanding of its surroundings, imagine the possibilities they hold across all industries and use cases. Our mission at Skydio is to make the world more productive, creative, and safe with autonomous flight. So instead of risking a life during an active shooting or a fire, we can bring a drone in instead to help first responders understand what's going on. We can also use drones to digitalize the physical world with millimeter precision, instead of using helicopters or heavy machinery. We can also capture amazing shots using advanced tracking and cinematography for drones. So now I'm going to talk about how Skydio began, what we're doing now, and where we're headed. So the founders of Skydio were at MIT, and in 2009, they created a fixed-wing plane that could traverse in this parking lot. And it did this all autonomously using a laser rangefinder. And their vision was that drones should be able to completely navigate in autonomous surroundings, all using low-cost sensors, like the cameras in your phone. So since its founding in 2014, the company has grown to over 300 people with experts in AI, robotics, hardware, and sales. The company is the first US drone company to reach unicorn status, and it designs and manufactures the drones in the United States. The drones are trusted by the US Department of Defense, enterprises, and everyday consumers. So in the past, computers and sensors used to be large and clunky, and that's why we could only put rudimentary sensors on drones, and we can only fly them manually. So with the invention of better sensors and computers in this past decade, we're able to enter this age of AI-driven autonomy. And so Skydio drones are able to fully navigate autonomously, avoid obstacles, and understand its environment intelligently. So what enables this intelligence? Well, the answer is the Skydio Autonomy Engine. And autonomy means to understand, act, and see. It's the brains of the robot. So you can see here, this is the autonomy engine in action. So the drone has to go from sensor inputs, like cameras and accelerometers, and actually make the robot move in the real world. So this is at the core of all of our products, and it is through a decade of research and development in AI, computer vision, and robotics. So going back to the land slide, how is the robot able to avoid obstacles in this difficult situation? So the first thing that has to happen is the robot needs to know where it is in the world. So this is the problem of state estimation. So it has to go from images from the camera to actually estimating where it is in 3D space. Then we have to use vision in order to track objects and be able to understand the environment. Finally, it's the problem of planning and controls, which is actually making the robot plan and move in the environment. So this is done on board with an NVIDIA TX2 processor. So this is basically a computer that runs on the drone. So now I'm going to talk to you about vision. So you can see here that this drone is tracking this mountain biker. And this is very complicated, and it's being able to track this through neural networks. So we actually run 9 neural networks on the drone at a time. And the drones have 360-degree obstacle avoidance with 3 cameras on the top and 3 cameras on the bottom. And each camera has 200-degree field of view. So it's able to see all the obstacles around it. And this vision is done using both machine learning and 3D classical geometric approaches. So most drones are not autonomous. They don't have autonomy capabilities. And even drones that claim to be autonomous can still crash because they don't have full 360-degree coverage, and they can't necessarily handle extreme visual conditions. So we've made a huge effort at Skydio to tackle these conditions, such as thin branches, wires, and textureless surfaces. And this is really difficult for drones to be able to do. And we try to capture this through failure cases and improve our model. So now I'm going to talk about state estimation, which is the problem of knowing where the drone is in the world. So you can see here, this is one of the cameras on our drone, and this is all a 2D image. So all of these are 2D images that the drone is able to see. And so the things you see in green are called feature tracks. And so essentially they're points that are being changed over frames, and we're tracking this across frames. And we have to turn these 2D pixels into 3D understanding of where these cameras are. And so this is done through 3D geometric processing, through a process called visual inertial odometry. So we also use an extended Kalman filter in order to fuse GPS and barometer into a single estimate of the robot's state. So we also do a lot of sensor calibration because every sensor has its own bias, and also it may change depending on the environment. So what's actually really interesting is that depending on the temperature, the lens of the drone will actually distort and change shape. So we even have to account for small things like that. So even if you're flying indoors and it's hot and all of a sudden you go outside and it's cold, the drone has to estimate online what this temperature is and make sure that we account for this distortion. So all of this combined allows us to visually navigate in really tough environments like this one. So you can see, even without GPS and radio frequency, it can navigate in really difficult environments. So now I'm going to talk about planning and controls. And so you can see here that this drone is following this mountain biker, and it's planning over 2 seconds in advance. And it actually has a trade-off between a bunch of different objectives, over 50 different objectives. So these objectives can include making sure that this mountain biker is in frame, or that we get smooth flight, or making sure we don't crash. And this is run really quickly on the drone, and we fine-tune this plan at 500 iterations per second. So now that I've told you about how the drones do state estimation, vision, and planning and controls, I'm going to tell you about a specific use case of the drone, which is Skydio 3D scan. So what this allows is we can create a 3D reconstruction of anything in the physical world. So whether it be a bridge, a building, or a tower, we can put this all in a digital environment, as a digital twin. So why is inspection so important? Well, all around the world, there's crumbling infrastructure. So even earlier this year, a bridge in Pittsburgh collapsed. And a Skydio drone could have prevented this. It could have helped engineers understand the structural problems of this bridge. So how does 3D scan work? So it's actually quite simple. The first thing you do is just set a bounding box of where the drone needs to fly, and then you set a bunch of settings like the precision that you want the drones to fly in, or the amount of overlap you want your pictures to be in. And then you just press go, and the drone does everything for you. So this is better than traditional solutions of scanning, because in other solutions, they'll just fly on top of the scene that they're trying to capture, and they'll fly in a lawnmower pattern. So the drone is actually able to go through every single nook and cranny and take a picture of the surface. So one important example of how 3D scan can be useful is in car crashes. So in car crashes, what typically happens is that a policeman will show up and they'll take their phone and just snap some pictures. But you can obviously lose a lot of information. There's potentially crucial information that isn't taken in. So with Skydio drones, what happens first is that it explores the environment and creates this coarse 3D map. And you can see here that as the drone is moving, the map gets updated and gets continuously better. And then after it creates this map, it actually does this capturing. So it explores and plans every single surface and makes sure that it covers it to the precise resolution that you want with the desired overlap. So this is the final 3D model of all of the cars in this scene. So you can see that this is not only high fidelity, but this was actually done under 10 minutes. So you can create this really efficiently, and it's actually very practical to use. So how is data involved in all of this? Well, you can essentially think of robotics as a huge problem of using data, because everything that comes into the robot is data. But one thing that we use it for is simulation. So we actually run a lot of simulation on the drone, and it helps in development. So instead of having to create an algorithm and fly it in the real world right away, we put it in simulation and make sure that it passes this. And it also helps when we test in simulation for rare scenarios that is difficult to actually see in the real world. So we also do regression testing, and that allows us to make sure that if we make one change, we won't break other parts of the system. And we run these regression tests on continuous integration. So we also make use of flight logs, and actually there's a ton of data that comes into the drone. There's over 3,000 events that are logged each second. And all of this is stored in this thing called a logbook. And we can use this logbook and understand how our customers are using our drones, and also create statistical analysis of all these flight data in an aggregate way. So looking into the future, we're currently in stage 1 and stage 2 of what we call the arc of autonomy. And this is essentially where we are now, where we fly a drone and it takes off autonomously, and we fly this one by one. And you have to be there. But what we're working towards is a dock. So essentially, in a dock situation, you can take off the drone and land the drone even if you're halfway across the world. And that allows for remote service. After that, we'll be working on multiple drones, and then eventually having drones as a service. So from construction to search and rescue to almost anything in your imagination, drones can be used for good. Thank you.
You nailed it, Maggie. That was terrific.
Oh,
Thanks. Put it on there. And I just wanted to give a shout out again. It's incredible how your talk has evolved. And I mentioned earlier that you're only working for the company for 7 months. What has been the most fun thing you've done in those 7 months yourself?
Yeah, actually, I was an intern at the company prior to working full-time, which was also a really incredible experience. But yeah, I think just seeing the our customers being excited about the products that we're creating, I think that's the best part of robotics, is being able to create something that customers love and actually find extremely useful. So.
Right. Well, thanks again for coming to WiDS and for telling us about your work in drones. Right, wonderful. All right. Now we have 4 more Tech Vision talks left and the closing address. So there's still lots of wonderful talks and lots of treats. And the next one is going to be wonderful also. Nandy Leslie from Raytheon Technologies will be addressing us. So Nandy, welcome to the stage and thanks for coming to WiDS.
Thank you so much for having me. It's such a pleasure to be here amongst you women and data scientists. I'm just thrilled to be here. I'm an applied mathematician by training. I have 22 years of experience in applied mathematics. And today I'm going to talk with you about the intersection of machine learning and cybersecurity. So for cybersecurity, there is a wealth of data. And there are millions of packets on any one network per minute going across the network representing communications. And largely, those networks are protected by signature-based approaches. And we know that those are inadequate. That is that signatures are largely representative of known attacks, previously identified attacks. And that is not what necessarily one needs in order to be able to detect anomalous behavior or the so-called zero-day attack. And today, one of the key problems that our customers are interested in is understanding the vulnerabilities, the need for resilience and robustness in a variety of different types of networks. Networks such as in-vehicle networks that may be in a variety of different domains, whether that be space, air, undersea environments, surface sea environments, ground vehicles, and of course, enterprise IP networks, as well as mobile networks, mobile ad hoc networks. And so there are this variety of networks with different protocols. And what we want to understand is the vulnerability to cyber attacks. We want to also be able to develop some level of autonomy in order to predict the characteristics of those attacks, to detect them, monitor the networks and detect those attacks, and respond to them with active responses. And so there's a strong need for mathematical and computational approaches which can do just that. And so one key research question is, are there accurate computational approaches that can maintain network robustness and resilience, that can address our security needs? And so, I mentioned initially that signature-based approaches are inadequate because they're based on previously known attacks. And so what we need is anomaly-based approaches, anomaly-based models, though they face their own issues. That is, they typically have high false alarm rates or high false positive rates, whereas, of course, signature-based approaches have high false negative rates. So we need to assess and address that issue of error with mathematical approaches, computational approaches that can reduce such error. And supervised learning presents a well-studied set of algorithms and models that can address this problem. And so one can analyze unlabeled data. That is the type of attack, the zero-day attack, which one hasn't, it's a unknown unknown, right? We want to be able to assess that. We want to be able to make predictions based on the clustering that one can derive from these unsupervised learning approaches. So what we see in this animation here is a simple application of online k-means approach, a clustering approach, where the blue nodes are representative of benign traffic. The red nodes are representative of a botnet of a variety of characteristics. And the links between those nodes are when any two IP addresses or devices that are networked are communicating. And so this model is running online to be able to detect in at near real time an attack. One needs to not only just examine these unsupervised learning approaches, but also understand something about the shape of the data prior to going in with any one of these approaches. And so there are these emerging approaches in topological data analysis where one can examine the persistent homological structure of persistence diagrams. And this is a depiction of a CIC IDS 2017 botnet data set, Canadian data set, and the persistent diagrams for both the malicious and benign data. And what one can see by examining the homological structure here is that there are through the filtration of via torus RIPS complex, you can see that there are connected components that persist in the data. One can also, more generally speaking, discern whether there are holes in the data, whether there are voids in higher dimensions, and be able to take that topological information and include it into the feature space. So just at a high level, the contributions technically that I'll go into more detail in the subsequent slides are a novel hierarchical agglomerative clustering approach that takes what we've known in statistical learning, unsupervised learning, about agglomerative clustering, and then combine that with an ensemble learning approach in order to detect botnet traffic and then be able to apply that algorithmic approach, that combined ensemble learning and agglomerative clustering approaches in order to first discern whether there is an attack ongoing in CAN bus, that is controller access network bus traffic in an in-vehicle network, as well as IP network traffics of a variety of types. And then subsequently evaluate the prediction performance of said algorithms. Some related work in this area, specifically to applying anomaly-based intrusion detection methods to CAN bus traffic and IP traffic. So one of the seminal papers is by Dorothy Denning in 1987, where she looked at anomaly detection for intrusion detection. And then there have been many works, and I can't cover them in this short time, but more specifically related to CAN bus and applying machine learning, there are these ones here listed. A survey by Al-Jarrah, and then Lockman has a deep autoencoder anomaly detection model for CAN bus. And then there have been additional works. There's an additional one by Young and his co-authors on the fast Fourier transform and its application to CAN. For this ensemble hierarchical agglomerative clustering method, EHAC, it's an, as mentioned, a combination of ensemble and unsupervised learning, where we talked about pre-processing and cleaning data. That's one of the initial steps. So, in machine learning, we have a variety of techniques for dealing with missing data. And in cybersecurity data, it's often that you have missing data. And so for that instance, one could use multiple, and I did use multiple imputation by chained equations or mice. And so then you have now a complete data set, no missing data, but then it's imbalanced. Largely you have a sea of benign data, and then a small fraction of that data is your attack data or cyber attack data. And so it's imbalanced. And how does one deal with that? There are a number of methods, but one in particular that I've used is the synthetic minority oversampling technique, SMOTE. And then, so now you've cleaned the data, there's no missing data, you've balanced the data, and then now you have to do some feature standardization methods, even prior to that, you must encode the data. You have mixed data, there are some categorical features like the prototype being used. There are a number of text-based data in the feature space, and then there's also numerical data. So you have to use a variety or select from a variety of encoding methods. Here, in this work, I just used one-hot encoding. And then, okay, now your data is cleaned and it's pre-processed. So this is where you apply agglomerative clustering methods. There are a number of them. There are graphical algorithms, that is the single linkage, complete linkage, group average linkage, and there are others, and one can innovate additional ones. And then there are geometric methods. There's Ward's method, and then there are several others. Here, and for each one of those linkage functions, there are metrics that one can use, right? So there is the LP norm or distance, and then there are cosine distances. There are a number of metrics. Here I'm using L1, L2, or Euclidean, and cosine for each of them. And then a committee method to vote across the methods. So single linkage is known as the nearest neighbor algorithm. It's basically, and for each of the agglomerative clustering methods are bottom up. You're starting with each element in your feature space, each observation is a cluster, and then you iteratively build based on your distances or dissimilarity within cluster dissimilarity. And so this one is a nearest neighbor where you're looking at the minimum distance between two non-overlapping, non-empty clusters in order to decide whether to merge. There's the complete linkage, where one is using a different within cluster dissimilarity. Group average, even a different within cluster or intergroup dissimilarity. Ward's method. This one is known as minimum variance, where you're attempting to, the objective is to minimize the error of the sum of squares. And so here, now we have the data. This is just an example of, one of a million of network sessions, mixed data, IP addresses, and so on. And here we have labels in this specific data set from Tech University, CTU 13, but in the analysis, we don't use those data, those labels until the prediction performance. Here we see EHAC has superior performance to a much simpler algorithm, k-means, for a variety of different types of data. We have the CAN bus data where you can tell that the CAN bus attack is very simple and that there's perfect detection both with a simple k-means application and EHAC. And then also there's the CICDS 2017 data set where we're looking at F1 score, the harmonic mean of precision and recall, and mutual information. And then there are two different botnet scenarios from the Tech University or CTU 13 data set. One is a DDoS and the other is a peer-to-peer attack, and both with better than random performance and better than general k-means. In conclusion, It has a wealth of data in cybersecurity that we can apply a variety of methods, whether from analyzing the topological data structure through the persistent homology and the persistence diagrams to get the shape of the data. One can also examine a variety of unsupervised learning approaches and combine said topological methods to improve performance. And then we can consider the accuracy of the data clustering and be able to make predictions when in the absence of labels and improve on the detection of any one algorithm through ensemble learning. Thank you.
Such a fascinating topic, anomaly detection and cybersecurity, and thanks for telling us about that. We have our next speaker coming up, Chiara Sabati, and she's going to give us a little bit more mathematics and statistics today. Chiara, thanks for joining us.
Thank you. It's great to be here with all of you. The energy in the room is really quite something. So a strong relationship between science and society is very important, as the pandemic has reminded us all very forcefully. And in order to achieve that, we need to work on multiple fronts. For example, today, in numerous occasions, we have pointed out the importance of having representative data or the importance of using algorithms that don't enforce discrimination or disparities. What I want to focus with you today is one other aspect, that is communication. We cannot trust each other if we cannot understand each other. So what I would like to do is to share some principles that I have found useful in my career as a data scientist to facilitate effective communication of our findings to the public. One, we should pay attention to the question and resist the temptation to use whatever data science method we have that is handy. If there is a discrepancy between the results that we get and the question that was actually asked, there's going to be the communication difficulties. Another thing that it's important to remind ourselves is that we have to be clear. But clarity does not mean oversimplifying things. Whenever we reduce the complexity, we ignore it, we run into the dangers of unintended consequences. Words do matter. So we have to be careful not to assign names to things that do not exist, that are not important. They are just a byproduct of our analysis, not for public consumption. And finally, even if we hack all the time in all the tasks that we try to do in life, when we are professional, we have to put on our hats of data scientists and really be scientists, and therefore communicate clearly and in an intelligible manner what are the limitations of our analysis and the uncertainties. So to illustrate why I came to these principles and how they have helped me, I want to share with you some vignettes from my day job, which is analyzing genetic data. So this picture from Rosalind Franklin helped us understand that DNA is a long polymer formed of 4 bases, and we share most of the bases. But there are some positions in which we have variation, and this variation impacts the way we look, how tall we are, and the chances we have to develop some diseases. So people in my area collect information on millions of these positions in the genomes when we have some variation, in tens of thousands, hundreds of thousands of individuals on whom we also have phenotypic informations. And we try to understand which position in the genome carry information for this phenotype. We do this for 2 reasons. One, if we point to positions in the genome, it's equivalent to pointing to biological pathway. This will increase our understanding. It will give us some drug targets. Also, we want to use this information for counseling and for developing personalized risk scores for individuals. Now, this trove of data is analyzed in this way that I'm going to try to describe to you in a fairly cartoonish aspect. So I'm not going to account for you of the rich literature in genome-wide association studies, but what I'm going to describe is a well-established and very popular pathway. So even if we have collected data on millions of SNPs, we analyze the association between the phenotype and these genetic variants one at a time with very simple linear models. And we say that we have a discovery whenever we discover that one of these genetic variants is associated to the phenotype. We can reject the hypothesis of independence. Controlling, why do we do this? We do this because it's easy. Because doing these bivariate models, it's easy to handle missing data, and these bivariate models produce for us p-values which we think are important, and indeed they are, to ensure reproducibility of our findings. But there are some challenges that come with this simplified analysis, especially when we try to put the results together for prediction. So the picture that you see here, it's one that is often used to convey the results of the analysis. Each dot here represents a different genetic variant. On the x-axis, you have positions along the genome with the color code indicating the changes of chromosomes. And on the y-axis, you have strength of association measured in terms of minus log p-values. You can see that there's a bunch of green dots, and those correspond to those SNPs for which we have rejected the hypothesis of independence from the phenotypes. But also all the SNPs that are very correlated to them, indistinguishable. And you can see there's a lot of these green points, and the signal that we have is spread along all of these green points, and there is some difficulty in interpretations here. For example, I cannot even tell how many independent locations in the genome have something to do with schizophrenia, which is the trait analyzed in the previous slides. We cannot even say what portion of the genome overall is important for schizophrenia. It's very hard to do genetic counseling because at the level of the population, it's fine to see, oh, there is an association between this SNP and schizophrenia. But unless I know exactly which allele is truly important, this is not very useful for an individual to know. And this working with association by, guilty by association makes it very difficult to transport our finding across different human populations because different human populations have different distribution for all of these genetic variants. We have learned very little about disease mechanism with this bivariate method of analysis. And we are really not in a very good place for doing prediction. And in fact, the prediction methods that have been developed starting from this approach have shown to be very not robust across human populations. So what can we do? You can see that these are all difficulties that emerge from the fact that there is a mismatch between really the question that we try to answer and the tool we use. I have been fortunate to be associated with a number of people that have tried to improve a little bit the situation, inspired by the principle I try to share. And one first step is try to test hypotheses that are more to the point. So for example, instead of looking simply for variants that are associated with the disease, we go ahead and look for variants that have information to tell us about the disease on top of every other variant in the genome. If we make such discoveries, these discoveries are by definition not repetitive because every single one that I can point us has some additional information. They are good input for prediction algorithm because they have something to tell me. And they do bring us closer to understanding the biological mechanism behind these traits. So this is how our result might be presented. And the very top panel you see, it's an echo of the same type of displays that I have shown you before. And the middle panel would represent how our analysis can be visualized. Again, on the x-axis, you have positions in the genome. On the y-axis, you don't have strength of association, but precision of findings. So at the very bottom, you have the more coarse finding, the ones with lower resolution. And as you move upward towards the panel, and it's probably easier if you look at the very bottom that it's a zoom-up version of one segment, as we move up, we increase the resolution. So you can see that instead of dots, I represent my finding here with boxes, and only the boxes that are significant, that correspond to discovery, are represented. The width of the box, the bases of the box represent the genomic area where I can say that there is a variant that influences the phenotype in addition to what happens in the rest of the genome. So every box, it's an independent discovery, something that has to tell me additional information on the trait. And as we move up on these building blocks, you can see that the size of the boxes diminishes, and that corresponds to increased resolution. Can I pinpoint more precisely where these variants are? And in some cases I can, in some cases I cannot. Another aspect that it's true about genetic data and that I have tried to hint about is that we see a variation of distribution of these genetic variants across human populations. So if we work in the domain of guilty by association, what happens is that one variant might be proxy for the causal variable in one population, might not be in a next population. So what I have to do is try to focus on variants that are good proxies across different populations. This it's dictated by reasons of fairness, but it's also useful from an understanding viewpoint. If I detect an association that it's invariant across environment, across population, it's much more likely that this association is actually causal, that it's not simply picking up the effect of something else going on, but it's pointing directly to the effect. And so we have devised methods to capitalize on data in multiple populations when these are available and find specifically these associations that are consistent. So if we go back to our picture of building blocks, the top image represents the same that I have shown you before. And as we move down the panel, you can see how our discoveries can be refined and diminish in number when we insist that they are found not just in one population, but two, this would be the yellow graph, 3, this would be the blue graph, or 4, the green graph. Finally, I want to bring attention to the aspect of conveying uncertainty. That's really what we need to do as scientists. And nowadays, whenever we do prediction, we use very complicated algorithms, and it's very difficult to actually give a nice description of their level of uncertainty. The way to do it is certainly to construct predicted intervals. So not just return to our user a prediction, but say this is actually the range within which, with 90% probability, the actual value that you'll get to observe will be. Now, constructing that range, it's difficult for the type of sophisticated algorithms that we use nowadays. We cannot fall back on parametric models. But there are solutions that are available to us, and the person represented here is Vladimir Vovk, who, unlike the other that appear on my slides, is not a collaborator of mine, but I want to acknowledge his work because he introduced the field of conformal inference, which really allows us to do this uncertainty quantification in a way that it's clear for the user and very powerful because it doesn't require any specific assumption. And Vladimir Vovk is also from Ukraine, who is having a hard time right now, so Slava Ukraina for today. Now, what we have worked on is an enlargement of these methods that focus on the problem of providing good prediction intervals that are valid for every group of the population. If you are not intentional about this, what might happen is that you create a prediction interval that is valid for the majority, but it actually does not cover the outcome for minority populations. And this might lead actually to wrong information and might lead users to make decisions that are not what they would intend to make. So we have worked on this one, and we intend to apply this method also for genetic prediction. So I hope these examples illustrate a little bit more concretely the meaning besides this principle, or what these principles meant for me and how I came to find them useful. So reiterating them once again, we need to develop methods, if they are not available yet, that really answer the questions of interest. We don't want to have a discovery that is not really what our user is interested in, because the user is going to reinterpret our findings, and then maybe all of those reproducibility guarantees or statistical properties that we thought were associated with our discoveries fail, because in fact, they are using it differently. The polygenic risk scores, that are the way that we use to combine informations on the genome, are really nowadays not very ready for prime time. They are useful to convey for scientists, for ourselves, a sense of what the information is that we have from this individual about the disease, but they're not very good for prediction. If we construct the prediction intervals, they're going to be very huge. So let's not emphasize unduly their role. And then let's try to be scientists. I have 33 more seconds, the clock tells me, so I'm going to put here this final slide, inviting you to yet another conference in the data science space that we will have here in just about a month. It will not be so wonderfully organized, and it will not exist on the online platform in such an interactive fashion, but we will be here and we will be streaming what's happening. We will be very happy to see you all here.
Thank you so much. And thank you for including that information about the upcoming Stanford Data Science Conference. Very worthwhile coming to. We're now going to spend a few minutes looking at some of the work done by our educational outreach team.
We all know that lack of equity and opportunity for women and people of color has been a problem for a long time. Challenges leading to this inequity actually begin during the school-age years, even as early as elementary school. Though interest in math and science coursework is approximately equal at the start of middle school, larger gender gaps develop later in middle school and grow throughout high school. We at WiDS Education Outreach believe that a focus on real-life problems, having students work together, and presenting them with inspiring role models will help close the gender gap and increase opportunities for students who have historically been sidelined in STEM fields, including data science.
We started the WiDS Education Outreach to inspire secondary school girls to take relevant courses and consider careers in the future related to data science, artificial intelligence, or related fields. And we want to communicate to all students that there are already many women doing important technical work in the field and the importance of diversity overall in data science.
This year, we launched a pilot program called Data Days in collaboration with Data to the People and the New Haven Public Schools.
The inaugural Data Days was a 2-day event hosted at King Robinson Middle School in New Haven, Connecticut. The event featured panels, keynote speakers, and hands-on data workshops, creating an inviting space for over 50 young girls to learn about and explore data science, both as a career and as a generally widely useful tool set. We also had 16 amazing data science volunteers joining us as group mentors for the event.
Our students had the opportunity to hear directly from women in the field, followed by small group workshops where mentors guided students through exercises with actual data sets. Our students were so engaged during these activities, and many have expressed their interest in joining the data science field. So to speak to experts in the field from Spotify and many of the other companies and understand how data influences decisions and day-to-day decisions that people make is exciting.
And we have another exciting program happening now in Hyderabad, India, in collaboration with WeHub and MathWorks.
The challenge
or the problem that actually we are trying to tackle about too few women in tech or entrepreneurship starts in the schools. We started this WiDS and MathWorks collaboration that we are running at WeHub.
The Data Science for Students program implemented is an amazing program exclusively designed to bring outcomes, and also create a golden model which can be futuristically implemented across India.
The first thing we did is made these teachers of these schools that we are working with our ambassadors. So we made sure that we worked with the teachers to be able to understand the curriculum and also indigenize it. We chose 6 schools from across India with 78 children.
The goal of this course was to introduce students to problem-solving techniques using data. We have tailored this curriculum to suit India's challenges, and together with WeHub, we have made it scalable so that it can be adopted by institutions in future. We've chosen topics that correlate with UN Sustainable Development Goals and those that are customized to solve challenges in the Indian setting.
Our student advisory team has been working hard to create new resources, such as CoLab notebooks, to add to our implementation guide.
I'm on the WiDS student advisory team currently. I've been working with WiDS since I was a senior in high school, so that's about 3 years. Currently, for the student advisory team, I run the social media account. Basically, I create and post different graphics and designs that talk about WiDS events, our team members, women in STEM, and like just data science in general. The handle is WiDS, W-I-D-S .student edition, so you should check it out for more information.
We're excited to announce the launch of a new Data Days program at San Francisco Girls School in April. We're really looking forward to seeing where we go next.
Work by the educational outreach team. And Carolyn and Karen and Elena are here today as well. So maybe at 5 o'clock, and it's coming up soon, you can meet them and talk to them about this at reception. How are you doing? Yeah, 40 more minutes. So our next speaker is Tori Lee from Whoop. And I have to show you something. This is my Whoop. This is my Garmin, and they're in competition. I'm going to believe the one that tells me that I burned more calories today. Tori, please join us.
Thanks, Margot, for the introduction. So I work at Whoop, where we make wearable devices, like the one you can see in the picture here and the one that Margot just showed. And wearables have become pretty popular over the last few years. Who in here, by show of hand, has a wearable device? Awesome. Is anyone besides Margot wearing Whoop? All right. So if you don't have a wearable device, you might not realize that you can count a lot more than just steps these days. And it turns out that wearables can be pretty useful for health tracking. There's been a lot of research around digital health tools and specifically wearables, so it's a really exciting field right now. And one of the things I love most about working at Whoop is its commitment to research. And I'm really excited to share with you some of that research today. I'm also really excited to share with you a story about my dad and how that research impacted him when he was sick and seeking treatment. So I want to begin by having you imagine that you're going to a visit with your doctor. You may have a few things in mind that you want to share with them, but for the most part, information will flow in one direction. They'll take measurements, labs, imaging, diagnostics, they'll interpret the results, and they'll make recommendations to you on how to improve your health. And this makes a lot of sense. They're the expert in this situation. But there's one big piece of information that they need from you, and that's information about your life. You are the expert on your life. And yet you have little tools and little data to draw upon here. It can be challenging to estimate how many hours of sleep you get each night or how well you're sleeping. It's challenging to estimate how active you are, if you're getting enough exercise, or what symptoms you experience. And that's where I think digital health tools, and specifically wearables, can have a really big impact. So why wearables? There's a few reasons that make these a really apt solution for this problem. For one, they're relatively easy to use. You can set them up at home, they're not invasive, and they're pretty comfortable and discreet, so you can wear them for an extended period of time. They also measure really relevant metrics, like sleep and exercise, two components that are very integral to a lot of chronic care management plans. And finally, perhaps most importantly, is that they collect data every single day. This means that they can establish personal baselines and know when a metric deviates from this personal baseline, even if it still falls within some broader normal range. So what's possible with wearables? Like I said, you can do a lot more than steps. And so here's by no means an exhaustive list of some of the sensors that you'll find in a wearable: an LED, accelerometer, gyroscope. With a little data science and signal processing, you can get to metrics like heart rate variability, respiratory rate. And if you sprinkle in a little bit more data science, you can get to insights like sleep and exercise, sedentary time, illness. Let's walk through an example. Let's say you have a wearable with an LED, accelerometer, and a GPS, and you get to metrics like heart rate and motion. And from there, you can tell your user something about exercise. So here's a screenshot from the mobile application that shows it's a run that was automatically detected, and it shows me where my heart rate was during the run, what heart rate zones I was in, how many calories I've burned. If we go to another example, let's say you have an LED and an accelerometer. You can get heart rate variability, and motion. And from there, you can tell your user things about their sleep. So here's another screenshot where my device has detected when I've gone to bed and when I've woken up. And it shows me that on the weekend, I tend to sleep in a little bit more, but I'm pretty consistent with my wake-up time on the weekdays. So this path is the main path that I want to focus on for the rest of this talk. It's from LED to respiratory rate, and from respiratory rate to illness. Given the global pandemic, a lot of research has been poured into how wearable data changes when someone gets sick, and specifically when someone contracts COVID-19. Here's some research that we've done at WHOOP with our partners at Central Queensland University, and we looked at changes in respiratory rate when somebody had a COVID-19 infection. So how does this all work? I want to break this down. So how do we go from an LED, which you can think of as just a little light, to respiratory rate? It's this process called photoplasmography. It sounds really complicated, but we'll break it down in this talk. From respiratory rate, which is the number of breaths that you take every minute, turns out if you measure that at night while someone's sleeping, night over night, there's not a whole lot of change to the metric. Except we've seen that in some illness, particularly respiratory illnesses, for some users, not for everyone, there's a substantial increase from the personal baseline. And you can tell that someone might be getting sick. So how does photoplasmography work? Let's break this down. An LED you can think of as a flashlight, and it shines light against a surface. A photoreceptor you can think of as a camera. It measures what gets reflected back. And you can imagine if you change the density of the surface, if you change the amount of light that's being absorbed, it's going to change the resulting optical signal. So let's apply this to a wearable. The LED is sitting on the surface of someone's skin. It shines light against the skin. Right underneath the skin are capillaries. And as a pulse travels from your heart down to your fingertips, those capillaries momentarily expand. And so we can see that the signal is traced out here on the right. And as the pulse moves underneath the wearable, we reach a peak in the signal. And another pulse comes through, and we reach another peak. And we get to this PPG signal, photoplasmography signal, where each of the peaks correspond to a heartbeat. Of course, we can identify those peaks with signal processing techniques like peak finding algorithms or frequency transformations. And we can also measure the amount of time that elapses between each of those beats. You might not realize this, but when your heart is beating 60 beats per minute, there's not exactly 1 second between each of the heartbeats. The first two might be separated by 1.1 seconds, the next two by 0.8 seconds. There's a bit of variation to the signal. So if we zoom out a little bit and do this on a larger sample, we've done the exact same process. We've identified the peaks and measured the amount of time between each of those peaks. And we'll call these the beat-to-beat intervals. We can create a whole new time series with that data. That's shown here on the bottom. There's variation in the signal, like I mentioned before, and you might even notice that this variation looks cyclic. There's a rise and fall. This actually corresponds to the respiratory cycle. It's this phenomenon called respiratory sinus arrhythmia. The idea is when you inhale and oxygen-rich air fills your lungs, your heart rate speeds up. Those beat-to-beat intervals get shorter. And as you exhale, oxygen-depleted air is leaving your lungs, your heart rate slows down. Those beat-to-beat intervals get longer. So if we go back to our signal, we can map that there, and we can imagine if we do this for a long enough period of time, we can get to respiratory rate, the number of breaths someone takes in a minute. So again, why do we care about respiratory rate? Well, as I mentioned earlier, if you measure it at night while someone's sleeping, there tends not to be a whole lot of change in the metric, night over night. Except we've seen that for some illnesses, particularly respiratory illnesses like COVID, for some individuals, not for everyone, there's this dramatic spike in respiratory rate. So you'll see here on the left, there's several thousand Whoop users who've been aggregated, and they've all reported a positive COVID test at day 0. And we can see relative to day 0, there's this large spike, sometimes even happening before day 0. On the right here is a screenshot from the app for an individual's data, and you can see this dramatic rise in respiratory rate. So I want to change context now and talk about a case study. Of course, this is an N of 1 study, so keep that in mind, but it's with my dad. And he heard about all the research we were doing, and he was really excited, and so I got him a Whoop, and he put it on, and a few weeks later, he saw this dramatic rise in respiratory rate. So of course, I told him, you should go get a COVID test, and he did, but it came back negative. A week later, his respiratory rate was still elevated. So I want to walk you through what became the 6-month journey for my dad with his health, and we'll frame it in terms of his respiratory rate on Whoop. You'll see here in the gray is his nightly respiratory rate, and plotted on top of that in blue is a 3-week rolling mean. So let's walk through some of the notable events here. In July of 2020, he begins wearing the device. By August, his respiratory rate has increased by more than 3 breaths per minute, a really big increase for an otherwise stable metric. During this time, he's gotten many negative COVID tests. Also during this time, he started to experience symptoms like shortness of breath, difficulty exercising. And so he goes to his doctor and he asks questions, and the doctor gives him a pulmonary function test. It comes back within range. My dad's confused. He can feel these symptoms, and he can see in his Whoop data that something's wrong. And so he goes back. He asks for more tests. He asks more questions. In September, after a CT scan, he was diagnosed with a rare form of viral pneumonia, and in the following weeks, he received treatment, steroids to help the inflammation in his lungs. And you can see here that his respiratory rate returned to normal from several months before. Also, his symptoms dissipated in this time period. So what are the key takeaways here? Of course, again, this is an N of 1 study, but I think there are some meaningful insights. For one, respiratory rate was being measured every day, not just when he was going to the office, for the doctor's office, or not just when he was feeling ill. And so this allowed him to establish this personal baseline. In fact, his respiratory rate never deviated from the clinical normal range of 12 to 20 breaths per minute. The data also gave him confidence that his symptoms were real. When the doctor told him that the pulmonary function test had come back normal, I think a lot of people would have dismissed their symptoms. He also could see the metrics return to baseline during treatment, which assured him that they were working, along with his symptoms were dissipating. Finally, I want to stress that there's still a need for the doctor's perspective. Wearables won't replace doctors. The doctor is needed to interpret the data, to make a diagnosis, and recommend a treatment. So if we take a step back, let's revisit why wearables. Again, we measure relevant metrics like sleep and exercise, and as we've seen here, metrics related to respiratory illness. It also doesn't require a whole lot of input from the user. You can put it on your wrist and forget about it. But if you do want to engage, the data is hyper-personalized. There are communities that you can join and create on the mobile app, and there's plenty of content to help you interpret the data. Of course, challenges remain. These are just a few, but some of the big ones. Validation. There are so many devices out there on the market. How is a consumer to know which ones work well? The volume of data. We're collecting thousands of data points on every individual, every single day. We need to make sure we're only surfacing meaningful insights. And finally, and this is the biggest piece, is access. These devices require a high degree of digital or technological literacy. They also require access to a mobile device or the internet. And finally, if you have all of those things, they can be expensive. I'd love to imagine a world in which health insurance covers wearables, and so you can buy one and get it reimbursed. So let's revisit this scenario with your doctor. But this time, you've been wearing a wearable device. You have sleep data, you have exercise data, perhaps you're also logging symptom data. Maybe you've started to make connections between these different data sources. Perhaps you've realized that on days where you get less sleep, you're more likely to have a headache. Or on days where you exercise, your mood tends to be more stable. All of this data can provide opportunities to have conversations with your doctor to better guide your treatment. So I want to wrap up by saying, I hope I've given you a glimpse as to what's possible with wearable devices, and that this is a really exciting space for data science. I hope I've also demonstrated that these little devices are in a position to have a really big impact on how people manage their health. If you remember nothing else from this talk, I hope you remember my dad's story and the huge impact that wearable data had on his life. Thank you.
Thank you so much, Tori. And no, you're still studying.
I am, yes.
So
Public health.
Public health.
Yep.
Now, how did you, I have to ask, and we have a little bit of time, how did you get to work with WHOOP?
Yeah, I was an athlete in college, and WHOOP's original sort of position was to help elite athletes from overtraining, prevent them from overtraining, prevent them from getting injuries. And so that was my initial draw to WHOOP. But then we saw that there was so much more possible with health, and that sort of brought me into the public health program and really interested in this topic.
Yeah. Well, thanks so much for a wonderful talk, and good luck with your studies.
Thank you.
Yeah, and good luck with your dad. It is so nice when people also share a little bit of their personal stories. I've got a question for you. Do you know that the United States has a chief data scientist? Well, now you know, right? Because she is on next. Our next speaker is the US Chief of Data. Her name is Denise Ross. She's an old friend of WiDS. She was with us several years ago, and I'm so glad that we were very nice to her because now she's our Chief Data Scientist. Denise, I'm so happy you could come back from Washington, D.C. to join us here today with WiDS. Thank you so much.
Thank you, Margot. It is an honor to be back at the Women in Data Science Conference. 2 years ago, just before the world closed down due to the pandemic, I was on the career panel. I had closed my remarks, encouraging you all to consider public service, but I had no idea that I'd be jumping back in myself. So I join you today as the Chief Data Scientist of the United States. I'm the second person to hold this title and the first woman. Today, I wanted to talk about how essential data science is for an equitable recovery from the pandemic and economic crisis, as well as resilience to future shocks and stressors like climate change. We need robust data flows for a healthy democracy and a thriving, equitable society. I especially want to focus on the intersection between data and the rollout of the bipartisan infrastructure law, with a few concrete ways that those of you here in the US can help. When the sun is shining and the sky is blue, like it is today here at Stanford, it's easy to become complacent with the data we already have. But when a crisis hits, that's when you really need more from your data. You need more frequent, more granular, more detail in your data. In order to address the compounding crises of the pandemic, climate-fueled disasters, and the chronic stressors of inequality and racism, we need data that is timely, broken down by characteristics such as race, gender, sexual orientation, disability, and veteran status, for small geographic areas, and tracked over time. We saw brittle data supply chains earlier in the pandemic, with rural communities that had limited internet access having trouble reporting on vaccines administered, which slowed down their receiving of the second batch of doses from the federal government. We also saw where paper processes that might have worked fine during normal times became untenable. For example, I remember seeing a photo of piles of paper death certificates waiting for data entry. One pile for each month. March 2020, April 2020, May 2020. all piled on the desk, increasing in size. Each month of the pandemic had higher and higher piles, but those data weren't digitized and therefore were not informing policy or action in a timely way. But these challenges we are seeing are not new. 15 years ago, I came up to Washington, D.C. in a secondhand suit, still evacuated from New Orleans due to Hurricane Katrina. I came to talk with members of Congress about how New Orleans needed data to chart a path toward an equitable recovery from the storm. We didn't have enough intel to know where to stand up temporary clinics, which parks to rehabilitate first, and with 80% of the child care centers shuttered, where should we be prioritizing philanthropic dollars in that sector? We reviewed the data on electricity hookups, water usage, and traffic patterns. We even looked at images from outer space showing nighttime lights. It turned out that the best way to see how many people were back in New Orleans and where they were living was to get monthly updates from a direct mail marketing company. You know how it is, junk mail always finds you. A company that rents out those mailing lists had the best data on occupied households. Fortunately for us, somebody in that company had the foresight to archive their New Orleans mailing list for July 2005, the month before the storm. They ended up donating their company's data to the nonprofit data intermediary that I co-led. And because they gave us the pre-Katrina baseline, we could track what percentage of households had returned and keep it updated every month. That data was a game changer for the recovery. Neighborhood associations like the Lower Ninth Ward, which was one of the hardest hit parts of town, no longer had to use their spring break volunteers to collect data. They could put them to work directly fixing houses. Even the police department used the junk mail data as the denominator for their crime rates for a spell. As we look at the future of data and how we will use data to better serve the American people, we're going to need to get creative. Private sector data, like we used 15 years ago in New Orleans, will certainly be a part of the equation. So will more robust state, local, tribal, and territorial data. The bipartisan infrastructure law is creating opportunities to responsibly collect more data to help our society understand how and whether our systems are serving Americans equitably. It's easy to imagine incorporating data capabilities into these investments, like GPS and internet-enabled electric buses that can increase the predictability of the public transit system for riders and also their productivity while they're riding the bus. Sensors on capped oil wells and to detect leaks, and participatory science to monitor water quality. As these historic investments roll out across America, one effort to watch is the Equitable Data Working Group. It was formed from President Biden's executive order on advancing racial equity. This group is tasked with identifying the inadequacies in our existing federal data collection infrastructure and laying out a strategy for improving data practices in the federal government. Across the federal government as we speak, agencies are looking for data gaps that stand in the way of assessing how equitable their policies, programs, and services are so that they can improve them. When I see what's happening at the federal level on data and equity right now, it reminds me of the incredible impact that President Obama's Open Government Directive had on me and other open data advocates when I was working at the local level a decade ago. When we saw the transformation that was happening at the federal level, we realized that we shouldn't have to beg our own local government for data on building permits or recovery investments. Publishing that data should just be a part of being a modern local government. So we pitched then candidate for mayor, Mitch Landrieu, on the idea, and as happens with these types of things, within a year I was inside City Hall working to release the data from the inside. When he took office in 2010, Mayor Landrieu committed to reducing the number of blighted, storm-damaged properties by 10,000. Data management was critical at every step of that process. Code enforcement officers collected inspection findings on sites throughout the city, And we had to shift that process from one that involved yellow pads of paper and envelopes full of photographs to a centralized electronic system that allowed for uploading the data in the field. We had to integrate timely, geographically accurate data from demolition crews, the courts, and state recovery offices. And there had to be easy ways for citizens to report problem properties or check on the status of their remediation. We knew that meeting our goal of 10,000 properties remediated was going to take the entire community. This was a problem bigger than government could fix alone. So we brought in a team from Code for America, the nonprofit, to help us organize all of the data we had about blighted properties into a single source of truth, a website where anyone could enter in an address and see where it was in the process of being fixed. I remember the first public meeting after we released this tool. City Council was holding a hearing on the blight problem, and it was standing room only. A woman walked up to the podium for her 3 minutes to speak, and she talked about the house next door, how it was threatening to fall over on top of her house, and it was home to all sorts of vermin and criminal activity. She gave the address and pulled out a piece of paper. It was a printout from our new website. As she spoke, the city's blight czar looked up the address on his iPad, and city council staffers pulled it all up on their laptops. For the first time since the storm, everyone had access to the same information at the same time. Instead of arguing about what the facts were, the conversation focused on what the solutions should be. It was still a hard conversation, but it was much more productive, and thanks to that common base of information, we were able to blow past that goal of 10,000 properties ahead of schedule. That digital transformation that occurred in the city of New Orleans a decade ago, that type of transformation is going to need to occur in communities all across the nation in order to meet the challenges we are facing, such as recovery from the pandemic and the economic crisis, preparing for and heading off the worst impacts of climate change, and ensuring equitable access to resources and opportunities like those that are found in the infrastructure law. These infrastructure projects will require state, local, tribal, and territorial governments to have the talent and the resources to design these local projects in collaboration with community stakeholders and then deliver. Data capacity will be a key enabler, just as it was in New Orleans working on the blight problem. That means we need people like you at the table. And the first step for communities is awareness about these programs. The law is vast. There's $550 billion in new funding over 5 years, with 375 distinct programs, from high-speed internet to creating reliable public transit to replacing lead pipes. These investments are being rolled out with the priorities of equitable delivery, creating good jobs, using materials made in America, making sure what we build will stand up to a changing climate, and delivering these investments where they are most needed. A few weeks ago, we at the White House released a guidebook at build.gov, that's BUILD.gov, that covers each of these programs, along with a spreadsheet for easy sorting. This is just the first version, and we'll be updating it with new information and additional data as it becomes available. For this crowd, I wanted to talk a little bit more about that spreadsheet of programs. We know that the highest capacity jurisdictions already have consultants who have been combing through the law, identifying programs they should get ready for, and then apply for them. Those communities that need these investments the most, though, they don't necessarily have high-paid consultants. There's room for what you might call a translation layer to curate the programs that are most relevant for different types of communities. Which programs bundle together in a way where the sum is greater than the parts, like laying fiber while you're expanding the highways, or putting solar farms on remediated abandoned mines. A small town that desperately needs a bridge or high-speed internet to keep their residents connected will often have a part-time mayor who is not single-handedly going to have the time or expertise to identify which programs to apply for, and then make the case in a grant. So that's where all of you come in. If you work for a university, think about how you can scrub in. Could your computer science department help cities predict where to dig for the lead pipes? Or help locate your state's most dangerous abandoned mines? Can you help your community apply the most current climate science to ensuring that any designs for bridges and stormwater management will stand up to future climate conditions? If you work for a nonprofit, how might you use the spreadsheet at build.gov to help your constituents to find the programs that their communities most need? If you work for a company, think about what data you might be able to put responsibly towards solving a challenge in our society. Have the foresight of that person at the junk mail company who set aside the pre-Katrina mailing list. If you're a data scientist, and I use that term in the broadest sense possible, please consider joining us in federal government. If you're early career, check out the US Digital Corps as a way to serve your country. If you're further along, consider a tour of duty in the US Digital Service, 18F, or as a Presidential Innovation Fellow. And keep an eye out for good government jobs. You can find most of them at usajobs.gov. State and local governments will also be hiring data and tech people to support these infrastructure projects. And I do want to warn you that those job titles are sometimes boring and they don't reflect how exciting the work is. And if you're already working in state or local government and want to talk about infrastructure data, please grab me this evening, or if you're in person, or reach out to me on Twitter or LinkedIn. Thank you.
Where there's your call to action. Thanks so much, Denise. So it's hard to believe, but it's 10 minutes till closing. And when we were thinking about who to ask to give a closing address, we thought of Rukmini Iyer. She is from Microsoft. She has been a WiDS contributor for many, many years, and we owe her much. And we're just so very grateful that she can be here today to take us to reception. Rukmini, you're between us and food. Yeah.
So I should start with, I should have taken an autograph from Denise when I was on that career panel with her. She is a celebrity. I mean, I'm so impressed. All of you are celebrities. And so if you're on panels together or you have given a keynote here, I think going forward, I'm just going to take an autograph just in case and keep it all together. Why am I doing the WiDS closing speech? I think, as Margot already pointed out, I've been associated with WiDS right from the beginning. I think except for the janitorial duties, I think I've been on the career panel, the mentoring panel, keynote, I've run a workshop, and the most rewarding of all is I've been part of the WiDS high school outreach program. And I'd say that's the one that probably had most of my passion. Oh, I hit the microphone. And I believe the high schoolers, we have two groups of high schoolers sitting out here. Are they still here? Yeah, they are. We have a lot of work to do to convince more such high schoolers and middle schoolers to come into the path that all of you have chosen to come into. And so why is WiDS so important to me? And I want to start with my own background. I came here in 1992, so I'm dating myself. I came here to do a PhD in AI. I was an electrical engineer. I had only taken one programming class. I hadn't even taken a random variable or a probability class. But I read a book on speech recognition, and I did a project on dynamic time warping. At the end of that project, I decided I'm going to do a PhD in this field. This is the most interesting field that I've seen. I had no idea what was required as a prerequisite to get into the field. Luckily for me, when I landed in Boston University, I landed in a lab that was run by a very, very strong woman scientist and engineer. And that one story, that one role model, was enough to convince me that I belonged.
that I belonged in this field, that I belonged at that table. Just imagine if all your stories get out, the 100,000 data scientists that WiDS has been able to reach out to. These stories are what creates that echo chamber, that inclusion chamber, where the high schoolers and the middle schoolers feel like when they look around, they see a lot of data scientists around, some in the government, some in the industry, some in academia. They're all looking at plots and graphs and looking at green and red bars. That's how it goes. You know, they don't have to have this doubt in their mind when they enter a physics class and only see 2 other girls in the class. Or when they get to college and they realize that they haven't done any computer science programming and they're far behind. They aren't. Like my story says, you know, I had very little programming experience, and I'm running a team that does engineering, ML, AI, game theory, auctions. I've learned everything on the job, on the way. So I think these stories are really, really critical that these stories be told. And I think that's what WiDS is creating. And this is why my first action item for all of you is participate. Participate in WiDS, participate in hiring, participate in learning groups, because your story needs to be told. You may think that your story just sounds simple or just like someone else's story, but it resonates. Even if it resonates with one other person, you're creating that path for them. I wanted to take a step out from WiDS to what's the next action item I want to give you, because this is a closing of a really, really fantastic day that we have had here today. And I want to leave you with, I do want you to be very ambitious about being a data scientist. So when you come in as a data scientist, you're given tools, you're given some Jupyter notebooks, you know your p-values, you know how A/B experimentation runs. And you can actually spend a lot of time just doing that. You can just spend a lot of time running experiments, diagnosing experiments, analyzing things, telling the stories behind those experiments. But I really want you to be a little bit more ambitious about not just the data that you have, but what you can do with that data. And I want to start first with the empathy for that data. And that sounds like an odd thing, but if you're a data scientist, you need to know, I think one of the speakers talked about the genealogy of the data. Where did that data come from? And remember that data is created. So if the data you're getting is not authentic, or it's not real, or it's biased, you can actually create, you can actually log unbiased data. And in fact, a lot of the machine learning scientists, this is the first thing they need to do. People get really excited about deep learning models and very large-scale language models, and they look at the hindsight data. But we know that that hindsight data was collected by some system in place. And if you're trying to build a new system, you need to actually randomize the decisions made by the old system. So that data, and having empathy for that data, is really critical. And figuring out where it came from and what you need to change so that you can make better decisions, that's really critical. The second thing is when people talk about data for good, they will, Denise is doing data for good. There's no getting away from it. People talk about healthcare. People talk about these areas where it's very clear that you can see data science is being applied for a good outcome. But many of us are working on products that are being used by thousands and thousands of people. And when it comes to data for good, these products also need to do good for not just the best users of the product, but for the tail users. Let's take online advertising. Definitely doesn't sound like a data for good. I work in online advertising. And in online advertising, I build really, really large-scale models and bidding agents and automated systems. And when I talk to my really large customers, it's easy for me to realize that these large customers have their own data science team. They're optimizing. They're doing creatives and keywords every day. And they have systems in place that do the best for them. But then I have this long tail of small advertisers who probably have no idea. They just enter a few keywords, they give us a budget, and then they're off and running. Now, can I bring the data science capabilities that I'm building, can I bring it to these small advertisers? That is actually data science for good. And in fact, we do it. We allow them to experiment. We use some of the largest language models that you've heard of. I mean, internally, it is Microsoft Turing for us. And we use those to generate creatives and test those creatives on their behalf. We automate bidding agents for them. So when you look at your product, you don't have to step off and go somewhere into the woods to do data science for good. You can do data science for good with the product that you have, with the customers that are using that product. So that's where I wanted to first start with. That's empathy for the data. And the second thing I wanted to ask you to do is to have ambition. Ambition about the tools you're using, ambition about the infrastructure that you're using, and always push the boundaries of that ambition. I'll start with A/B experimentation. For many of the large organizations that work with lots of data, experimentation was the key breakthrough that we had. We ran thousands of experiments. Very quickly, as we built the A/B experimentation platform, say you have 1 million, 2 million sets of users, you're running experiments on them. We quickly realized we ran out of users to run experiments on. The first challenge that we had was, now can I run multiple experiments on the same user? And we figured out how to do that. If you have orthogonal hypotheses, you can run multiple experiments on the same user. So you, as a user, Google, for instance, or Microsoft is running multiple. They may be running a UX experiment. They may be running a placement experiment. So they may be running different types of experiments on the same user. Now, we wanted to push that a little bit more and see, now, if you have a lot of correlated hypotheses, do you really need to run discrete time-bound experiments? If you're working in contextual bandits or reinforcement learning, you know that you can weed out hypotheses as you go around. Now, if you can do that, this means the scale of your experimentation just grows. Now, tying these two concepts together, we're trying to do that right now with UX experiments. This is pushing the boundary of what the current platform gives you. And I want you to use this type of, I think the first speaker asked, what are the questions that have not been asked? Oh, she's already cutting me off. I would say all of you, please ask the questions that have not been asked. Thank you.
Thanks so much, Rukmini. Yeah. You can tell we put someone on stage like that. There's a real danger because she will just talk and talk and talk. She's so passionate. She will be around for reception. So we've reached the end of an amazing day. The Hop-In people have already moved to Career Expo and networking for another hour. We have till 6 o'clock the opportunity to celebrate with each other and talk to each other. I'm looking forward to meeting many more of you there. I wanted to just say, I don't have to say much after Rukmini and everything else that you've heard today. I just wanted to say today, we started today to focus on what we can do. And all I'm going to ask you is carry that forward. So important. Focus on what we can do. Focus on the community we're building. Focus on all the connections that we can make. And I just look forward to hearing about your exploits and your adventures and your successes and failures in data science. Thank you for being here today. It was fantastic. Really enjoyed it so much. And I look forward to seeing you there at the bar and have some food. So again, thanks to everyone. Thanks to you. Wonderful day. One little thing. For those of you local, these centerpieces on the table, they're for grabs. Take them with you.